Welcome to the Walrus Class SSK subbrief. Above all else must not be detected is the submariner axiom. Many messages have been signed off by admiralties around the world with that statement after giving orders to go in harm's way, essentially, and do something clandestine. And that is the mantra of the Royal Netherlands Submarine Force. They do things in a very clandestine, quiet way that never makes it out into public. They don't brag about it. And to a fault, they often don't tell us NATO allies about their operations. I was shocked at the amount of information I was able to learn about their operations that, as an active duty submarine person, I'd never even known about. So, Dutch submarines often work alone. Now, that's not unique to the Dutch, but they don't work with fleets as much as, say, the United States Navy does. They have a very small submarine force of only 6 submarines, 4 of which are this Walrus class. A lot of times 1 or 2 of those are in maintenance or some sort of modernization upgrade period, and that leaves only a handful to actually go out and accomplish their objectives. A lot of times that is covert intelligence gathering, and it's hard to do whenever you're in a fleet, so they often send these submarines off by themselves, which is a compliment to the professionalism and capability of the sailors of these submarines. Mission requirements necessitate complete secrecy, even from NATO allies at times. An example of this is in 1989, there was a NATO exercise of which the Royal Netherlands Navy had a surface ship as a part of it at the Strait of Gibraltar. We were practicing escorting ships safely through the Straits of Gibraltar. So NATO and other countries chartered huge cargo ships with no cargo on them, essentially, just to go back and forth through the Strait of Gibraltar for about 5 days. And we would practice escorting them, and we'd also have a Red Force practice attacking them. Well, unbeknownst to any of us involved in that operation, they sent one of their Zvezda class submarines through the operation and pulled into port, so that when the operation was complete and everybody involved in it pulled into port, there was this Royal Navy submarine already sitting there that had moved through our op area completely unbeknownst to us. So kudos to them for pulling that off. But that is the kind of sailors we're dealing with. Very capable, very quiet submarines, and they're not afraid to do something like move through a NATO exercise without telling us. So independent operations are expected with the Royal Netherlands Navy Subforce. Okay, so the Walrus story begins in 1974 with this defensive paper talking about replacing the aging Dolphin-class submarines, which was the ones they had back in the 60s, and the current Zwaardvis class, of which they have 4 at the time. They're going to reduce that to 2. The 2 most recent ones will stay active duty, and they want to build, a Walrus class of 4 submarines to complement them. It's going to be conventionally powered. There was a brief time during development and early talks where the Walrus class could have been a nuclear-powered submarine. But by the time the planning was finished and the construction had begun, it was going to be a conventional submarine. It didn't stay nuclear for long. However, that was an option early on. However, it was going to incorporate a lot of modern designs, like the teardrop-shaped hull. It's going to have double hull construction, an advanced X-shaped radar, which for the time was very, very new. It's going to be made from French steel, special high tensile strength steel that they use to make submarines out of. It's going to displace about 2,800 tons, and it's going to have both blue water capability and shallow water capability. It's got to have both. And the X configuration rudder is just an indication of that's what they're thinking of whenever they put that on. We'll talk more about that later on. And a primary mission is generally going to be intelligence gathering with a wartime blue water capability. All right, all 4 of these are built in the Rotterdam Dry Dock Company in Rotterdam, Netherlands. It's a large shipbuilding company. It's been around for ages, and they're going to construct all 4 Walrus-class submarines there. All right, so here's some pictures of the Walrus Hull 1 under construction. There's the initial hull rings, if you will, being mounted together. Here you can see that they're building them 2 at a time. You've got Hull 1 on the left and Hull 2 on the right, the Walrus and the Zeeleeuw. Zealy stands for Sea Lion, so I'll be referring it to as Sea Lion here on out. But here you can see how they're constructing them in pairs. So once these two are done, they'll begin constructing the next two. So the Walrus is S802. She is laid down in 1979. She's launched in 1985, but has a terrible fire in this construction building that she's in. Guts the submarine, essentially destroying all the electronics inside and all the cable runs. They all have to be pulled out and replaced with new ones, and that takes a long time. So they quietly, unlaunch her and say, all right, we're going to relaunch her years later in 1989. And then commissioned her in 1982. So because of that fire, which also damaged the Sea Lion a little bit, but it completely gutted the Walrus, the Sea Lion ends up being the first submarine actually launched in this Walrus class. So normally, the first submarine that's laid down is the first submarine that is launched, is the first submarine that is commissioned, and that's where you get the name for the class of the submarine. That is typical among all navies. Well, in this case, we're staying with the Walrus class name, even though it's not the first one commissioned. The Sea Lion is commissioned in 1990 there. And I absolutely love this photo of her coming out of the building and into the little area there where she's going to be moored pierside for more testing and equipment installs. But great photo. So here's the X-rudder I was talking about. Again, when this was planned and brought up in 1974, designed and built in the 1980s, this was a really revolutionary way of thinking about controlling a submarine. Because at the helm, the helmsman, often called a pilot in today's terms, drives the plane like it's an airplane. He has a rudder and a stick, and he pulls back and left and right like he's flying an airplane. Because when the submarine is submerged, you're essentially flying it, but it's underwater. But imagine, if you will, if the wings of your airplane, instead of being horizontal to the ground, were canted at about a 45-degree angle all the way around. So whenever you pull back on the stick to go up, it actually pulls you to the left and up. It does both. So they have to have a computer system that will translate simple joystick commands, control stick commands, to get the desired effect to the rudder. So whenever you pull back on the stick, it gives it a little bit of rudder 1 and a little bit of rudder 2 so that it forces the submarine straight up instead of at an angle. Well, it takes a computer to do that, and a computer to translate those things. And so that had to be invented and installed and tested. And that was a big part of this program. I also want to point out to you where the rudder pivots. These entire surface planes act as both stabilizing stern planes that do not move and rudder surfaces that do move. And it essentially bisects each one of these rudder blades in half so that the outer tip is the only part that pivots. All right, Hull 3, S808, the Dolphin. She's laid in 1986, launched in 1990, and with no fires or problems is commissioned in 1983. Here you can see a great photo of the inside control room. This is after modernization, of course. The fourth and final hull is HNLMS Bruneviz S810. Her keel is laid in 1987. She was launched in 1992 and finally commissioned in 1994. And she's the fourth and final of the Walrus submarines. Now, before we go into their equipment and their operational history and everything, let's talk about what these four submarines are in today's terms. Well, they displace, like I said, 2,800 tons. They're about 223 feet long, 15 feet abeam. Standard ratio, very similar to a 688, but a little bit smaller. But the ratios are about the same. She drafts about 23 feet, so that's how much is below the waterline whenever she's sitting but next to the pier, 23 feet. And she has three of these 2,100 horsepower, 12-cylinder, 4-valve, V-shaped marine diesels called the SEMPs. And those turn 3 alternators, generating 2.88 megawatts of power. It's a lot of power whenever you're running all three of these marine diesels at the same time. And these alternators power the battery. They go to the battery, but they can also go, in addition to the battery, to this Holec electric motor, which turns that 2.88 megawatts to a maximum of 6,900 horsepower. So 6,900 horsepower is what the submarine has pushing the shaft. One shaft of 5 skewed blades, pushing the submarine through the water at about 20 knots submerged. And she has an average surface range, or average range rather, of 10,000 miles if she averages a 9-knot speed of advance, an SOA. She can go out to 380 mile range submerged at 4 knots, which is great. So that means she's got good batteries. It can go a long way at a very slow speed, and she has a test depth of about 1,000 feet. Now, as far as equipment goes, she did go through a upgrade period and a modernization period. So we're going to talk about how the Walrus is today and time of this recording. So she has the Signal surface search radar. Whenever she's on the surface, she can put that up and take a look around. What submarines will often do, if they're required to use the radar for safety of navigation, peacetime safety rules, they will go buy off the shelf at a marine store, where you go and you buy, things for your boat, and they'll buy a Furuno radar, just a common civilian radar, and use that instead of a military radar, so that when the submarine is on the surface, she, to other electronic sensors, looks like just any old other sailboat out there running a little short-range navigation radar. But the military version is this Signal ZW07 surface search radar. Thomson Sintra Octopus sonar is basically the export version of the Deuce 5. It is a very good sonar system, and because of this, she doesn't really need a towed array. What this new Octopus sonar system does, not only is it active and passive and medium freak and low freak, it has hydrophones down the side of the submarine in these big panels. And it's got very good long-range detection for even quiet submarines that she's looking for. So she essentially becomes a self-driving towed array with this Octopus sonar. So even though in the earlier versions they had the ability to have a towed array and a tactical short-stay towed array that was very similar to the ones the Royal Navy used, she doesn't even need it anymore with the Octopus sonar, because she has the wide aperture arrays mounted along the side of the hull. So she's her own towed array. 4 53-centimeter bow-mounted torpedo tubes. She can carry 20 torpedoes in the torpedo room. It's actually 16 plus 4 in the torpedo tubes. Or she can have up to 40 mines. She can, by 2020, well, actually by 2014, shoot the Mark 48 Mod 7 Sea Bass, which is one of the newer capable Mark 48 ADCAPs, advanced capabilities, and has a crew of 52 people, of 7 officers and 45 enlisted. The Royal Netherlands Navy does encourage mixed crews of men and women, and right now men and women serve shoulder to shoulder on these submarines. Anyway, so what do you do whenever you build 4 of the most capable conventionally powered submarines in the world? Well, you invite the Queen. That's what you do. The Queen came down for a visit in 1993. Here's HM Queen Beatrix touring 2 of the submarines that are out there. You can see her smiling face going down into the hull. That's because she hasn't got a whiff of how bad it smells yet down there, but she's being very royal and presidential and pomp and circumstance. And I absolutely love these pictures. It's very cool to see someone like, a queen coming down to tour the spaces of just a common submarine. And there you can see another picture of her coming through a watertight door, it looks like, into another room. And by the expression on her face, she has begun to realize just how bad these submarines can smell. A mixture of human sweat and diesel oil and electronic fumes is quite the cocktail. So weapons load. Here's a weapons load of one of the Walrus class. This is happening, it looks like, in Den Helder. By the way, one of my favorite ports. Pulled in Den Helder a couple times and absolutely loved it. But here they are, pier side, and they're loading the torpedoes in the American style. This is something that a lot of American and NATO boats do, is we load them from the top, which means you got to gut the forward part of the submarine to get it down to the torpedo room. It's a very difficult, labor-intensive thing to set up. Once you get it set up, they load pretty fast. But you basically have to rip out the forward compartment, the top 2 decks, to get down to the third deck in the torpedo room and load these. There's essentially a sled that slides all the way down. It's hydraulically, braked and pushed back up again. And you just lower these down by, releasing some of the hydraulic pressure, and then gravity kind of pushes it down. And then once you have it in place, you push the cradle that is holding the weapon all the way back up to the top where the crane can come over and place another weapon on the cradle. So on the left-hand side, you can see a couple torpedoes, and I want to talk about their color schemes. Apparently, the Royal Netherlands Navy uses a different color scheme than what the United States Navy does, but it's a very similar pattern. So based on not the color, but the pattern that they've painted these torpedoes, the blue torpedoes appear to be war shots. And then the safety orange torpedoes, those are either shapes that they won't even eject, they're just there for ballast, is what it looks like, or those could actually be exercise shots that they will eject and will run for a short period of time as if it was a real torpedo. But that's the difference between those two. And the canister you see being lowered on the right-hand side that's yellow in color, that is a harpoon missile. That's what a harpoon missile looks like when you're loading it onto a submarine, because what the submarine will do is eject that entire canister all the way out the bow. And the canister is balanced in such a way that one end is slightly more negative than the other, causing the canister to go upright once it's outside the submarine. It's also very positively buoyant, so it rapidly goes up to the surface. And there's a little sensor on the light end of the canister. As soon as that sensor doesn't have salt water connecting it anymore, so it assumes that it's at the surface and there's air there now, it fires the rocket motor that boosts the harpoon missile out of the partially submerged, at that point, canister. Yeah. So the booster rocket motor ignites, pushes the missile out up into the air where it kind of noses over, so it's horizontal with the sea. By about that time, which is about 4 or 5 seconds, the booster motor is gone, is expended and dropped, and then by that time there's enough speed to force the turbofan that propels the harpoon the rest of the journey to have started and keep it going, keep it in flight. And then this canister that's left in the water, without the missile in it, fills with seawater, becomes negatively buoyant, and sinks down to the bottom. It becomes a little reef for all the little crabs down there. So that's kind of how the harpoon missile works. Very different than the VLS you see on other newer submarines now. Obviously with VLS, the tube stays with the submarine because it's part of the submarine. But in submarines that don't have VLS, this is how that works. Sensor, weapon, and command systems. So I talked about the modernization and life extension program that the Walrus class went through. The biggest improvement she had, in my opinion, is this command sensor integration. They've integrated sonar with radio, with fire control, so they can read radio messages, watch the periscope, and listen to sonar contacts all at the same seat. All these functions are available to all these operators. Now, under normal operating conditions, you'll have your sonar stack where your sonarman is sitting doing his thing, and next to him is probably another sonar operator, to be honest with you. You probably have 2 of them. And then next to that guy, you probably have like a weapons officer or some kind of fire control who's taking that sonar data and putting it into a solution so that there is a mental picture, if you will, 3D picture of the area around the submarine while it's submerged. That's where that happens. And then next to him, you honestly could have anything, because these are multifunction consoles. They can do any console can do exactly what all the other consoles do. So, but you'd probably have like a radio one for message traffic. The captain has his own. Matter of fact, that's the one on the left-hand side of the photo looking back at the camera. That is the approach officer console, which in time of war or in a battle, that's going to be the captain. But if you got a snapshot right now, you don't have time to wake the captain up. Well, it's going to be whoever the officer in charge is or the officer of the deck is. It's going to have that console. And a lot of times on that console, whenever they're underway, that's where they'll have the fusion plot, where they'll fuse all the contacts, whether it's a radar contact or a sonar contact. all the solutions for all those contacts will be on that display. So at a glance, anyone really in the control room can look at that display facing back towards the camera and just get a quick snapshot of what's going on outside the submarine. That's the purpose of that. It's a very good display. So highly advanced computerization of weapon integration, like I talked about, extensive automation for target management. Yeah, the computer has a little, I don't even want to call it an AI, but it's like an algorithm that will attempt to solve any context motion into a range speed, range speed course solution automatically. A lot of times it gets it wrong, but it's a starting point. You can usually take that automated solution and tweak it into something a little more actual. It also integrates that signal radar I told you about and the octopus sonar. These walruses are towed array capable, but they didn't even always go underway when they had the towed array tube before the modernization, and now they don't even need it. But technically, the system is towed array capable. Let's see, weapons. Oh, let me talk about that for a second. When would you want a towed array? Well, you definitely want a towed array whenever you're doing blow water operation and you're going out to track things in deep water. But a tactical towed array is not very useful in very shallow water. It can actually be a liability if it gets caught on something. So if you're doing shallow water operations and you're not going to be doing any blue water operations, you may choose to not go underway with a towed array. Plus, the amount of time it takes to install it and attach it, that's time away from mission. So, or you got to do that beforehand and then after the mission. All right, let's talk about the weapons real quick. They have the Mark 48 torpedo. Mod 7 is the most recent one that I'm aware of that they can shoot. It's a 50-knot torpedo, plus it goes much faster than that. 21 miles is the public unclassified range. If this thing gets within 20 miles of you, it's going to hit you. It has a very large warhead. It's designed to break a ship in half. Well, let me break that down. It doesn't literally break the ship in half. It does break the keel in half, which is the center point of the ship underneath the water, right? And that keel is the foundation on which the entire weight of the ship, everything above it, kind of rests. So if you break that foundation, the ship's weight and the motion of the water will saw itself in half. So the idea is to break the keel and let the ocean do the work. That's kind of the theory behind it. The Harpoon missile is their other major weapon, 550 miles per hour. With the extended range mod, she can go over 150 miles, and she carries a 488-pound warhead. But the big thing that the Walrus class is really known for is working with special forces, special operations. The Netherlands Navy has a great Marine Corps that work with the Walrus class, but because they're part of NATO, they've worked with Navy SEALs too. And so they do a lot of operations, both real and for practice, with special forces. She is mine capable as well, capable of laying mines. But I couldn't find any sources of where she had ever even practiced that. So if she did, she's just keeping that a really good secret. But let's just acknowledge that modern submarines in today's age can lay mines. They just can. Okay, so the modernization program began in 2008. Remember, these were built in the early 90s. So, this is almost 15 years into the program by the time the modernization program is coming along. And that's designed to, technology has changed a lot from the 90s to the 2000s. And so they want to have the better processors, better sensors. And that's what is happening in 2008. But in 2014, they decide that they've already made up their mind to buy a new class of submarine. And we'll get to that at the end of the lecture. But they need to keep these 4 walruses going until they get the new submarines that are coming. So in 2014, they began a service life extension that is going to allow the Walrus class to operate in a very competitive environment. In other words, win wars, win battles through 2030. At least, probably going to be even pushed back after that, because that's how these things go. They always ask too much of these military vehicles until they just begin to break down. And the sad thing about a submarine breaking down is if it happens at sea, that could include the loss of the submarine. We've seen that. So But yeah, they're going to get as much out of the Walrus class as possible. And as long as they maintain it and they continue these surface life extensions, they could probably go into the 2030s as well. But they don't need to, because they have a plan to replace the Walrus class. But let's take a minute and acknowledge some of the operational accomplishments the Walrus class of submarines have participated in, because they have done a lot, really, for NATO and for themselves. They are a great, capable naval ally. Very, very impressed. And keep in mind, this is 4 submarines we're talking about here. They do a lot. So just from 1994 to 2006, before their first modernization period, they were involved in the Yugoslavian wars, which is really strange for me, because I was underway for a lot of this. So I didn't know much about the Yugoslavian wars, other than we were involved in this intel gathering as well. But as a lowly sailor, a lowly sonarman, they don't tell us anything. So we were not briefed really on what was going on, but they were with us near the coastline of Yugoslavia, collecting intel, just trying to see what was going on, because there was fears of genocide and things like that. And that war went on for about 6 years. It was a huge, there was a delayed peace process, let's put it that way. But part of the war got really, really ugly. And they were part of collecting the information that our government leaders were making decisions based on. So good job to them for doing that. In the 1990s, and this really began in the 80s, the Royal Netherlands Navy really began focusing on operating in the Mediterranean Sea. In the 90s, that was very well justified, because Russia had collapsed and they did not go to sea very much at all in the 1990s. I was very fortunate to have the encounters that I had, because that was not the norm in the U.S. submarine force to come across Russian submarines, because they just didn't go to sea very much in the 90s. So they rightly so shifted their focus down to the Mediterranean Sea and Persian Gulf too. They did all sorts of things. In other words, this submarine has not only a lot of capability, it has a lot of range. So they did intel gathering missions in the North Atlantic and the Mediterranean regions. And in 2002, they even deployed to the Arabian Sea, which is right outside the Straits of Hormuz. And I have one report saying that they did go through the Straits of Hormuz. And they probably didn't tell anybody and did it submerged, just like they did the Straits of Gibraltar, because that's how they operate. In 2006, they followed a Russian battle group in the Med. Yeah, that was fun. That was a big feather in their cap. They could have sank the whole thing. They could have taken them out. 2006. So operational history from 2007 to present. This is with the modern equipment. The modernization program is complete. The life extension program in 2014. After that is complete. In 2007, they deploy to the Caribbean Sea and support marine operations. That's also like SEAL Special Forces operations at the request of the United States. We asked them to come over here. We have this war on drugs. The Caribbean is a big halfway point, or, pausing point, loading point, storing point of drugs before they come into the United States and Mexico. So they came down and they helped us with that. So that was a big help to us in 2007. Plus, that's just demonstrating their versatility. They don't just need to go out and collect intel on Russian states and ships and do deployments to Persian Gulf. They can come over to the Caribbean and do drug warfare as well. In 2010, she participated in Operation Ocean Shield. Yeah. It's off the coast of Somalia. So she's out there protecting ships, making sure that they're not being boarded and raided by these little, pirates that come up in these outboard, little boats, but they have AK-47s. What are you going to do? Guy comes at you with an AK-47. You're going to do what he says, right? So they were out there just quietly making sure that didn't happen in their little area of the operation. In 2016, she did shadow a Russian amphibious battle group in the Eastern Med. It's way over there by Turkey and Syria. But this time she was detected, unfortunately. But when they found her, she was only 11 miles away from the Admiral Kuznetsov, which was the Russian carrier. The Kirov was in the battle group as well. She could have sank both of them easily. 11 miles away, she's easily within weapons range. 4 ships could have been targeted and destroyed even after she was detected because she was so close. But they got out there with their little helos and escort ships, the Utiloys, and chased her away because they found her. But she's out there causing trouble for the Russians, which we appreciate. And present day, she operates in the North Atlantic and the Med with a focus on Russian naval operations and intel collection. Because recently, up until 2021, so up to 2020, Russian naval operations have been on an increasing tempo year after year. So it's kind of the reverse of the 90s. It's almost 1980s level of submarine deployments. It's not quite that high, but it's getting back to that. So because of the increased activity closer to their home ports, they began shifting more towards North Atlantic, Norwegian Sea operations, by which they're very good at that too. So just a quick response to Russians' naval operations that have been happening recently. And she is also a member of the Submarine Command Course fleet. So we will use her. We use American submarines, Royal Navy submarines and Royal Netherlands Navy submarines, among others, Canadian submarines, for this command course. And what this is kind of an international course where officers from all sorts of navies like Brazil and even Korea will come over as a command qualified prospective officer. He's not a prospective he's not a commanding officer yet, but he has to graduate this course to finish his qualification. This is like the final step. This is the final board examination, if you will, the practical factor examination. And they'll go underway. It's usually, if I remember correctly, it's only a week. And they'll have 3 or 4 of these prospective COs. And they're not in competition with each other. They can all 4 pass. So that makes things a little more professional and nice. It's not ruthless like you may think it would be. And we'll go out on the range, just a designated piece of water that they keep all civilian traffic out of. And they'll come at him with everything, man. I'm talking surface ships. Sometimes there's another submarine there. There's always aircraft. And they have to stealthily complete all these objectives. One of which is usually infiltrating a port, submerged, which is flipping dangerous, but infiltrating a port submerged and then just raising a masted antenna, taking a photo, and then simulate collecting intel for a period of time, 5, 10 minutes, an hour, however long. And that's all up to the schoolmaster, the guy that's running the program. He's there too, by the way, kind of as a safety officer. So usually the captain of the submarine, who's responsible for the submarine, of course, he can take over the periscope and the whole operation at any moment if he feels as if his crew is in danger and the submarine's in danger, because accidents have happened on this course. Collisions have happened. It's just part of life. And then also usually an admiral, usually it's like a rear admiral or a very senior full bird captain is running this submarine command course, can jump in at any time and take over. But it's a very interesting time. I did a number of these in my time in the Navy, helping relatively senior officers take that next step towards a command. And it feels good whenever they get it done right. There's a lot of pressure on the enlisted men, I should let you guys know, to perform at our absolute best for these guys, because even if they're with another Navy, it doesn't matter. It's a matter of professional pride, one, to help them succeed. And these are a lot of fun because this is the closest thing you'll get to a wartime scenario without actually getting shot. So those are always good times for all hands. All right, so let's talk about the next step. What is next? What is the next submarine for the Royal Netherlands Navy? Well, in 2014, they decided that they were going to extend the life of the Walrus, like we talked, to 2030, but we got to start looking for a new sub. And there's 3 subs on the table as of 2021. Okay. And there's a few of you out there that are like, well, what about that 4th one? We're not even going to talk about it. Okay. Because it's no longer on the table. This is a recent change. As of 2021, time of this recording, there's only 3 remaining. The A26 AIP is a base model of which Dame Group and Saab Group want to get together and make a new version of the A26 for the Netherlands. That appears to be the favorite choice right now, but you really never know with these contract talks because money talks a lot and it's also very political, unfortunately. It's not always about getting the best deal or even getting the best submarine. Sometimes it's about making the best friends with your near neighboring countries. Sometimes that's part of it too. And that's where DCNS comes in, or Naval Group as they're known now. It's the French short fin Barracuda. This is the short fin Barracuda that they're providing Australia in 2030. They said, hey, we could build you a couple of these too. We're starting to, pump them out now. We could make Netherlands a couple of these. So that's option number 2. And then the final option, and not by any means the last option, are the Germans. The German ThyssenKrupp Marine Systems wants to build them the Type 212 CD. And there's a picture of it there. And the Germans have a great history of building great submarines. I mean, going well back, even before World War II. So obviously they are a very serious competitor. And this is the choice that the Netherlands has now. The Senior Admiralty, the political leaders, they need to go through the process of deciding which one of these projects will they go forward with. And, we'll see. Hopefully they make a really smart decision that's good for the country and the sailors and the people of the Netherlands. All right, so my final thoughts on this. Man, I love the Walrus submarine. I was very young in the Navy when I first came across the submarine, and I was a little dismissive of her because we were in our Fast Attack 688, all new and shiny, and we just had come back from a very cool mission, and we were pulling into Den Helder for a week, ladies and gentlemen, 7 days. That's unheard of. The only reason why we got 7 days in Den Helder is because we had just done something incredible, and it was like a reward for the crew. Anyway, enough about me. Highly adaptable submarine. I have quickly come to love the Walrus submarine in my career. She's deep water, shallow water capable, so she's very versatile. She can do just about anything, and she's super quiet. I can't stress that enough. Of course, all submarines are quiet, but she is so quiet. She could be right next to you, and you wouldn't know it. And that's why she's so good at those shallow water operations, getting very close to land, because you want to get as close as you physically can without running aground to get those special forces divers on and off your submarines. You don't want to exhaust your special forces before they even get to the mission on land, right? You want to help them out by getting as close as you can. And so she's very good at that. It's a very well-controlled ship, easily, ballast and maneuvered, especially with that X rudder in the back, and very good at special forces operations. She is a perfect submarine for training prospective commanding officers because she's very nimble. So she gives prospective COs the advantage of stealth and the ability to get very close to targets, and they have a wide margin of error. Let's say a prospective CO is on a 688 nuclear powered submarine that dives at a certain rate. It's not as fast as, say, the Walrus dives. Well, the Walrus can get closer to a submarine before it begins to violate safety rules, and before the CO has to take over control of the operations. So there's a lot more forgiving aspects to this submarine compared to, say, a nuclear submarine because of how well it handles. It's a very good submarine, a very good design. All right. She has a very aggressive deployment schedule, which I, as a sailor, appreciate. These 4 submarines, they have 6 total in the fleet, but there's only 4 Walrus classes, are aggressively at sea a lot, even through their modernization period, where 2 submarines at a time, a third of the whole fleet is ashore for long periods of time, leaving the remaining submarines to pick up the load of the operational tempo. And they did. And they've done it for decades now. So my hat's off to the crews, the people that maintain these submarines and the way that they operate them. You never hear of an incident with a Walrus class submarine. And it's not because they're not going to sea. It's because they're very good at what they do. And they don't tell you about it. Welcome to the Scorpion Subbrief. Today we're going to talk about one of the most popular export submarines in the world right now. 11 of these Scorpions are built and operated by 4 different navies, all in the southern hemisphere, ironically. So if you're operating in the South Pacific, South Atlantic, or the Indian Ocean, there's a chance you may come across one of these. Now, because they're operated by 4 different navies, each variant for each country is a little bit different in terms of equipment, and we'll be going over all those individually. Some things that the submarine Scorpion class share amongst all of them are the 6 torpedo tubes that it operates, a very capable sonar system, and the NVIDIA Exocet cruise missile Block 2. The very first of these Scorpion class was commissioned in 2003 for the country of Chile, but since then they've been exported to India, Brazil, and Malaysia as well. The Scorpion class is a joint venture between France and Spain and their respective military industries called Naval Group for France and Navantia for Spain. So they're built in those 2 countries as well as the countries that are operating them. Here are the countries that received the export version of the Scorpion. On the left, we have Chile. They have the O'Higgins and the Sarara. Malaysia operates 2, the Tunku and the Tun Rask. India operates 5 of these, and Brazil operates 2 of these, the largest of which has been exported to Brazil. There's displaced the most water. So let's begin with the sensors here. They all have the SAGM I-band navigation radar on the mast, but Malaysia and Brazil operate the Talos DR ESM electronic support measure equipment. Chile has gone with the slightly less expensive AR900 ESM system. For sonars, they use the Talos S-Cube sonar suite. The reason for that is a modular sonar suite. You could have one array, you could have multiple arrays that cover 360 degrees of coverage around your submarine. It is up to the Navy and the country to determine what version of the S-Cube sonar suite do they want. Included with the S-Cube on this submarine is the TSM 2253 Planier Flank Array, which is a fantastic flank array that goes down the port and starboard sides of these submarines. As far as countermeasures go, India has spared no expense and has gone with the Leonardo C303 torpedo decoy launcher, and Brazil has employed the hard kill anti-torpedo system called Contra Alto S. And I'll show you some pictures of how those work. That was an extremely secret program when it was in development, but now that it's in operation, it's some information's come out about it, and we'll talk about what we can. They all shoot the Exocet Block 2 anti-ship missile from the bow, and they fire either the heavyweight F-21 French torpedo or the Black Shark heavyweight torpedo made from Italy. And Malaysia and Chile shoot that Black Shark torpedo. Here's a list of all the ships and when they were commissioned. As you can see, they are manufactured at multiple different sites. India builds their own in Mumbai. Brazil builds their own. And there was a time when Brazil was fooling around with the idea of making the S-40, the Richelieu, a nuclear-powered submarine. But since it's been commissioned in 2022, and I have no further information on them trying to make it nuclear, I assume that it is still a conventionally powered submarine. But that's an interesting little twist to the S-40, one of 2 that Brazil operates here. So even though these are made and designed by France with Spain engineers as well, they are built in Cherbourg Naval Group in France and Cartagena Navantia in Spain. India builds their own out of Mazagaon Shipbuilders. And I want to pay note to the picture in the lower left. You can see the Indian flag covering the flank array going down the side of the submarine there. That's where that flank array goes. And Brazil has their own small shipyard where they build and maintain their 2 submarines. All right, so the Scorpion class by the numbers. This will be a little confusing because there's 4 different variants here. So I've tried to simplify this. Malaysia and India use the peel stick 12-cylinder marine diesel. They have 2 of those. If a country is not operating those 2 peel sticks, they will operate 4 of the smaller MTU Rolls-Royce 12V 396 engines. Those are physically smaller, so they can put 4 of them on, and they produce 4 of them produces the same amount of power as 2 of the larger peel stick ones do. So it's a 1-to-1 push, just different countries went with different layouts for their marine diesels. So I should mention that the Cavalry class did intend on having air-independent propulsion installed on at least one of their Cavalry class submarines. That went horribly wrong, but I believe that they still intend on doing that. So there's a potential that at least one of India's 5 that they operate is air-independent, but that has not been confirmed as completed yet. So that's still out there as a potential. They could easily change their mind and just leave it diesel electric like it should, like it's been designed to be. But there's possibility of one being air independent. So max underwater speed is 20 knots. On the surface, it can make 12 knots. And it has a 6,500 nautical mile range at 8 knots. And that would be 8 knots surfaced, by the way. Okay, can shoot 18 weapons. So it shoots either a heavyweight torpedo or an exocet missile. It could have 18 exocet missiles, or it could have 18 torpedoes, but not both. So each submarine has weapon stows for 18 weapons. It does have 6 torpedo tubes. Those are 53 centimeter torpedo tubes, which means that they can shoot all the NATO ammunitions, you know, whether it's the Spearfish, would physically fit in their torpedo tube. And as well as the ADCAP. They just don't have the software to launch those types of weapons, presumably. But the fact is that the hardware can physically shoot those weapons. So a software install wouldn't be that much of a difference. It would be a huge upgrade in capability, but it's not that hard to do. I-band navigation radar are on all of them. It's a standard SAGM navigation radar. The Talos S-Cube sonar system is really interesting. We'll get into that here in a second. That's coupled with the flank array that I talked about. When you do that, you make your submarine extremely valuable. It can see a very long way across the oceans. The Leonardo, which is the Italian version, C-303 torpedo decoy launchers, is operated by India. And then the Caltralto hard kill torpedo defense system is operated by Brazil. Talos DR3000 ESM, or electronic support measure, is operated by Malaysia and Brazil, and the AR900 electronic support system is operated by Chile. UDS is the International Subsonic Weapon Control System. Basically, it groups all the sensors to the fire control system, including radar and communications. It's basically the heart of the submarine, linking everything together and making it usable to the operators and understandable to the officers. Here's that peel stick marine diesel. This one's operated or manufactured by MAN Diesel Group. It's very large compared to the other submarine diesel engines, but this makes a lot of power. It makes just under 2,000 kilowatts running at 1,500 RPM. Very fuel efficient, water cooled. IOC'd all the way back in 1962, and it's still used today on brand new submarines because it's such a great, efficient, low maintenance, low cost design. If you can fit this on your submarine, most countries go with that. But if you can't, for whatever reason, you don't have the floor plan for that large diesel, you can get the smaller Rolls-Royce marine diesel called the MTU-12V. And this comes in different configurations. You can get the 8V, the 16V. Those are all different cylinders, but they're all in a V configuration. And each engine will produce 12 kilowatts at 1,800 RPM. That's why they have 4 of these, so they can get up to 4,000 kilowatts, just like the submarines operating the other diesel engine with only 2 can produce 4,000 kilowatts. But again, the service time on this is very low. It's very easy to maintain, and it doesn't require much once it's up and running. This IOC'd in 1990. All right, here's the S-Cube sonar system by Talos. This is modular, which means you could have one of these arrays or you could have all of these arrays. It is a combination. It's like Legos. So up front on the bow, you're going to have a conformal array or you're going to have a cylindrical array. You could even have both if you have the room for it, but you wouldn't really need both. That's going to give you 360 degrees coverage of everything in front of you and to the sides, but you will have what's called a baffle region where it literally can't see through the submarine behind it. So that's why you have these other arrays. The flank arrays, that run down the side are extremely good. And because you have one on the port side, one on the starboard side, the flank arrays alone will give you 360-degree coverage because the beamformer combines those two flank arrays into what is digitally a large sphere all around the submarine. So those are key and are on every single one of these submarines. Now, something that's very optional because of the flank arrays is a towed array. And you have every possible towed array option you want. You can have a clip-on towed array, which means when your submarine leaves port every single time, it's followed by a tugboat until it gets into a little bit deeper water. And then they physically clip a towed array onto the back of it that's strung out 500-600 feet. And then you go to sea with this towed array behind you. The problem with that is when you return to port, that tugboat has to meet you in deep water, find that towed array, fish it out of the seas, and unclip it from your submarine before you can pull in. Otherwise, you'll be dragging it through the mud, destroying the towed array. That's a real maintenance pain. That's why most people go with the reelable towed array if they have the space for it. That's usually stored inside a ballast tank, the entire kit, the winch, the motor, the towed array, stowage drum itself. If they have room inside an aft ballast tank, they'll usually go with that one if they have a towed array at all. Now, as far as the towed arrays go, they can have passive towed arrays and active towed arrays. They can have a towed array that pings active, and then they use the rest of the sensors to get a bearing off that ping. Very multi-function, literally, sonar system. The S-Cube is designed to be very flexible and fit on any submarine from 500 tons, which is very small, to 3,000 tons, very large. Here's the plan of your flank array, and each one of these panels you see the technicians bolting on is very good. It's long range, it's sensitive, it's wide frequency bands from 0.003 hertz, very low, all the way up to 10 kilohertz. And then when you pair it with a second one, and a third, and a fifth, and a 10th, and a 12th, you get incredibly accurate bearings at very long range. This is a fantastic array. This array alone, in my opinion, supersedes every other array they have from the S-Cube sensor system, which technically is a different system. This TSM 2253 Planier Flank Array technically is not part of the S-Cube system, but it is paired with it because it is a nice pairing of conformal and towed array with this flank array, giving these submarines outstanding sonar performance. They can track up to 64 targets with the combat system, and 8 are an auto track, which means you assign a tracker and just let it go. It'll track the target left, right, and as it goes up and down. All right, here's the torpedo decoy launchers. We're going to start with the C303. This one's manufactured by Italy. Their company is called Leonardo. Basically, the military industry complex owned, well, it's a multinational company, but it's stationed out of Rome. So they identify as an Italian company. This is on the Cavalry class, the ones that are operated by India. It's an anti-torpedo countermeasure with a very strong active and passive sonar decoy capability. It also has a jam mode. It can lure a torpedo to it and then confuse it, or it can just jam and insonify the entire stratosphere of water with noise, confusing the torpedo as to where the target might possibly be. The torpedo will have to keep restarting its search because it can't see anything, much less a target. It's pretty effective. Little system. This I LC'd in 2000. Now, the Contra Alto S torpedo countermeasure, this entire program was super secret forever because it is a hard kill system. This torpedo decoy system will not only do what the other ones do in terms of jam, decoy, and lure torpedoes away from your submarine, it will also physically ram the torpedo, destroying it physically. It's a hard kill system capability. And it's demonstrated to work, which is a very difficult thing to do. Now, how it does all that, of course, is still not public, but this one is special. The Contra Alto S torpedo countermeasure is a very new technology. Of course, NATO uses it. DR3000 ESM, that's electronic support measures. ESM, I get that question a lot, so I want to make sure we make that very clear here. This is different than ECM, even though they commonly work together. ESM is just passively recording the data and analyzing it. So this covers NATO IJ bands of radars. It has the large antenna that you can see there coming up on a mast, 360 degrees of coverage, and very sensitive. Anytime you see a sensitivity of more than -60, that's kind of the threshold between amazing and awesome. So this is an amazing sonar system, or radar detection system, very sensitive. This IOC'd in 1991 and was installed on these as early as 2007. So Hull 1 didn't get it, because Hull 1 got this. The Chile export got the AR900 ESM from Argos Systems. It's a radar electronic support measure system. This is a kit that you can put on anything. And in this case, they put it on a submarine. It fits rack mounted with one display, one computer, and a keyboard, as you see here. And it has multiple sensors that you can stick, in this case, on a mast and send it up with your periscopes. And it will just automatically search. Can track up to 500 contacts. It will classify the contacts by their frequency, what kind of radar it is, how powerful the signal strength is, and its PFR rate, how fast is it updating. Because a fire control radar, for example, or an interrogation radar would update extremely fast, multiple times a second, whereas a standard search radar just sweeps regularly a lot slower. And this will give you information like that on a budget. All right, here's the F-21 heavyweight torpedo manufactured by Naval Group. This is a very large, nearly 3,000-pound weapon, but it is electrically driven, which is quite unique. This is actually becoming more common. Today's batteries are so powerful, they can push heavyweight torpedoes, whereas decades ago during the Cold War, anything this heavy would usually have a thermal engine, a gas-powered engine, essentially. But this is pushed by a electrical propulsion and is connected with fiber optics, which means it has a high data bandwidth back to the submarine as it conducts its mission. This IOC'd in 2019, a very new and highly capable 50-knot long-range torpedo. The Black Shark heavyweight torpedo, essentially Italy's version of the same thing. There's a few minor differences in terms of performance, but the big thing is it can do 50 knots as well. It's 50 kilometers range, and the warhead is 250 kilograms. It's fiber optic. It is active passive acoustic, and has a cool black paint job instead of the French green paint job. But essentially, Black Shark and F-21 are, in my opinion, the same torpedo, built and operated by different countries. Here's the Exocet SM39 Block 2 Mod 2. This is an old and well-tested but modernized and updated subsonic anti-ship cruise missile that uses a solid propellant propulsion to eject it out of the canister in this case, because it's submarine launched. And then it is an air-driven engine that drives it to the target. Its warhead is 165 kilograms, high explosive RTX. This IOC'd in 1985. And this particular Block 2 version was updated again in 2005. So modern, subsonic, anti-ship cruise missile. All right, the Scorpion class, very well-designed export submarine. Even though the French build it, they don't use it because they have a nuclear-powered version of this class of submarine that they operate. They build this one and designed it to be export only. And that is part of the reason why Brazil wanted to try and make one of theirs nuclear-powered, because the French had done it. But the French also designed it, and they know more of the submarine and how to do things like that than what Brazil knows. And there's a story in there somewhere. I'm not sure where that story ends, so maybe I'll look that up and make a video out of that for you guys, how Brazil tried to make a conventional submarine nuclear powered. As far as I know, that's still ongoing too, so that story may not have completed yet. But back to the Scorpion, the conventional class. Brazil did order 2. India operates 5. Chile and Malaysia each operate 2. A total of 11 submarines are in use today. 3 more are being built. 3 more in the dry docks, on blocks, being assembled right now. And these are still in use today. They IOC'd in 2003, and they continue to operate, all in the Southern Hemisphere. And they are very good submarines. They're fast, they have a heavyweight punch, and one of the best sonar systems you can buy out there. Very impressed with the Scorpion class. All right, that's been the Scorpion class sub brief. Thanks for listening, everybody. We'll see you next time. Welcome to the Bori class submarine subbrief. The Bori is the replacement for the famous Typhoon submarine Russia used during the Cold War and after the Cold War. This is the ballistic submarine they built to replace it and the one that they're using today. Now, the Bori comes in two different configurations, simply called Bori 1 and Bori 2, and there are significant differences in the equipment between those two submarines, but just know that it's all the Bori class. They're building 10 of these. 7 have been commissioned. 3 of those are the Bori 1, and the remaining 4 are Bori 2. The 3 that are under construction will be Bori 2 as well, for a total of 10. Now, the one thing that the Bori class has in common is that it's a ballistic missile submarine. So it has 16 ballistic missile tubes behind the sail, vertically launched, and it shoots 53 centimeter torpedoes out the bow. A lot of the equipment in between the bow and the missile compartment is different. And so we'll talk about those differences today. Let's begin with the missile compartment right behind the sail there. You can see it's a 16-cell RSN 56 Beluga SLBM launcher. Shoots intercontinental ballistic missiles with multiple warheads in each one. And on the bow, you have 53 centimeter torpedo tubes. Now, one thing I'll begin pointing out here is the Bori 1 only has 6 torpedo tubes on the bow. The Bori 2, the current one, the most modern one, has 8. They've added an extra tube port and starboard side. All right, sensors and countermeasures. Let's talk about the countermeasures on the bow. This is often confused with torpedo tubes. These brow launchers are not torpedo tubes. These are special purpose tubes. They're external countermeasure launcher tubes. They're not reloadable from inside the submarine. They do not go into the torpedo room or the pressure hull at all. They're completely external to the submarine, but inside the outer shell. And what I mean by outer shell is that this is a double-hulled submarine. What we're looking at is a steel shell over a steel pressure hull that's inside of it. And inside the pressure hull is designed to withstand the pressures of depth, and that's where the people and most of the equipment are. And out on this outside of that, is the shell that we're looking at here painted black. External tubes like what we're looking at on the bow, the brow launchers, are in the space between the outer hull and the pressure hull. The black boxes that you see going down along the side of the submarine, those are vents, free flood vents that allow seawater to get in between those two hulls. You'll notice as you go along the missile compartment, instead of having a small rectangle vent to allow seawater in, it is a long opening that runs the length of the missile compartment. That is to ensure even flooding of the area between the two hulls, the outer hull and the pressure hull. So there's no air pockets in there. You don't want any air pockets because that one can make a little bit of noise, and air compresses is the second problem. And so you don't want anything that's going to be compressed by pressure that shouldn't be. So you want the free flood area evenly flooded, fully flooded with seawater between the pressure hull and the outer hull. If we look at the sail, and we're going to go over this in detail, but you can see that they have one of the periscopes raised. That's the PCIe series of periscopes in front of the bridge. The bridge is where you see the 4 or 5 sailors standing there. And then behind them, you see the large radar ESM mast, that huge tree trunk of a steel mast that's raised up hydraulically. And on top of that is the Snoop half radar. And right below that, the beige color is ESM, a surveillance system. Take a note real quick and look how big that sail is compared to the people standing in it. This is a large submarine. We've broken down the 2 different types of sail configurations from the Bori 1 to Bori 2, and credit to Mr. Richard Stern on Twitter for supplying this for us. He drew this. In the Bori 1, you have what's called the commander scope and the navigation scope. It's always standard to have 2 scopes. The big thing is those go through the pressure hull, which is a bit of a problem. So in the Bori 2, they made them non-penetrating masts. So they're basically a camera on a pole that is still raised and lowered, but doesn't go into the pressure hull. Behind that, we have the whip antennas, the ESMs, of course, the HF and VHF communication antennas are all lowered in the picture. You don't see them, but just they're behind where that large GSM mast is. And then they have the snorkel mast. And behind that is the satellite navigation mast, which often is cone-shaped. We have a good picture of that coming up. I do want to mention the snorkel mast real quick. The snorkel mast, when it's raised, is sucking fresh air into the submarine that can either regenerate the atmosphere inside the submarine for the people to breathe, and it can also supply fresh air to the diesel engine when that's running. So I've often seen people mistakenly say the snorkel mast is for exhaust. It is not exhaust. It's actually an intake. The exhaust comes out in different areas on different submarines. On this one, it comes out the sail right below where the mast or snorkel mast is. All right, here's the mast arrangement in a 3D drawing. Credit to Mr. Stern again. I want you to take note of the green cone shape antenna. That's the satellite communication antenna that I was talking about. All right, here's the Bory 1 picture. This is in, looks like St. Petersburg Navy Day Parade. They participate in this every year, and it's often a good opportunity for OS and IT people like myself to get pictures of this. Very high definition and detailed. Nothing new in this picture, just a different angle of what we've already talked about. Here's the Bory 2. Couple differences to the outer hull. You can see that the free flood area comes forward to the sail about halfway. So it is much more than just the missile compartment there, allowing the water to get in and fill that void between the two hulls faster. That would help facilitate a faster dive time, among many other things. Great picture of this submarine at sea. The yellow antenna that you see behind the sail, that's part of a tugboat that's alongside of it. But if you look just forward of the sail, you can see that the capstan is raised, and that's where they would use the capstan to for line handling. To if they wanted to pull the submarine closer to the pier, instead of doing it by hand because this thing is massive, you would use a rotating capstan to pull the line for you. All right, so we talked about the 10 submarines that they are building. 7 are complete. They've been commissioned between 2012 and 2023. There are 3 more in construction right now in the assembly building, and we fully expect them to be done in the next couple of years. These are built in Sevmast Shipyard, that's in Russia, right there in the White Sea. That's right south of the Kola Peninsula. It's a very secure port, a very active shipyard with a very long history. They've been building submarines here for a very long time, and they've gotten pretty good at it too. They pump them out pretty fast, and they do more than just nuclear here. They can do the kilos, they can do the conventional submarines. The Lada class is built here. If it's a submarine, it's probably a version of it has been built in the Sevmast Shipyard, and probably the first one. They build a lot of Hull 1s here before they build them in other shipyards. Here's the Bory class by the numbers. It is a nuclear-powered submarine. The OK-650 Bravo pressurized water reactor makes 190 megawatts, has an OK-9 turbine, and the propulsion that moves the submarine through the water is not a screw, it is a pump jet. It is 170 meters long and displaces just under 15,000 tons surfaced and just under 20,000 tons submerged. That's with a full Beluga payload. Top speed is 25 knots submerged, 15 knots surfaced. It has a 16-cell Beluga submarine-launched ballistic missile compartment. It has 8 torpedo tubes for Bory 2. Bory 1, the first 3 hulls, only had 6 torpedo tubes. But they both fire the Test 71 and 53 series of torpedoes. The 53 series is a number of anti-submarine torpedoes of different variants that we're not going to go into each one of those. Just know the 53 stands for the diameter of the torpedoes, 53 centimeters. Easy, makes it easier to remember. It does have 6 special purpose tubes, eyebrow or brow tubes on the bow above the torpedo tubes. We'll point those out when we see them again. For the sensors, they have a pretty good sonar system called the MGK 600 Bravo. Bravo is the modernized version of this, both an active and passive sonar system. And it's pretty good. I have to give it to them. everything that I've seen with their displays and the capability of the sonar system is very modern. So they've really caught up in that area since the Cold War. They have the MRKP-59 surface search radar in the Bory 1, and they have that combo R43M radar ESM in the Bory 2. The Bory 1 has the commander's periscope, like I talked about, with the navigation scope. For the Bory 2, they use non-penetrating mast called Paris 98KP and Paris 98UP optotronics mast. Now, you might be asking yourself, what is the difference between an attack periscope and an optotronics mast or a navigation mast? And it's really the size of the head that is exposed out of the water. Whenever you're using a navigation mast, you usually have a wider field of view through the scope or on the TV screen in the case of a optotronic mast. And you're not too worried about being stealthy with that. You just want to safely navigate or safely not run into something. You want to see more clearly around you in a wider field of view with the with the navigation scope or the Paris 98UP. The attack periscope usually has a lot more stealth built into it, including a smaller head that is exposed above the waterline, and it talks directly to the fire control system. You know, you can ping a bearing with a push of a button and send that bearing to the torpedo room, and that pushes it to the whatever weapon is selected, and at least that weapon knows what direction to go. If it doesn't have any other information, at least has a start if it is used. It gets a lot more involved than that, but that just gives you an idea of why they have two. Plus, it's always a good idea to have two systems for everything on a submarine, because if one goes down, you want to have a backup, especially in critical systems that allow you to see outside the submarine, like an optotronics mast does. And the towed array is the shark tail sonar that they've had for years. Shark tail goes all the way back to the 80s, but they've improved it over time. It's all part of the MGK 600 system. All right, here's that nuclear reactor. I love this photo. It's OKBM, African TOV development. Basically, it's built by Russia for Russian submarines. It feeds 50,000 horsepower steam turbine that turns a single pump jet that pushes the submarine through the water. It is a water-cooled thermal neutron nuclear reactor, produces 190 megawatts of power, so very powerful, and uses 20 to 45% enriched uranium-235. And it's a derivative of what was used on other submarines like the Typhoon and Oscar and Yasin class. And if I'm not mistaken, this photo is actually of it looks a lot like the Yankee, but it could be modified. So yeah, as you can see, they don't change a lot in the design. They just make these more powerful. And this is the most modern one that they have here. All right, let's talk about sonar. The MGK 600 Bravo, Eardish, we called this shark teeth in the U.S. Navy. That was the American name for it, our code name, if you will. It's an integrated sonar system that does it all. It has a low frequency active-passive bow array. It has a flank array. And on the Bory 2, that flank array can actually go active as well, which is pretty incredible. And then, of course, the towed array, the shark tail we talked about. It has the whole kit right there. It is connected with the combat system, so whenever they track a target, the combat fire control system is automatically generating fire control solutions, which just means it tells the torpedo or the missile, they can shoot missiles out of the torpedo tubes as well, where to go to hit the target, right? And it's a bit of a science to get that solution just by listening to a target and watching it for a period of time. And then you use simple geometry to figure out where it is now, how fast it's going, how far away it is, and then where it's going to be by the time your weapon gets there. You have to know how fast your weapon is and a lot of other details that they would already know. Well, the fire control system does all that for them. So all they have to do is assign the tracker, wait a few seconds, and then they're ready to shoot. See, the active sonars are located on the front and flank arrays. The flank arrays on the side are for the Bory 2, and they can go active, which is, like I said, that's a very new capability. Usually the original flank arrays were all passive. The point is the flank arrays are very good, much better than the bow array. And it gives them a near 360, we'll just call it 360, view all the way around the submarine. No more sneaking up on submarines from behind with flank arrays. That's going to be very difficult to do now. It says here, this is from Jane's, that they have an estimated range of almost 130 kilometers. That is just the range modes that it has. Obviously, sonar range is 100% dependent on the environment, and then, of course, the equipment as well. Here's that Radian U radar ESM combination. NATO name is Snoop Half. So it's always fun when you get a Snoop Half detection, because you're watching the Russians do their thing. It's a derivative of what used to be Snoop Tray, which was the older version of this. But Snoop Half is a combination of radar and ESM all in one module now. ESM is a passive system, just listening, picking up radio detections. The passive detection is about 173 nautical miles. But again, just like sonar, that depends entirely on the power of the radar that's being transmitted and the conditions topside. But just think that 173 nautical miles would be the maximum in ideal conditions. Active detection can be as much as 108 nautical miles away. That's certainly capable. The power of the active on the sonar system can certainly reach that range, absolutely. But again, it would have to be deep water Pacific Ocean or deep water Atlantic. You're not doing that in shallow water. All right. So here's the R43M, a radar ESM complex. This is on the Bori 2. This is the upgraded ESM, and it's got that white shroud over top of it. It's a lot more sensitive. It operates in the I band, which is the 8 to 10 gigahertz band. This IOC'd in 2014 and is very good. We don't know a lot about it because it's only been out for, 8-10 years now, but we just know what band it operates in. It is a two-dimensional surveillance navigation radar combo. The radar part of that is it just gives you bearing and direction. It doesn't give you altitude. So that's what a 2D radar means. All right, here are the PZKE 21 and Type 01 periscopes. This is on the Bori 1. These are the older periscopes. These penetrate through the pressure hull into the people tank. That's a liability, and that's why they wanted to get rid of these. They only put these periscopes that were also used on the Typhoon, same periscopes, on the first 3 hulls, because that's Bori 1. And then Bori 2, they don't penetrate the pressure hull at all. And here they are. This is the Paris 98 periscopes, the UP and the KP variants. These are unified non-penetrating scopes. They're connected to the fire control system. You have basically a big one and a small one. One's more stealthy than the other one, but the smaller one doesn't have as big a field of view or as many good a picture as the larger one has. Let's see, the visual optronic channel has low light television. That's the attack mode. TV thermal imaging and laser rangefinder would be on the Paris 98. Magnification is up to 12 times. That's really good. Having a 12-time magnification is something that's we didn't have that in the Cold War. It wasn't quite that much. Anyway, but 2 very good periscopes. We got to give it to them. They've come a long way. They're still much larger than anything the United States uses, but as long as it fits and it works, it has the capability, a good capability. Let's just leave it at that. All right, let's talk about torpedoes. Test 71 heavyweight torpedo. This thing is a nightmare. It is a anti-submarine torpedo, wire guided, has the Sapphire guidance system, which means it's very hard to decoy away. It goes into a countermeasure homing. Whenever it reaches a countermeasure, it will blow through that countermeasure, do a search again, and if you're anywhere in the vicinity, it's going to see you. So this thing, it's scary, and it's heavyweight, which means it can go not just blow up your submarine. This thing will blow your ship out of the water and crack the keel. So it's not a submarine-only torpedo, but they can do both. It's dual purpose. It has a 200 kilogram high explosive warhead. Speed is up to 40 knots. Range of 23 kilometers max range. Depth is in excess of 400 meters. And nasty, nasty weapon. Type 53 torpedoes. There are a lot of these. Many, many different variants. The important thing is they're all the same diameter. They fit in the torpedo tube. And so they shoot the Type 53 family of torpedoes. These are anti-ship, anti-submarine, long-running series, high speed, 55 knots, range of 24 kilometers. There's just so many different of these to talk about. Just know they keep upgrading these. So I'll tell you a quick story about these torpedoes. I saw a lot of these launched in the Barents Sea during their war games. They come out every summer, usually around May or June, and they do a week's worth of war games. And they shoot these weapons, obviously with no warheads, just shoot them for practice at each other. And I never saw a submarine seriously try to avoid one of these. So for whatever reason, whenever they shot one of these during a war game, the target submarine that was designed to play the rabbit and be hit did not try to get away. And of course it was hit. So I can't tell you how good it is. And that was many years ago. So hopefully they've made improvements, but honestly, the only way that this thing was hit when I was watching it was because the target submarine did not try to get away. So take that for what you will. This weapon, I see it all the way back in the 1960s, but don't judge that torpedo today by that number because they've modified it every couple years since then. So it's not the same weapon as a 1960s torpedo. Also, take a look at the picture in the bottom right. I've pointed out the brow launchers. Those are the torpedo countermeasure launchers that are above the torpedo tubes. And this is the best picture I had of those. So whenever you see this submarine again, and if you look at submarines like the Akula, has the same brow launchers, has the same decoys. Yeah. So that's what those are. All right. Here's the RSM-65 Balava ICBM, submarine launched intercontinental ballistic missile designed to destroy cities. This thing has multiple re-entry warheads, can have up to 10. If it has 10 MIRVs, then it's very small warheads, or it can have 3 city killers. You know, it's bad news no matter what, if this thing is ever launched. The missile can carry decoys. Yeah, this is something that they began doing in the 90s. And I don't know anything about our own missiles, but this is pretty scary. These reentry vehicles do not reenter in a straight line. They spiral in like a corkscrew. And on top of that, they splinter decoys every few seconds. So one warhead will look like 20 by the time it gets into the reentry position. It uses internal navigation as well as GLaSSNOS. GLaSSNOS is just the Russian version of GPS. Because obviously in a conflict, we would turn off, the United States would turn off GPS, or we would encrypt it is what would happen. We'd still be able to use it. You just need to have the encryption key to use it. Yeah, which means all of your cars and your navigation system would stop working. And so, but the more important thing, the Russians and the Chinese would not be able to use it either. So they made their own. GLaSSNOS is Russian GPS. Astro inertial navigation is very cool. And I used to not be able to talk about this, but I'll tell you how it works now because it's been a while. It takes a fix of a specific star. I think one of the common ones is Polaris. It's going to be a star that doesn't move in the sky. And by its position after launch, it knows exactly where it is over the Earth, not by looking down, but by looking up at where specific stars and constellations are. And then it triangulates, or has more than just 3, multiple directions, crosses its orbital position. And it's very accurate. It's shockingly accurate. Astronavigation is. And yeah, the Russians do it too now, and they're good at it. All right, it does have 3 rocket stages, solid fuel and liquid fuel combination, which is bonkers to me, but hey, that's just the way Russians play. Solid fuel is very dangerous, man. But that's how they do it. They have solid and liquid fuel. Max range is 4,500 nautical miles. You can hit just about anywhere in the world that it needs to. Obviously, the targets that it's going to be looking for is anything in the northern hemisphere can be targeted. I should mention that these submarines are deployed both out of in the Northern Fleet, so above the Kola Peninsula, and in the Pacific Fleet. So anything in the northern hemisphere can be reached easily. If they want to hit the southern hemisphere, they can hit most of that too, but they have to go down south a little bit. So CEP, I should mention what CEP means. That's basically the error of impact. So that's the estimated amount of error. It's only 250 meters. So when we're talking about nuclear weapons missing by 250 meters, it kind of doesn't matter, right? Because it's close enough to hit. All right, final thoughts. Bori class submarines, like I said, successor Typhoon class. It's a very successful design. It is quiet. I don't want to go into how quiet it is. Just know that it is quiet. They've built a good submarine. This thing is reliable. It goes to sea regularly and is not publicized because, like the United States, we don't publicize every time we deploy a submarine. We don't talk about it at all, actually. Well, neither do the Russians. Just know that these things are consistently coming in and out of port every couple of weeks. They have 7 of them. And, there's always some in port in maintenance, and there's always some being deployed. And they're reliably performing their strategic deterrent mission. Oh, here's an important point about the hypersonic missiles, the Zircon, and there's another one called Avangard. Yeah, the Avangard glider. It can't launch those. It's just the tubes and the fire control system and all that don't communicate with those weapons. And in order to fit a Zircon missile into one of these ballistic missile tubes, it would need to have some sort of sabot sleeve, so it didn't just rattle around in there. Just like whenever the Americans put Tomahawk missiles on our SSGNs that used to be Ohio class SSBNs, right? We were able to fit like 7 Tomahawks in one of these tubes because they're so big. But you couldn't just throw 7 in there. You need to have a sleeve around them, and then the electronics to communicate with it and all that stuff, and then the insulation to protect it from the temperature changes, of course, and everything else that goes along with that. Well, they didn't do any of that for the Bori class, so they do not launch the Zircon missile or any of their hypersonic weapons out of this submarine. It's strictly nuclear strategic deterrence and nothing else. Now, having said that, there's nothing stopping the Russian Navy from doing what the Americans have done and take 1, 2, or in our case 4 ballistic missile submarines and convert it to shoot cruise missiles. They absolutely can do that. They just haven't. And they really don't need to, because they can shoot their hypersonic missiles from other platforms. And they've demonstrated that. The Zircon missile does work. They just don't have a lot of them, And we've seen Zircon missile launch fails as well. So we're not sure how reliable it is because we don't have a lot of data yet. They have a handful of launches. Some have worked, some did not. And we know that they just don't have a lot. Anyway, the point is, Bori class 1 and 2, backbone of the Russian submarine fleet, reliable submarine, does its job quietly, and is strictly a ballistic nuclear missile platform that has torpedo tube capability. And it can shoot cruise missiles, not the Zircon, but cruise missiles out of the torpedo tubes. All right. Well, thanks for the support on Patreon, everybody. I really appreciate it. And we'll see you in the next lecture. Have a great one. Bye. Welcome to Type 212 Alpha Subbrief. This is a venture between Germany and Italy. This started in Germany, but Italy was quickly signed on as they had similar needs to meet and an aging submarine fleet to replace. The project to replace the 206 was the German submarine, and the Saro submarines for Italy are going to be replaced by these new subs. It's designed by a combination of design bureaus, one in Germany, which is the primary one, but also Italy came on board with their Fincantieri Spa. And the German one is in Kiel, called the Hauptwerk Deutsche Wharf, or HDW for short. The goal is to have a superior littoral water submarine. Littoral meaning shallow, near the coastline, even going upriver in some cases. That's all littoral waters. It's not deep blue water capability focused. It's focused on shorelines, coastal defense, shallow bodies of water like the Baltic Sea and the Mediterranean. It's certainly not limited to that, but that is the focus performance-wise for this platform. They want to be able to support recon operations ashore and at sea, which means special forces and signal intelligence, whether it's through a periscope and radios or sonar, or it's by putting Marines ashore. They want to have a minimum crew, so automated systems as much as possible to increase endurance or at sea time for this platform. There's going to be modular construction that allows frequent low-cost upgrades. That's all the equipment inside is going to be computer off-the-shelf technology, or COTS. And that's what they're going to use to make sure they stay up with the latest hardware so they don't have to redesign, say, the entire sonar system if they want to do a simple upgrade. It's going to be modular now. And one of the biggest things that they've done with this platform is the air independent propulsion. They went a different direction than Sweden went with its Gotland class. And we're going to talk about this air independent propulsion in a lot of detail. It's fantastic. And they also have some advanced sonar arrays and processing on this relatively small sub that are also impressive. So those are the goals. That's what they want to achieve. And Italy and Germany are working together to do it. So let's begin with Germany with HDW and a second shipyard out of Emden called Thyssen-Nordswick GmbH, or TNSW for short of Emden. These are two completely different shipyards working together to build this one submarine class. So they're going to divide the load between the two. They're going to assemble hulls 1 and 2 in Kiel and hulls 2 and 4 in Emden. Okay, so they've completely divided up the workload, but they're also building the bow section in Kiel and the stern section in Emden. So each shipyard builds its own half of the submarine, and then the other half gets shipped to it so that they can assemble it later on. So Germany's going to assemble U-31, 32, 33, and 34, 4 hulls originally in batch 1, and they will be completed between the years 2005 and 2007. That's when they're commissioned into the service. A second batch is also built, but it's almost 9 to 10 years later before they're complete. And this is going to be hull U-35 and 36. Italy has a similar structure, but it's all out of the same shipyard. And they're just going to build 2 submarines initially. And then after they rework the process and improve it and upgrade it, they build 2 more in 2016, 2017 for a total of 4 submarines operating in the Italian Navy. So in the end, we have 6 submarines for Germany, 4 submarines for Italy. The total program completed hulls is 10. There are more planned, but not completed for Germany. All right, so let's talk about construction. Obviously built in the shipyards. Here you can see a close-up of the sails. This close-up on the upper right-hand side is a 212 Alpha with the diver swim-out locker there on the starboard side of the hull. I should mention that the hull of this submarine, it's a twin hull or dual hull submarine, double hull. The outer hull is a non-metallic material. So some kind of composite of some kind. They don't go into details. It's really classified as to what it is, but it's non-metallic is what they're saying publicly. You can see the small cylinders there on the left-hand side. Those are the hydrogen cylinders. Part of this air-independent propulsion is combining liquid oxygen or just pure oxygen with pure hydrogen and making electricity with it. So they have cylinders exterior to the pressure hull in a free flood area between the 2 hulls, some with oxygen, some with hydrogen. You can see right here clearly the smaller tanks are the hydrogen tanks. In the beginning, they had a 7-bladed screw on the first batch of submarines, but they quickly removed that and put on 6-bladed, again, non-metallic composite material screw blades onto the second batch of 212s, 212 Alphas. And there you can see the vortex dissipator on the very back end of the screw. The picture in the lower right is a picture of a more modern second batch 212 Alpha with a 6-bladed screw. So on the left is the early version, on the right is the newer version. Okay, hydrogen tanks and liquid oxygen tanks. Here you can see a really good picture of the liquid oxygen tanks, how they're sitting topside behind the sail, above the pressure hull where the people are, but below the second hull or the outer hull. And there's looks like 2 tanks there. Obviously, they're a lot bigger than hydrogen tanks are because at the molecular level, the oxygen atom is physically bigger than the hydrogen atom by a lot. So it needs to have a larger tank to have, equal amounts of fuel going into the engine. All right, so batch 1 and batch 2, here are some of the differences between the two. The upper one, like we've already talked about, had the 7-bladed screw. But if you look at the lower picture, it goes over all the different systems that are a little bit different. Again, the non-metallic hull around the outer side, the 6-bladed carbon fiber screw is for the newer one. Modified hydroplanes, rather. They changed the hydroplanes to be a little more efficient going through the water, whether it's on the surface or submerged. And so they got a little more maneuverability out of them. Made them a little more hydrodynamic, a little bit larger plane surface, and so they can get a little more motion out of it. They have a Callisto comms mast in the new batch. This is a comms mast that does satellite communication, but it's also able to be deployed from depth, and it floats. And it can, so the submarine doesn't need to come to periscope depth necessarily to communicate with satellites and through the satellites with special forces and shore facilities. So that is a really cool addition to a diesel boat. This system, this Callisto system, has a lot of problems. The buoy doesn't work reliably. It was taken off of at least one hull we know about. I'm not sure if it's even in service at this time, but that's the Callisto comms mast, satellite communication mast. There's an optotronics mast that they added to hull batch 2 rather. So it has not just the primary periscope, but it has a non-penetrating optotronic mast as well. Swimmer airlock is added to the starboard side inside the sail. There's a larger control room. They made the control room a little bit bigger in batch 2, and they added active sonar. Now this can get confusing, so I'm going to explain it now and again a little bit later in the lecture. Both hulls have active mine detection sonars, both batch 1 and batch 2. Batch 2 added a second active sonar that is mainframe active sonar or active operational sonar. They don't go into any detail about it. I don't know the frequencies. All I know is what they say here on this slide is that it's an AOS, active operational sonar, and the mine detection sonar on the bow there. All right, so let's talk about PEM, polymer electrolyte membrane. This is the magic that creates electricity from that oxygen and hydrogen I was talking about. Air independent propulsion, completely independent of snorkeling. The reason why it's air independent propulsion is that this energy is 100% used to turn the screw. So it's not air independent power like it is on newer diesel boats. Okay, this is still for propulsion only. And the way it works is just like here in the diagram, is they have this membrane. The membrane is the secret to making this work. They have a classified material that is between oxygen and hydrogen. And the oxygen acts as the cathode, the hydrogen acts as an anode, and the electrons want to flow from the hydrogen side to the cathode or oxygen side. And there is enough flow of oxygen to produce a couple things. One, heat. It gets really hot. It also produces water on the oxygen side, because when you combine a hydrogen and oxygen, you're left with water. The process of making this heat and making this water is an electrical load, or supplies electricity. And it is this engine, this new air independent propulsion, that is going to harness this electrical load as this water is created to turn the screw. It's really incredible. It's different than what they use on the Gotland class. All right, so here's a detailed breakdown of how it works together. It's created by a company named Siemens, and it's the Permison electric motor. This is a little confusing because it uses the same 3 letters, PEM, as the polymer electrolyte membrane. The polymer electrolyte membrane is inside the Permison electric motor. Okay, keep that straight. So the fuel cells take in the oxygen and the hydrogen, as seen here in the diagram. Heat is created whenever that happens. The resulting water is collected into a reaction water tank, and the electricity that is produced by making this water is used in the energy cells. The energy cells are then used to turn the motor. It's pretty clever. Here's a picture of the motor. This is a masterpiece of engineering, how they made this work in such a concise manner while it's taking 2 volatile substances, creating energy, heat, water, and electricity in a safe, reliable, consistent manner that is also quiet and very well balanced, all in one component. This is the Siemens Permison Prime Mover. This is the engine that turns the screw. And it does it with only two things: pure oxygen and hydrogen. Pretty incredible. And look how large it is there compared to the gentleman standing next to it. All right, 212 Alpha by the numbers. It is 57 meters long. Notice that batch 2 is 1 meter longer than batch 1. Other than that, it's all the same in terms of dimensions. 6 meters wide, displacement's about 1,450 tons. It does have a 6-bladed propeller now. Know that when they started batch 1, they had 7-bladed propellers, but they're all 6 non-metallic composite propellers now. They can do approximately 20 knots submerged. Torpedo tubes, it has 6. It has enough stows for 13 torpedoes. It can carry mines externally, but that's not commonly done, but it does have a mine capability. Just note that if they do go on a mining mission, the mines are not inside the submarine. The mines are going to be strapped to the outside and released as they drive over the locations that they want to mine. That is a little bit old school compared to modern day mining, but it might have a lot to do with the treaty restrictions that they're under. Okay, the air independent power generates 240 kilowatts, quite a bit of kilowatts for just mixing oxygen and hydrogen together. Has officer and crew complement of 27 people and can be submerged for up to 18 days. They brag that they can go longer than 12 weeks, but they also set a record of 18 days without snorkeling and without ventilating or coming to the surface or doing anything. They stayed submerged in a diesel boat, traveled over 1,000 miles in 18 days, and didn't come up for air during that entire trip. Pretty incredible. All right, so here's some pictures of the ship's control stations. You can see that it's a single-man operation. Guy sits down there and operates the levers to drive the ship, forward, up, and down. And you can see that the picture on the right is the mechanical backup to the electronic control unit. So if they have to, they can take local or hydraulic control of the control planes. And they have that little diagram below them to help them visualize what they're doing as they reposition those 4 knobs. There are 4 levers for each of the 4 cross rudders in the rear. And so if they want to raise the boat, they don't really have to think about, okay, which one do I put in what position? They just use that matrix chart to operate the hull to get the desired result that they want from the rudder. And the little picture on the top there you can see is just some of the systems. Looks like a trim and drain system for ballasting the boat to a neutral buoyancy. That's ship's control station. Okay, combat management system is the MSI 90U Mark II. This combines sonar, radar, periscope data. Periscope data, not just video, but actually pickling or buzzing, we call it in the Navy, buzzing a bearing that the periscope operator is looking at to the fire control system. It does automatic target motion analysis based on time frequency and time bearing. It also is how you control the torpedo tubes, although you can control them locally as well. Threat identification, it assists in targeting threat tonals on the narrowband side of things. And visual identification, it has a library too for the periscope operator to reference. Data recording and replay is available both on the visual side from the periscope and from the sonar side. This is really key because whenever you're listening to a sonar system, you obviously have 360 degrees around you, and you're also looking up and down. So there's multiple tiers to this 360 degree. Oftentimes, you'll be listening in one direction when you see visually a noise source in another direction that just ended. Like it began and ended in less than 1 second. So by the time you scroll over to it, you don't hear it anymore, but you know something noisy just happened. Well, with this system, they can pause time, rewind it, and listen to it again with the cursor on the right bearing because it is all saved into a buffer that allows the operators to go back in time and listen to bearings that they did not hear the first time. It's a big advancement in real-time data analysis. Being able to say, well, we missed something over there. We know something noisy is going on to the starboard now. Let's maybe listen to that bearing and possibly miss something else on the port side. So being able to go back in time and listen to those old recordings is really, really key for the sonar world. Video recording, like I said, is a thing. Oh, and there's a built-in simulator. So instead of going to a shore facility and taking up classroom space and all that to simulate operating their equipment, they can actually operate their equipment in port and at sea with false contacts injected into the system. So it's great cost saving and time saving measure and equipment saving measure, as well as personnel, because you don't need external teachers to teach people in a schoolhouse. They can conduct their own training with their own equipment, gaining experience with the equipment that they're actually going to take to sea. So built-in simulation is common in every sonar system now, and they have it here as well. All right, more pictures of the control room. You can see some of the periscopes down there. That's the optotronics mast that he's looking at. And that is the ESM mast over on the right that detects radars that are topside looking at the submarine. And that's really key in case there's like a periscope, high frequency radar that can detect the periscope. They'll know right away and be able to dip. It also has direction finding for the radar, so they'll get a bearing to it. So they'll know that it's coming from the south or whatever. And there on the left, you can see more control room panels. Looks like more ship's control and weapons. Oh, that's combat management right there. Combat management. All right, let's talk about the Atlas DBQS40. This is the sonar system. So this is the bread and butter of the submarine as far as I'm concerned. We have multiple arrays. They put a lot of arrays on this thing. First, and surprisingly to me, I honestly did not know this until I made this lecture, they have a towed sonar array on this little diesel boat, which makes sense, especially if it's going to operate in deeper waters, which it can do. But for a littoral operation submarine, it is unlikely they'll ever have depth excess for a long towed array. Now, it's possible they have what's called a tactical towed array, which is a relatively short towed array that they can just put out a couple 100 feet and it still works great. Even a couple 100 feet is all you need for low frequency. That's what I assume that they have here. They do have active intercept. That is different than active transmit. Active intercept is simply a cylindrical hydrophone. It's in the sail that hears active sonar and will give them a bearing to it and how loud it was. So it's active intercept. Passive ranging with the flank array. This is really cool technology. This is something that was coming online at the end of my career, where we have flank arrays now that go along the sides of the submarines, and all they do is hear the sound. And because the array is so long, it's on, the side of the submarine, or it's just has one array on the bow and one on the stern, and there's like some bearing separation between the two. They can triangulate the location of the noise, whether it's active sonar or a transient, based on the time delay from when it reached the bow of your submarine to the aft end of your submarine. That creates a little triangle that points to right where the target is and gives them an idea of range. The range is not gnat's ass, but it's, it can be within, a couple 100 yards, which is not bad. It's all you need for a weapon. So they have this passive ranging flank array. And all it does is listen, and it spits out ranges at you. It's wonderful. Active mine detection is on the bow. That's the MAS. Mine active sonar is what that stands for. Always looking forward. Because they're littoral, that's very important that they not wander into a minefield. They do have some own ship noise monitoring arrays. Nothing really fancy there. Every submarine has them now. They're very important to know how loud you are. And if you do have a noise problem, it also helps you isolate what piece of gear is causing the noise, because these own ship noise monitoring hydrophones are throughout the ship. So they can kind of triangulate the location and based on the frequency that it's hearing, figure out what's going on. Another way of doing this would be to shut down pieces of equipment, one or two at a time, and see if that noise violation goes away. And then you're like, aha, it's the ice cream maker. We can't turn on the ice cream maker anymore because it makes noise. So that's what that's used for. And then finally, and kind of the main array here, is the passive chin cylinder array. This is the primary broadband array that the operators are listening to with the headphones on, looking for contacts. It's right there on the bow. All right, here's the navigation plot. Notice that manual navigation is still done. Even though they have all this equipment, satellites, GPS, they still manually plot their location, and that's key. American submarines do the same thing. Every experienced navigator knows the value of manually calculating and verifying your position, and that's what they do here too. It's really good to see this. With all the tools that they have at their disposal, they're still manually tracking their own position. And there you can see what the periscope looks like to the operators in the control room. So not just the person on the scope sees what's going on outside. The paraviz is what we call it, is replayed on any of the consoles that selects it. Any console can bring it up and see what the periscope operator is doing. The idea there is more people looking at the paraviz, or, you know, the better chance you have of not missing something. Because if it's just one guy and he scrolls too fast, he may miss that sailboat that is right on top of you, you know. So it's really good. All right, the Callisto buoy array. I kind of already talked about the problems with this, but again, it's a two-way satellite communication that allows them to contact, you know, other commands and their special forces. That's important, using satellite communication. They don't need to come to periscope depth to operate this. When it works, it's great, but the program does have problems with the buoy simply not working, not staying at the proper depth. Sometimes it doesn't work at all. So, and it was taken off one of the German submarines. I don't know if the other ones still have it or if they've worked out the issues. That's not clear. But technical problems continue to plague this Callisto radio buoy. All right, so let's take a look at the crew living space. This gives you an idea of what they have to work with. It looks like they have 5-man berthing areas. And you can see by the number of lockers on the left, there's 6 individual lockers for personal items, which would imply 6 people in that berthing space, with only 5 racks, which means someone sharing rack with somebody else. It's very common on submarines, especially on diesel boats, when there just isn't enough space for berthing for everyone. You know, the only people getting their own space is the CO and XO and maybe some senior enlisted men. You know, if you look on the right, you can see there's 8 lockers for 5 bunks, which means, you know, most of those people are sharing bunks with other people in that living space. And that's just the way it is. And whenever you sign up for submarine duty, this is what you're signing up for. All right, crew's mess. This is like the main common area that people can just come together, hang out when they're not on watch. They can also do training here. Typically, there's an entertainment center with a television of some type, even though it's not pictured here. They also do daily briefings here. Even if you're in port, you'll have like a morning brief with everybody. Say, this is what we're doing today. This is what's being worked on. Here's the equipment status of everything. That type of evolution, if it's not done topside on the pier where there's more room for everybody, they can do it down here, you know, if conditions up topside are not positive. And here's some gentlemen just having a chat. Looks like they're having a meal too. All right, so the MTU 16-cylinder V-shape 396 diesel engine. This is a very common diesel engine for these German submarines, German designs. MTU's been used, you know, that's the marine engine for just about every type of diesel boat. You know, it's, you know, 8 cylinders by 8 cylinders in a V shape, very reliable. This is just another, you know, modern upgrade to that. And it's one of the things that they can rely on, that if all this new technology that they have does not work or fails, they can rely on this, that if they start it up, it's going to run and it's going to provide electricity, and they can use that electricity for propulsion if they need to get out. To move from wherever they are. This is extremely reliable. This is the primary diesel for this boat. So whenever they're not using the, you know, the oxygen, the hydrogen with the PEM, they can use this. The submarine also has batteries like every other diesel boat. We haven't mentioned that yet. This is how they charge those batteries, is by running this diesel engine. Something else the diesel engine does that doesn't get mentioned enough is it recirculates the air inside the submarine from topside. So every time they run the diesel engine, whether it's in a World War II movie or it's, you know, modern day, they're sucking air in from outside through the diesel and of course expelling the exhaust, but it also helps to circulate the air inside the compartments. So the crew's getting fresh air at the same time that this thing is running. All right, torpedo tubes. This was interesting. It has 6 torpedo tubes. But because of the location of the ejection pumps, which are the big round barrel shaped things right there, being where they are, 4 of the 6 torpedo tubes that are 53 centimeters apiece are on the port side, and 2 are on the starboard side. So it's a little off center. And the reason why it's off center is because of the location of the ejection pumps. Now, these ejection pumps are very quiet. They are piston operated, which surprised me. I think that might be disinformation, but every source I've read that's not classified says that it is a piston that operates these ejection pumps. I have reasons to believe that that's not the case, but we're going to go with what they say because that's the unclassified answer. So 4 on the port side, 2 on the starboard side, a row of 3 over 3 basically. Just there's a few more on the port than on the starboard. They're all the same size, 53 centimeter, and they shoot a number of different weapons. We're going to get into those next. So here's a close-up of the port side offset. So the gentleman there is, he's standing on what is the starboard side of the submarine. You're looking at the front of the submarine as it looks back at you, and you can see how most of the tubes are on the port side there. Also gives you an idea of how big a 53 centimeter torpedo is. Pretty big. All right, here's inside the submarine. Again, you're looking at the tubes. They have the tube open there. That yellow box thing with a handle on it, that's called a battle lantern. And it's basically, a dry battery cell flashlight that is used only in emergencies. Why it's mounted inside the tube, I don't know. Maybe they're just doing an inspection. I don't think it's normally supposed to be there. Looks like they may just have set it there for this photo. Really no way to tell. But that's what that yellow thing is, and I thought you would like to see how the locking rings work on the back end of the torpedo tube. You see how thick they are. That is solid steel. All right, let's move on to what they shoot. So we have the Germans shoot the Sea Hake, which is a heavyweight torpedo, has a large warhead, and the Italians shoot a very similar version of the same weapon that they call Black Shark. And the cool thing about this is that it is fiber optically guided. So it does use a fiber optic cable, or, I guess you want to say a fiber optic fiber that connects it to the submarine as it's going out swimming around. One of the things that this fiber optic allows them to do is they can listen to the actual audio from the torpedo. So if the torpedo is in passive homing, the sonarman can put on the headphones and hear what the torpedo hears. It's like having a probe out there with a high explosive warhead on it. It's really cool. We don't have that kind of capability on the United States Navy yet, or at least whenever I was active duty. And that's one of the things. There's other things as well, but that's just one of the things that having a fiber optic cable does, because it allows for additional information to be transmitted between the submarine and the weapon. And real-time audio is one of those things. Oh, something cool about the Sea Hake is that you can add multiple batteries to it, which would increase the length of the torpedo. Anywhere from 2 to 4 batteries. Obviously, more batteries gives it longer and longer endurance. So they can load a torpedo that's relatively short range with 2 batteries, saving them space in the torpedo room and all that. Or they can have a couple of the torpedoes configured with all 4 batteries installed, so it's full length, but it goes for a very long way. Same torpedo, different ranges, depending on how many battery packs they install on it. All modular. Okay, here's some pictures of torpedo handling. That's how they load them. Rear first into the submarine. They kind of just slide down. And then once they get down in the torpedo room, they pivot down so they become horizontal again. This is exactly how American submarines load ours. We use a cradle instead of a sled like they have. Well, we have a sled too. So we have both a sled and a cradle, whereas they just have what looks like a cradle as the torpedo gets loaded in there. Okay, here is the Interactive Defense and Attack for Submarines, the IDAS. So this is really cool. This is something that I've been wanting for the American Navy for years, and leave it to the Germans to come up with it first, because they're effing brilliant when it comes to designing and engineering things. This is a surface-to-air missile shot by a submarine, optically guided with a fiber optic cable attached to it, just like the torpedoes, that can shoot low-flying aircraft out to about approximately 12 kilometers. And it's really cool. It is the first missile that is submerged launched that comes out of the water that's not encapsulated. And encapsulated can mean many different things, but in this case, that black missile that you see in the lower right-hand corner is what comes out of the water, kind of like a ballistic missile does. But a ballistic missile is encapsulated in bubbles all the way up to the surface. A Tomahawk missile is encapsulated in an actual capsule that is ejected from the submarine, floats to the surface where it becomes vertical, and then from that capsule launches the Tomahawk. This is the first missile that is ejected from the tube without any of that. No bubbles around it, no capsule around it. It looks like a finned, missile. And even in a high sea state, according to the brochure, the people that make this, even in a high sea state, can come out of the water and hit a target. And it's got a little fiber optic lead that connects it to the submarine through the torpedo tube. The magazine that you see there being loaded holds 4 of these. So they can load this magazine into one of the 6 torpedo tubes, shoot the magazine one at a time, up to 4 times, without ever ejecting the magazine itself, and the missiles will fire one at a time. Whenever the magazine is empty, they can backhaul the magazine and offload it in port. It is just incredible. How accurate this thing is, I have no idea. There's no data at all on how accurate it is. But I'd like to think that it is effective since they use it. So they go to sea with this. So helicopter pilots that are out there, and, P7 Poseidons, there's a P8 Poseidons pilots that are doing low, flying for, looking for submarines, now have a realistic surface to air threat in what would otherwise look like open ocean. So this is a game changer in that the helicopters and ASW aircraft are no longer immune during their hunt. If this gets proliferated, which I'm sure Americans are going to have our version of it too, this is going to change ASW warfare. All right. We also support special forces with these. Again, with the second batch, they added that swim out diver hatch on the starboard side. There is some kind of door that opens up from the front, but to get into the people tank, the hatch is on the starboard side. Remember, these are double-hulled submarines, so they got to get inside the outer hull, which again is non-metallic. And then to get into the people tank, the pressure hull it's called, they have to go through this airlock chamber that is in the sail. So here's a really nice picture of Italian special forces swimming outside their submarine. All right, so let's talk about some operations. This is a relatively new submarine, so there's not a lot of history here, but a few interesting things I found online were in 2006, U-32 conducted a 1,500 nautical mile submerged transit without snorkeling or surfacing to Rota, Spain. That was from the Baltic Sea to Rota, Spain. Again, it wasn't record breaking, but that's a long ways without surfacing or snorkeling. 2008, 2009, the Italian submarines are deploying with the United States Navy. They're in the Mediterranean, operating for 5 and 6 months at a time, proving the endurance of these submarines. They can handle long deployments with NATO fleets. That's what they achieved there. 2012, S-526 is deployed to the Indian Ocean. So that's an Italian submarine going to the Indian Ocean for a few months and coming back. She also operated in the Arabian Sea and the Red Sea. She went through the Suez Canal there in Egypt to get to that. Okay, 2013, U-32 established a new submerged record for 18 days without snorkeling. Here's where the record gets set in 2013. A German U-boat operated, went over 1,000 miles without snorkeling or surfacing or doing anything to bring fresh air into the boat. So I'm sure that boat smelled really good at the end of the 18 days, but congrats to them for proving the endurance of this submarine. Modern naval warfare may only last 18 days, and that's what they need. July 2017, U-32 did damage its batteries and was out of service for a year. It's not clear what happened. I don't know if water had gotten into the boat or if they had just put too much of a load on the battery that shorted it. They are very close-lipped about the details of these casualties, but we know that they damaged their battery doing something at sea, came back. There was no dry dock available for her, so she had to wait a little bit before the repairs began, and she was out of service for about a year. In October the same year, U-35's rudder is damaged conducting operations in and around Norway. So it's believed that she struck some kind of rock and was out of service for a little while. U-36, which is the second of the Batch 2 submarines for Germany, was used as scavenging parts to keep U-35 operational up until this point. Obviously, at this point, there's we can't use the rudder anymore. They actually had to escort her from Norway back to Kiel to get her repaired because of the damage. The damage was that severe. So she had a bit of a hard time. Now, at the time of this recording in 2020, the maintenance is better and the submarines are operational again for both Germany and Italy. They had gone through about a year or so where there was a short time where none of these submarines were operational for a very short time. That's been remedied. But 2017 to 2019 was a tough time for the German Navy. In 2020, it seems like they're getting their momentum back and their funding back, which is important. All right, so final thoughts on this. Man, it blew me away. I learned a lot making this lecture. It's a absolutely revolutionary air-independent propulsion. What Siemens came up with is like magic. My hat's off to them. Those engineers are incredible. I can't believe they made it work, and they did. And so if you can get your hands on one of these submarines, if you're a nation looking for a good diesel boat, I would recommend talking to the Germans about doing this, about making some for you. They have offensive anti-air capability. That's ASW warfare game-changing. No longer do we have to run and hide from these helicopters and airplanes. We can actually engage them if we need to. High endurance and station keeping, setting records for diesel boats, being underway for 18 days without any type of surface air replenishment for the crew or machinery. Fantastic. Can support special forces, in and around littoral operations and stay on station to retrieve those special forces for up to an 18-day period. That's unheard of. That's fantastic. That's some nuclear powered support measurements right there. Whenever the Americans, when we support our stuff, we can stay on station for months at a time. That's only because we have the nuclear reactor. They're doing this with a very small but highly capable diesel boat with air independent propulsion. Well done. Heavyweight torpedoes. Those torpedoes can knock out large ships. They have huge warheads on them. So they can get into a deep water Blue Navy fight and do a lot of damage. They are very quiet. That Siemens prime mover is amazing. Very few moving parts with the exception of the shaft itself. So by eliminating all the additional pumps and support lube oil things that happen in a normal propulsion system, by getting rid of all that and making it a chemical process to generate electricity with no moving parts other than the actual shaft output and the motor itself, is a huge evolutionary step in submarine warfare, and it's very quiet. The design is outstanding. I give this, out of all the subbriefs I've done so far for diesel boats, the highest grade. It is very well engineered, and we wouldn't expect anything less from our friends over in Germany. They did a great job, and in Italy too. Don't forget, Italy definitely had a part of this design. But that Siemens primary, the prime mover is what we call it in the Navy. The main engine is just really incredible. And they put together a lot of really good technologies here in one platform that make this extremely capable diesel boat. So I'm blown away by it. All right, welcome to the Type 093 Chinese Shang SSN subbrief. All right, we're going to begin our subbrief with the August 1993 Vinhe incident. China's Ocean Shipping Corporation vessel, the Vinhe, is on a scheduled route from Taijin port in China to Dubai and then further on into Kuwait and back again. It's been on this scheduled route for years. They just basically deliver building supplies from China to Dubai and Kuwait and, return with whatever they have to go back to China. And it's just a regular routine visit. But in 1993, the United States alleges that the Vinhe is carrying chemical weapons that will be delivered to Bandar Abbas, Iran from China. And in order to go through the Strait of Hormuz and into where the Persian Gulf and deliver to Dubai and Kuwait, it is going to have to go by the Bandar Abbas fleet or harbor. But that doesn't give them any, that's not proof that there's chemical weapons on board. But the United States swears that there's chemical weapons on board. They have intelligence. It's infallible. They know that it's there. And so they begin shadowing the Vinhe in the Indian Ocean as it makes its way into the Gulf of Oman, getting ready to enter the Persian Gulf. And it calls for, diplomatic action to be taken, and over the radio, they call for the ship to return to port. So no further action is required by anybody. They don't want to stir or start an international incident over this weapons of mass destruction, but they certainly don't want them delivered either. So the United States finally forces the Gulf states of United Arab Emirates, Oman, Saudi Arabia, and Kuwait, and Dubai, and Qatar to close all of its ports to the Vinhe, so it doesn't have anywhere to pull in, including Dubai and Kuwait where it's supposed to go. So it's sitting in the Gulf of Oman, basically under siege. The only open ports in the vicinity are the Iranian ports. Ironically, the ones that the United States were trying to keep the ship from going to in the first place, is the only port it can go to now. But it doesn't even do that. It sits in the Gulf of Oman for a few weeks as this siege and diplomatic pressure evolves. The United States administration is advised by its lawyers that it is illegal to search a ship at sea without consent. They compromise by escorting the Vinhe to a Saudi Arabian port, and with a joint Chinese, Saudi Arabian, and American inspection team, they'll all go on board together and see what's going on with the manifest. What are they actually shipping? Well, they do this, and wouldn't you know it, the inspection team finds no weapons. They only find the paint and all the items that are on the manifest. There's no contraband whatsoever. This has all been bad information from the American intelligence community again, and just another example of how unreliable that can be. Well, China finds out about this. Of course, it gets into the media. The Chinese nationalism spikes over this. The Chinese people want a response. They want compensation. The company that runs the shipping has delayed delivery. They have delayed payment. They have penalties for delayed delivery. This has a ripple effect through the Chinese economy at a local level with the company that runs this, the Chinese Ocean Shipping Corporation. Has incurred, financial hardship because of this mistake that the United States has made. Well, the United States doesn't offer any compensation, doesn't even offer any kind of apology or acknowledgement of wrongdoing. The United States doubles down during an investigation by the United Nations years later, where there were public hearings. The United States representative is saying, we had good information, the weapons of mass destruction were going to be loaded on it, but because we found out about it, they did not load the weapons of mass destruction, which is complete baloney. They just would not apologize because they didn't want to, agree that they had made a mistake. And they certainly didn't want to pay any kind of financial compensation to China. The Vinhe incident is seen historically as one of the key moments where China and American relationships begin to fracture again after the 1970s Nixon visit. Through the 70s and 80s and early 90s, things were getting better between America and China. We had strong economic bonds, and that was bleeding over into a little bit of cultural exchange, and we were having a positive relationship with these countries. And this incident is the beginning of the end of that. The Vinhe incident, 1993. All right, in 1994, the very next year, Project 093 is announced by Chinese President Jiang Zemin, instructs the Central Military Commission to start a next-generation submarine program. China wants to build a navy capable of protecting its shipping lanes in distant seas. And this is the natural progression of a developing country where they get to a point where they have long-range shipping and trade deals that need protection by the Navy. The United States went through this in the early 1900s, and then again after World War II, protecting the shipping lanes was the primary focus of the United States Navy. Well, China is now saying that they need to do the same thing based on what happened to the Vinhe. They didn't have any other military response. They only had diplomatic avenues to go after and protect their investment. So this is in direct response to the Vinhe incident. The PLAN will use nuclear submarines as its primary long-range naval power. And here we can see not only a picture of the president, and there's also a graph of how far out 1,000 nautical miles is from the Chinese coast. And this is where they're going to put their submarines. Their nuclear-powered submarines are going to fill this red void out to the limits of 1,000 nautical miles, as well as protect the sea lanes. That's still there too. But they want to flood this region in a layered defense of anti-ship ballistic missiles that can reach out to 1,000 nautical miles, which, by the way, are devastating. Those things are incredible technology. They call them carrier killers, which is a bit of an overstatement, but they are effective and they're very deadly, and they will damage a ship and possibly sink a carrier if it hits it. but I digress. Inside 540 nautical miles, that is where the submarines will be supported by aircraft, land-based long-range aircraft over them, keeping the hostile ASW aircraft off of the submarines. And then inside 270 nautical miles, which includes Taiwan, they are going to have everybody else. Diesel boats, nuclear subs, coastal defense vessels, and their surface fleet supported by the Air Force inside 270 nautical miles. On a side note, China still considers Taiwan a province of mainland China. That has not been resolved yet. MND, 7th Research Institute of National Defense of the People's Republic of China. That's a mouthful. What this is inside Wuhan, China, in the Hubei province, is a large campus. It is enormous, that has multiple research and development institutes on this, city-sized campus. Research Institute 719 is specifically researching and developing submarines. Now, there are other research labs like 711, 712, going all the way up to 726, I believe is the last one. And each one has their own primary focus, whether it's artificial intelligence, computing and technology, and robotics would be another one. Materials, experimental materials would be one. Well, 719 is for submarines only, so that's our primary focus for these subbriefs. It's the primary nuclear submarine design bureau, as I said. It was established in the early 1960s. This entire complex took multiple years to build. So from 1960 to 1963 or so, they got all these up and running. Research Development Institute 719 by itself employs about 700 engineers and researchers. Those are the people going to work every day designing better systems, quieting their submarines, building a better nuclear reactor and propulsion system inside the next generation boat. All right, here is a quick map of China and their fleet headquarters. They have 3 major headquarters for their Navy, PLAN. Up in the north, they have the Qingdao North Sea Fleet, the Ningbo East Sea Fleet, and the Zhenjiang South Sea Fleet. Here are their fleet distributions. Up in the north and down in the south are where the nuclear boats are stationed out of. Ningbo doesn't have any nuclear submarines. There are diesel boats in all 3. And notice how the South Sea Fleet has a lot of ships, a lot of frigates, amphibious ships, patrol craft, corvettes. That's because China, moving forward, is putting a lot of pressure militarily into the South China Sea as they're trying to make a claim by proxy of the Spratly and Parcel Islands, which are contested by other countries. The idea is if they simply occupy it, it becomes theirs, ownership by proxy. All right, let's begin. Type 093 Shang SSN subbrief. Designing the Type 093 subbrief. So China began by using Russian technology to improve their information and communication equipment in the command section of the Shang. They ripped out everything from the Han. They didn't reuse any of that equipment, and they built a brand new fire control system, radio communication suite, inboard ships control systems and systems monitoring. All that was completely redesigned with Russian help. In the beginning, we expected the 093 to resemble a Victor 3 or a Victor class because of a lot of the Russian technology being used from that time. That was not the case, but they still used Russian help. The fire control system that they ended up with can shoot the submarine variant of the YJ-18 anti-ship cruise missile. And I would postulate that this is the primary weapon of the Type 039 submarine. And we'll get into more as to why that is at the end of the lecture. The reactor design was assisted by France in the beginning of 1995. If you remember, their previous design with the Han and the JA ballistic missile submarine, which was the same reactor design, was very inefficient. So they came in with a new design with some help from France, and Canada began providing technical assistance in 1998. And the American company Westinghouse made its AP600 civilian power plant available to China to study. The idea behind the Westinghouse deal was they would use the AP600 method or style for their civilian plants. That was not supposed to be a military project, but they learned things from that design that they then used in the Type 093. China's nuclear power design improved significantly from 1995 to 2000 with this help. The new submarine will also have a double hull design, just like the Han had, and like most Russian submarines have, but they'll be using HY116 steel. That's high yield 116 steel for the pressure hull. This makes it a relatively deep diving tactical submarine, comparable to, but not the same as, the American Seawolf class. But it can dive deeper than, say, the 688 because they use a different HY steel. And it has 6 53-centimeter bow torpedoes in a 4/2 configuration, just like the Han. That's one of the few things that they kept from the Han design into the Type 093 design, was the torpedo tube configuration. All right, the Bohai Shipyard Heavy Industry Company is the only shipyard in China that builds nuclear submarines. So we're back here again to talk about the Shang 093 type. It's located in the Longnang province. That's in northern China, right next to North Korea. They produce both military and civilian vessels. They have a huge assembly building they recently completed, and inside that assembly building, they can build up to 4 nuclear submarines at the same time. It is a climate-controlled building, which means no matter how bad the weather gets outside, no matter what time of year it is, they can continue working on 4 submarines at once. All right, the Type 093 Shang by the numbers. First is the length. Let me address this. The length as measured by the satellite measuring tool from Google Images, satellite images, is 103 meters. And there's a little bit of uncertainty in that. So it could be 104 meters. But the key here is for all 3 variants of the 093 Shang, they are all the same length. That is an extremely controversial thing to say for people that don't believe that, as we'll get to a little bit later on. But as measured from satellite images, the length is the same. You might argue that it's 104 meters, and I would be okay with that, but it's not 110. It's not that much different between the 3 variants. And that is very important. Remember that 103 meters for the Shang Alpha, and the Shang Bravo. 103. The beam is 11 meters. It displaces about 7,000 tons, which is a little bit more than a 688. It is 30 knots maximum, a little bit slower than a 688, probably because it's pushing a little bit more weight. And it has 1 pressurized water reactor turning 1 shaft with a 7-bladed skewed screw on the end. It eventually gets down to approximately 120 decibels noise level when it's running in quiet. The early versions of the Shang didn't make it that quiet, but the later versions certainly did. And they did that with rafting and sound isolation techniques that we'll talk about. Test depth is about 400 meters because they're using that HY116 steel. They have an endurance estimated at 80 days between port visits and food reload. The crew's 100, and they have the 6 torpedo tubes. They can stow up to 20 weapons, including those missiles, or up to 36 naval mines, and they can also do a combination of either some of one and some of the other. They basically copied France's low-freak front sonar that they used on the later versions of the Han. They're installing the same version here on the Shang with the Chinese name of HSQG-207. And on the Type 093 Bravo, the very last variant, there is an unknown type of towed sonar array on that. So they do have towed sonar array capability on the Bravo variant of the Shang. All right, Type 093 Shang hulls 407 and 408. These are the first 2 hulls that they built beginning in 1999, commissioning them in 2006 and 2007. They had 4 years of sea trials apiece, and they learned a lot from their design in this period. So they went back to the drawing board to make some changes. But before we go there, let's talk about how you're going to identify the first 2 hulls of the Shang. If you see a photo of it on the surface, or if you are in the position to see it on the surface in real life, is the windows at the top of the sail is a very Soviet-era design for Russian submarines, and they continued that over into this design. This is a foul weather bridge, which means they can be surfaced and navigate a crew in the sail in terrible weather, whether it's snow, sleet, whatever. too cold, they can get in there and be protected from the elements and still be able to see out the windows. So the first two hulls have those windows. The sail on the front, as it meets the topside deck, is a straight 90-degree joint. It is like the letter L, 90 degrees. There's no curve to it at the top or at the bottom of the sail. And then finally, if you look at the rudder, you'll notice that there is no tube on top. Later on, there will be a tube. So if it doesn't have a tube, it has a 90-degree joint, and most obviously, if it has windows, it is hulls 1 and 2 of the Shang. All right, back to the drawing board. They're going to go back and try to make some improvements. Even though the Han was very noisy and the Shang hulls 1 and 2 were much better, they still weren't quiet enough to be tactical in a modern day naval environment. They did not match with their Russian counterparts, and certainly not as good as the American counterparts. So they went back to the drawing board and they added sound rafting improvements to the engine room, and all major machinery in the boat, forward and aft, sits on sound-absorbing floating decks, like the American submarines do, and shock-absorbing springs. Now, these shock-absorbing springs aren't the coil springs you may be picturing like in a mattress or something. A shock-absorbing spring can come in many different shapes, the most common of which looks like the letter D. It's simply a flat surface that mounts, and then there's a loop, a steel loop that makes kind of a half circle, and that half circle can support weight and absorb frequency. When you put a rubber mount on top of that, spring, you get the effect of both absorbing sound. And if you put a rubber raft on top of that you then mount a piece of equipment inside of, so it looks like it's sitting in a raft, you get triple layer of sound absorption, and this is called sound rafting. It's an improvement that greatly isolates sound from individual pieces of equipment inside the submarine. Well, they did this. They went back to the drawing board and rafted as much as they could, and it worked. It got them down to that 120 decibels we had talked about. They also installed anechoic tiles on the exterior, which has a dual effect of kind of insulating the sound inside from going out into the water, a small amount, but it is designed to deflect and absorb and refract active sonar that's coming at it from the outside. So it's a little less susceptible to active sonar, as well as making it a little bit more quiet. They also flared the sail forward at the deck level and curved the forward top part of the sail backwards to give it a little bit better hydrodynamic flow. They also removed the sail windows because those things are just basically bolted in there, and they can rattle underway at high speeds. All right, the Type 093 Hull 413, they only made one of these. This is one of one. After they got all the changes from the first two hulls, they laid down the keel in 2009, launched it 3 years later, only needed 3 years of sea trials, so the sea trials were getting shorter. They were happy with the improvements that they made. They commissioned it in 2015, and then they went back to the drawing board again. But here's how you see, or here's how you determine if Type 093 Alpha is the one you're looking at. You look at the sail and look for those flares at the bottom and the rounded top of the sail. If you see that little ski jump looking thing at the bottom and there's no hump and there's no towed array back there on the rudder, then you know you're looking at the one of one Hull 413 Shang. This is also known as the Shang Alpha or the Type 093 Alpha. It was the only one of the alphas that they made. All right, so they went back to the drawing board and they added a little more tactical capability. They added a towed array to the Alpha and called it Bravo. They did a few more things than that. We'll go over. They launched the keel, or they laid the keel rather, in 2012, launched her in 2014 with only 2 years of sea trials. They were happy with their results. They finally got the Shang Bravo to where it needs to be. It's quiet. It's got low frequency detection capability, long range capability. They have a towed array capability now. They're very happy with that. They build 3 of these, making 1 a year in 2016, 2017, 2018. The way you're going to visually identify this is, again, look for the rounded sail in the front, just like the Alpha, but then look for a hump in the back, which is sometimes hard to see depending on the angle of the photograph you're looking at. But you can always just look at the rudder, and clearly from any angle, you'll see that there is a tube that protrudes out past the rudder. at the very aft end, and that is a towed array stowage tube. That is only on the type 093 Bravo. No matter what else you see, if you see that towed array stowage tube and it's a Shang, it's a Bravo. All right, so let's talk about this hump. This is the one that's going to curl some toes out there because it goes against what a lot of early websites suggested or guessed at, and basically they got it wrong is what I'm saying. This began with the Chinese media sites talking about the Shang has now VLS capability to shoot these YJ-18 cruise missiles that I talked about in the very beginning. But that is misinformation coming out of the Chinese media. Unfortunately, it was picked up by every internet site that follows this stuff as if it was gospel, and they echoed it. And so now everybody seems to think that the Shang 093 Bravo has VLS tubes. It does not. And I have the picture here zoomed in just after the sale where they claim the VLS tubes to be, where you can definitely see that there is clearly a hump that starts way forward, kind of in the middle of the sail there below the fairwater planes. It slowly ramps up for hydrodynamic purposes only to reduce the vortices coming off the sails. It goes through the water to about 2 to 2.5 feet high, where it then flattens out for just a few feet and then it slopes back down again. If you look at part of the picture where I've zoomed in on the hump, you'll see that there is no VLS hatch, but you can clearly see 3 holes that allow any water or air rather that's inside the hump to escape as the submarine dives. If you didn't have those holes, there would be an air bubble in this hump after the submarine dove, and surprisingly, that can be very loud. It sounds like water washing around in a bathtub as you're trying to sneak around the ocean. It's very detectable. So they added those holes that the water could escape after the submarine dove. But more importantly, there is no VLS hatch back there. It's certainly not in the configuration that the Chinese media claimed it was in, which is in a side-by-side configuration. In other words, as you're looking at the submarine from the bow, it would be going from right to left. They claim to have 3 tubes in line. There is not enough room for 3 tubes in line in this design. And because all the submarines are the same length, roughly within a meter of each other, I'll give the critics that, within a meter of each other, that is not enough room to put a VLS tube, not even one. You would need multiple meters. You would need something that's closer to 110 meters in length. And it simply isn't the case. The photographic evidence shows that all 3 of these variants are somewhere between 103 meters and 104 meters. They don't have the additional length required to add a VLS tube at all on the Shang Bravo. What is there is probably what the Germans did with the Type 212. They probably added a towed array handling system, and there is probably a towed array stowage tube that goes from the hump back to the rudder. And I measured that at 262 feet, which is enough length to stow a TB16 fat line towed array, or the Chinese knockoff of what we call the fat line towed array. It's a single stave array that's good for low frequencies, and there would be enough room for it to be stowed there, and a few extra feet for a handling system. It fits perfectly within the measurements of the Shang Bravo. So the hump shape not only has a hydrodynamic purpose to help alleviate some of the vortices coming off the sail as it goes through the water submerged, it is also big enough to hold a towed array handling system and its stowage tube. So why is the YJ-18 so important? Like what makes this submarine a game changer? Well, one is the attack range. The YJ-18 can, by American estimates, go up to 290 nautical miles. That is huge. And the way that it does this is it only goes at a 0.8 Mach cruise speed as it sea skims towards the target. So there is a real delay if it's going the full length of its range between the time it's launched and the time that it is detected, or it's at its target at least. And so if the initial launch is not detected by the target, it may never know that it's being attacked until it's too late. This also buys the launching platform plenty of time to launch more than one salvo before the first salvo is detected 290 miles downrange, and gives the Shang the opportunity to begin leaving the launch basket, opening datum on the launch area before the target even realizes it's being attacked. So when used tactically, this YJ-18's capability will give the Shang ability to escape and evade before the attack begins. Now, the way the YJ-18 works is once it gets onto its terminal phase and it has its target, which is expected to happen between the 16 and 20 mile point, it accelerates from the relatively slow 0.8 Mach to Mach 3, which is 2,283 miles per hour at sea level. And at that point, it takes only 25 seconds to get from where it accelerated to the target. That 25 seconds is all the time a radar operator has to recognize the threat, report the threat, spin up a missile, and get a defensive missile in the air to shoot down this weapon. And if these things are coming in packs of 4 to 6, they're not going to have enough weapons in the air by the time it hits. Also, because the final phase is a sprint at Mach 3, that makes it less likely that it will be intercepted by a ballistic defense like Sea-Wiz that uses a ballistic round. That's not saying it couldn't shoot it down, but it's less likely to shoot it down because it's so fast. Also, because of the speed change of 0.8 to Mach 3, makes it hard for a ballistic computer to calculate if it does see it out that far, because the speed is not constant. So it does have a 300 kilogram conventional warhead, which is approximately 660 pounds. Pretty good conventional warhead. It is nuclear capable. It can have a tactical nuke on board as well, which would be terrifying. And don't forget that the submarines do shoot the YU-8 53 centimeter torpedo as well. That torpedo doesn't have, of course, the range the missile has, but it is an anti-ship, anti-submarine torpedo that is very capable. All right, so here are your 6 Shangs of the Type 093. You have 2 Type 093 originals. You have 1 Type 093 Alpha with the ski slope front on the sail, like the Seawolf has. And then you have 3 of the Type 093 Bravos, which has the ski slope sail, the rounded sail on the front top, and the hump with the towed array tube on the rudder, which is the easiest way to identify that. Just look at the rudder right there. All right, so final thoughts on China's Shang is it's the quietest submarine that they've built to date as of building this one. The capabilities are on par roughly with First Flight 688. And to give you an idea of what technology that is, we built that in the 1970s with 1960s technology. Of course, flights 2 and 3 got a lot better, but First Flight 688 seems to match these capabilities on paper. It has a very long anti-ship cruise missile capability. I believe that's the primary weapon of the Shang. We've used multiple sources to improve the Shang. The Russia, France, Canada helped them out with the nuclear power program. And of course, Westinghouse gave them plans to the AP600 nuclear reactor that they then used knowledge from that to improve their submarines. Even though it's not quite the same apples to apples comparison, because they got better civilian nuclear reactors, they were able to build a better military one. And by replacing, or they will replace the 5 Han submarines with these 6 Shangs in the 2020s. So this decade, as of this recording, we can expect the Hans to be retired. They've already retired 2 of them. The last 3 should be retired as these Shangs come on service. And overall, I think it's a good and capable submarine. I think the Chinese have done quite well for themselves. I'm surprised that they only built 6, but that's probably because they have something better on the drawing board, and we'll do a subbrief on that when that comes out. The USS Mackerel was built in 1953. The U.S. Navy originally designated this submarine as an auxiliary submarine, AGSS 570. Didn't have any weapon systems or fire control systems. It was just a simple testing submarine, auxiliary submarine. But before they had even finished it, she had been redesignated as a training submarine, SST-1, or as it was known to be called, USS T-1. And she was destined to become an ASW training vessel for the United States Navy. But in 1966, her world changed for a short period of time of about 9 to 10 months. She became a special equipment testing platform for keel-mounted wheels, thrusters that could maneuver the ship within the length of its own body, and a manipulator arm on the bottom that could pick up objects. All this equipment would eventually be installed into the NR-1. This is the NR1 Nerwin subbrief. All right, our story begins with the USS Mackerel, and in the 1960s, Admiral Rickover learned of the Ivy Bell missions. Now, the Ivy Bell missions were happening with the USS Halibut and then the Parchie later on. They were doing different things over on the Pacific side of things, where they were tapping into communications, undersea communications, and Rickover wanted to have a submarine that could do that on the Atlantic side. So he worked with scientist John P. Craven, who was part of the special projects of Bureau of Ships, and he also worked on the USS Halibut and was familiar with the program. So together, they designed a nuclear-powered deep submerged submarine that could conduct these special operation missions, but without divers. The Parchie and the Halibut, they all had to have divers in the water, doing these operations. They wanted to build a submarine that could do it independently with everyone inside the submarine the whole time. And together they raised about $32 million to construct a submarine to do just this. So these are the two engineers that came together, an admiral, nuclear engineer, and the chief scientist with a history in special projects coming together to build NR1. So here's how this happened. Rickover funded his own project without going through the normal chains of command. He had done this before whenever he was pretty much pushing nuclear power into the U.S. Navy. Instead of into the surface Navy, he pushed it into the submarine Navy without really telling anybody until it was already in progress. Well, he did something similar here to fund this NR1 idea. So this all kind of begins with the loss of the Thresher off the coast of Massachusetts during sea trials in 1963. That loss of life of over 120 some young souls led to the development of a deep submergence submarine project, or DSSP. The DSSP would build rescue vehicles. And so the DSRV was created to go down and dock with a stricken submarine and bring the crew up, about 10 crew members at a time, over multiple trips. But special projects that built this DSSP and DSRV had a secret budget, much like the CIA's budget is secret. Special projects in the Bureau of Ships budget is secret as well. And who's in charge of that money? John P. Craven, the guy that was working on modifying the Halibut and working on those special missions. So special projects works in the Bureau of Ships, where Admiral Rickover works as well. Now, Admiral Rickover, he is the assistant chief to the nuclear propulsion part of the BU ships. So he's really high ranking up there. He is higher than Chief Scientist Craven is. Admiral Rickover is also the manager, or a manager, but the manager over at nuclear reactors. The nuclear reactors is part of AEC, Atomic Engineering Commission, of which he sits on a committee, which is above Bureau of Ships. So Rickover has two positions, one on a committee that oversees many different things, anything to do with nuclear power, including Bureau of Ships. So he has two positions in a chain of command, one subservient to the other one. So Rickover could order Bureau Ships Admiral Rickover to build a nuclear research submarine, and BU Ships could not refuse, as long as it didn't involve any other departments. And this was kind of key. So he very strategically built a research vessel submarine that didn't have any weapon systems on it and had no combat capabilities, and was going to be used strictly in the special projects program as a non-commissioned research vessel. These are all very key words that keeps the program strictly in line with the Bureau of Ships and not involving any other part of the DoD, and evading eventually all those other oversights and inspections and committees that can get involved in building and improving a ship, because each one of those has their own little budgets and committees and bureaucracy that takes a lot of time. Well, he was skipping all that by making a very narrowly focused submarine and funding it by himself. So with the Bureau of Ships, he had approximately $22 million that was already designated towards other projects. So other ships, other submarines that were going to be built on both coasts. He's taking a little bit of money out of a lot of different projects, and he assembles a bucket of $22 million. And he takes this idea to special projects and says, how much money can you give us? He basically steals John P. Craven out of the special projects program that he's working on with whatever's going on in there, and brings him into the NR1 program with $10 million more. And that's how the NR1 program began, with a budget of approximately $32 million, started by essentially 2 men. Now, you cannot build a submarine and crew it and have it be supported in the United States Navy at shipyards and maintenance without telling people. So he did need to go to the chief of naval operations, the senior admiral, and tell him what was going on eventually. But before he did that, he went to his friends in Congress first. Because remember, Rickover, he got promoted through a special congressional committee, because people in the Navy did not like him. They don't want to promote him. So again, he's kind of greasing the approval by going around the chain of command, again, going to Congress first, whether it's at dinner parties or in private meetings, and saying, hey, we're building this research vessel. We're funding it for ourselves. It's going to cost about 20% of what a normal submarine would normally cost, but because it's research focused only, it doesn't have any weapons on it. It doesn't cost hardly any money, and we've already got the money for it. So anybody he talked to in terms of like the Secretary of the Navy was already on board with it. So by the time he approached the senior leadership in the Navy about this idea, the Navy, even though they didn't like it and they wanted to cancel it, tell them, no, you can't build an NR1. You need to be building our ships that we're paying you money for. The $22 million, where did that come from? And they want to know all these things. But because the Secretary of the Navy, he had already had him on board with the NR1 idea, he kind of got around it. Also, in 1965, whenever this discussion is going on, what else is happening? Well, there's a little conflict brewing in Southeast Asia in a country called Vietnam. And Big Navy is not worried about Rickover's little dreamboat, NR1. They're worried about carrier fleets, Gulf of Tonkin, things that are happening over there. So they're very distracted. They don't have the time or the energy to shut down another one of Rickover's pet projects. So this is kind of like the perfect storm of a very narrowly focused ship that's already funded, that's outside the chain of command or an oversight of big water Navy, blue water Navy. And that's how this got done. This could not be done today, but it was done perfectly in line with the Navy being distracted, congressional approval, pretty much preordained, and they weren't taking any additional funds from the Navy. But of course, the ship is eventually going to need a crew. It's going to eventually need an overhaul, and those things will be done in this ship. But the ship will not be commissioned. This is not a commissioned vessel. Much like the USS T1 or SST1, it's going to act as a special project ship or a research ship, not a commissioned naval vessel. All right. General Dynamics is where it's built in Groton, Connecticut. They designed and built her in the 1960s. There you can see a photo of her alongside a 688 class submarine. 688 was where I spent most of my naval career. I can tell you 688, 130 guys on that thing. It's pretty small. It's pretty tight. This thing is about maybe less than half the length of a 688 and much less than half the width. So Rickover required that any civilian engineer that is going to work on this thing and build it in the dry dock, they go to the U.S. Navy Power School, of which he was head of, for a year before they could even begin working on anything. So engineers in electric boat that were already building nuclear submarines, working on nuclear reactors, had to go to school again before they were allowed to touch anything on the NR1. This is just one of the requirements that Rickover seemingly arbitrarily put onto the construction process. Now, in terms of material, this submarine has a nearly perfect round hull. It's made out of HY80 steel, which is the same steel used in the 688s, which is it's a special kind of steel used for submarines and some other projects, but mostly submarines. But it had to be almost perfectly round so that it didn't collapse from the pressure, because this thing is going to be designed to go down to approximately 3,000 feet. It's going to work without divers, so it's going to have some external, tools like a manipulator hand, and it's going to have a basket where the hand can pick something up and put it in the basket and then bring it up to the surface together. It has a miniature nuclear reactor. This thing, no kidding, is approximately the size of a small refrigerator. So if you go into your kitchen, look at your refrigerator, imagine if that was a nuclear reactor. The whole thing, like the primary loop, the secondary loop, the whole thing is just kind of creating a very small amount of energy that can then be converted into electricity with a turbo generator. So we call this a nuclear reactor turbo generator power plant. One of the only of its kind. Well, it's certainly the only one of its kind because it only made one NR1 and it was specifically made for that. But a nuclear power turbo generator in itself is a little unique. It has 3 viewports along the bottom forward part of the ship that looks out at the bottom where a sailor could lay down, and he only had enough room to lay down for these viewports and look at the bottom through this 6-inch thick piece of glass. It was that thick because it had to withstand all the pressure. And it was only maybe 4 or 5 inches around. You know, it was thicker than it was large. Then you could view through it. So as this submarine is rolling along with wheels on the bottom of the ocean, you could have a couple sailors look through these viewports and look for items to pick up. So here's some pictures of the external tools here. They had a mechanically jointed arm that could lift 250 pounds. There's a picture of it there on the left. It's got a little orange clamper. It had a little basket that it would, after it picked something up, it would place it in the basket. The basket kind of dropped down from in front of where the viewports are there, you know, and would raise back up again. It had 2 rubber wheels mounted in line like a bicycle. The first time they submerged, they took Goodyear tires, like the kind you would put on your truck. And of course, they collapsed from the immense pressure. So they had to go back to Goodyear and get special tires made. There was a lot of animosity with the NASA Apollo program because they were putting moon buggies on the moon laced with diamond treads, you know, and so they had special tires for the moon buggy, but they couldn't get special tires for this project because there was a lot more visibility in the Apollo program than there was in this program. It had both black and white and color cameras mounted all around on the bottom side and then also on a periscope-like device, and multiple external lights. Both like floodlights and incandescent lights. It could basically just light up the bottom, record it on video, and you had viewports available to the crew members as well. All right, so Sperry Marine Systems made a lot of the controls, electronics, and computers for the NR1. Their office at the time was located in the Charlottesville, Virginia area. They built and tested the computers that would run the NR1. They also built a really cool flight simulator called a ship's control or sub-control simulator, where the crew could come and practice driving the submarine before they actually did it. They also designed the con, so that's where the sailors sit and drive the submarine and manipulate the cameras and stuff. They designed that entire cockpit-like area. They programmed and create the Yuck 44 computer. That's it right there on the right. It has a black, you know, rectangle-like vent on the bottom, and then the top black part, that's the display part up there. And yeah, they had to program it in machine code. It didn't have an operating system. So whenever you're loading memory registers, you're literally loading it in with 1s and 0s. Yeah. We had the Yuck 44 on the 688. We also had the Yuck 7s. And whenever I was loading my sonar system, the sonar system didn't have a BIOS like your computer at home has. You had to load the BIOS commands manually with machine language. So you would select register 1 by hitting, you know, the button that meant 1 because it was either 1 or a 0, and then that would light up an 8-bit register, and you would program the 8-bit register with 1 value. And you would repeat this process approximately 60 to 75 entries, and you had to memorize these to boot the computers up. Yeah, you were literally loading registers 1 machine language value at a time. For a sonar system on the 688, it was approximately 60 values. And you had to memorize this to be a sonar supervisor. And some people could never get it down. I was fortunate enough to be able to memorize it. And that's the kind of machine programming that they're putting into the Yuck 44. They had very limited memory, a limited number of commands that they could execute, and it was linear, so it had to execute 1 command at a time. So they had to be careful not to overload this little computer with too many commands. All right, so it had a high-frequency collision avoidance sonar. You'll see that in the next slide, but it's like a forward-looking and a side-scan sonar where they could search for objects and then avoid, of course, running into like the side of a mountain or the side of a sunken ship or something. The side-scan sonar could look out to approximately 1,800 feet. it has different modes with different ranges. So here in this picture, you can see the pie slice, like forward-looking part of the high-frequency sonar. Those displays, as you're looking at them now, are in passive mode. That is not active. I assume the active is still secret, so I'm not going to talk about it. But since they're showing you the passive, do you see how the background for this part of the screen here is blue, where my cursor's at? Well, that means low background noise, nothing there. Blue representing clean water. But these green spikes, these green areas, that means that there's a rise in noise in that direction. So you've got something making noise there. Now, obviously, shipwrecks that have been on the bottom for years don't make a lot of noise. So there is also an active mode where that thing kind of pings out. Imagine like from the movie Aliens, those motion sensors that pinged, very similar to that. Yeah. And, but we're not going to go into how the active one works. You see a lot of the TV cameras that they have here are mounted on the bottom of the submarine, and there's even a periscope TV camera. This is one of the first American submarines to use a TV camera as a periscope. Yeah. Very cool design. So the con, as we come to call it, changes over the years. It has multiple upgrades. And so these are some of the different configurations that the con was in over the 40-year period of the submarine's operation. Here at the top, you see a lot of danger tags hanging. These are valves that are locked in a position so that they can do testing and work on systems without spewing high-pressure air or hydraulics all over the place. It allows you to work on systems without draining the energy out of the systems unless you need to. Oh, and this right here, this is the Yuck 44 computer. This is an air vent. The air vent is larger than the computer itself because this thing made a lot of heat. This thing was like a space heater whenever you walked by it. Yeah. And this keypad here and these little toggle switches, these are how you would program the registers. Yeah. Very, very old school programming. Kids these days with their keyboards and mice. All right, the first crew. Every crew member and officer had to graduate power school. So that didn't just apply to the people building the submarine. If you were going to be on the NR1, you had to be a nuke. You had to have graduated from nuke school. Every submarine officer in the submarine force for the United States Navy is a nuke graduate. But not every enlisted man is. Only the people that work in the engine room are nuke graduates. So every one of these crew members were Navy power graduates. And that kind of made me jealous because I saw the NR1 parked next to my submarine for years and I wanted to get orders to it, but I was never eligible in my entire career, only because I never went to nuke school. But every one of these guys, as young as they look, they are extremely intelligent, no matter what color shirt they're wearing, whether they're an officer, an enlisted man, or an engineer, or the scientists that go underway. These are a bunch of very incredibly intelligent people. That man the NR1. They're individually screened. Every crew member is individually screened throughout the entire program. January 25th, 1969, the NR1 is launched into the Thames River. There it is being christened by Miss Robert W. Morse. And so the keel was laid in 1966. It was launched in 1969, so approximately 3 years to get launched. It's, again, never commissioned. It's very important that you don't commission this boat because the moment you commission it, it falls under the umbrella of a lot of other departments other than the Bureau of Ships. So it's going to be launched, it's going to go do sea trials, and then it's going to disappear into the Special Projects Program. All right, so here's the Naval Reactors 1, NR1. It is 148 feet long, 13 feet wide, has one miniaturized nuclear reactor, 2 propellers, 3 blades each, 4 ducted X-mounted thrusters. They can make about 5 knots on the surface or about 4 knots submerged from the 2 3-bladed propellers. This submarine will be towed everywhere because if it's such slow surface speed, it just basically has a support ship with it every time it goes anywhere. And so it gets towed at about 15 knots or whatever the speed is. It's usually about 15 knots out in deep water. Oh, and whenever it's being towed, it submerges itself. That's right. Once they get out into deep water, this thing will get tossed around by the big waves of the ocean. So they'll submerge to about 150 feet while being towed. Yeah. So you'll see a ship with a tow line coming off the back, and that goes right down into the water. And then down there, the submarine is more stable underwater, and it's safer actually for them to operate. Of course, the reactor is critical the whole time. It's providing electricity for the boat. But it's still going to be submerged as it's being towed. Okay, test depth 3,000 feet and 25 days max endurance with a 13-man crew. So a few notes about that. They had to eat basically microwavable meals. They did not have a microwave. They had a convection oven that they borrowed from the P-3 Orion airplane. They put that on here as the only way of making food. It was this convection oven. It would heat up the meal and you would eat it. So they didn't always have all 13 members on board. Sometimes they did, but they didn't always have that, especially whenever they were being towed and transiting. They would maybe have 9 or 10 because they didn't need the scientist or whatever. So, but if the full complement of the crew, they could last up to 25 days. But it's a very crowded submarine for food for 13 people for 25 submarine. Because we'll show you right here. The crew could really only use half this already small submarine. So let's take a look at this from, say, the aft end, the rear end, going forward. So you got your 2 3-bladed propellers back there, and then you've got your stern thrusters. These thrusters are in an X configuration, blowing up and to the right, down and to the left, and vice versa. This allows the submarine to hover in place and spin around without actually moving anywhere. These thrusters are very cool. Just forward to that is a lead shot dispenser where tons and tons of lead shot were held as ballast. And so in the event of an emergency, if they just could not get to the surface, they could always release this lead shot, giving the submarine a lot of positive buoyancy and rising it up to the surface. Just forward to that, you see the first one of the 2 wheels on the keel. Above that is the engine room. The engine room is still secret. We're not going to talk about the engine room in detail other than that it did have a very low power reactor. You could imagine this reactor creates about as much energy as a diesel engine, like a diesel engine in your car or truck. It's not very high powered at all, but it is nuclear. That's important. All it does is it makes enough energy to turn a turbo generator that creates electricity, and everything, including the propellers, are turning on electric motors. Everything's electric here. So the only thing the reactor does is make electricity via the turbo generator. All right, we have some variable ballast tanks in the keels between the 2 wheels. The variable ballast are used to flood and drain seawater to kind of trim the ship, to give it a neutral buoyancy while submerged so they can maintain depth. Just forward to that is the lead shielding. So the one unique thing about this miniaturized nuclear reactor is that it did not have any shielding around the reactor itself, which is extremely unsafe. And unlike the United States nuclear program, as safe as it is, there's shielding on everything except NR1. In order to save weight, because again, this thing is already only doing 4 knots. If they put any more weight on it, it won't be making any headway at all. So they had to remove as much weight as possible. So they put one lead shield between the forward compartment where the crew is and the engine room. This essentially makes the engine room, the entire engine room, a reactor compartment itself. Nobody is allowed in the engine room when the reactor is operational because there's no shielding in there. You'll go in there and get radiation poisoning. So the crew could only stay in the forward 1/3 of this already very small submarine. There it had 4 racks stacked one over the other. And this is officer berthing, enlisted berthing. This is everybody's berthing. Everyone's sharing a rack, even the captain and the XO. And yeah, you only had 3 officers on this thing. So, nobody gets their own rack. There's just no room for it. Everybody may have their own rack and stateroom on board the support ship, but on board the NR1, certainly not. All right, the battery compartment is right there underneath the galley and the berthing area. We had the viewports up forward there where they're right above the manipulator arm looking out through the 3 viewports. Because of the limited berthing, crew members would often go down there to sleep, even though they're supposed to sleep in the bunks. They are often sleeping down there. That allowed them 3 more bunks, essentially, almost doubling the number of bunks on the submarine if they slept over the viewports. The mess hall, or the mess hall / wardroom / crew's mess, had the convection oven there, again, borrowed from the P-3 Orion program. Forward to that was the control station. So you essentially have 4 parts of the submarine if you count the viewing area. So you have the control station, the mess area, the berthing area, and then the little viewports where 3 guys could crawl down there and lay down and look outside the submarine. Very, very tiny tiny submarine. Above that is a little space called the doghouse. The doghouse is the area between the pressure hull where the people are in and the sail bridge where the officer deck would stay when the submarine's on the surface. Because the United States Navy requires two valves, two watertight seals between the people tank, the pressure hull tank, and the outside, they had to have two hatches, one right over the other, to get into the submarine. So they had, it was called the doghouse, and it's this little area that you could crawl up into, shut the hatch below you before you open the hatch to get up into the sail. Forward of that is another lead shot dispenser. That's also where the basket is, where the mechanical manipulator arm would pick up items and throw it into the basket. The basket would lower down from just forward of it there. And then all the way forward of everything were two more bow thrusters in the X configuration, allowing the submarine to, again, maneuver around without moving forward, essentially. So a very small submarine, made even smaller by its weight restrictions. All right, the USS Sunbird ASR-15 support ship. So I talked about the NR-1 being towed everywhere, right? So who was doing the towing? Well, it always had a support ship with it. This support ship was commissioned in 1950, and it was equipped with a deep diving bell. And the deep submergence operations that were designed for submarine rescue, but also, undersea exploration, research, it recovered a lot of Polaris missile items, also known as dummy warheads. So whenever the Navy was testing the submarine-launched Polaris missile, they wanted to recover as much of that missile as possible. They would send out the Sunbird to go and do those missions. But in 1969, all that stopped, and she became the dedicated support ship for NR-1. She would tow the NR-1 everywhere, all the way to the Mediterranean in one case, and all over the Atlantic, up to Scotland, down to the Gulf of Mexico, all through the Caribbean, where NR-1 spent much of her time was spent in the Gulf of Mexico and the Caribbean down there, because it's very shallow, clear, hard, sandy bottom, perfect for a little NR-1 to be rolling around on the bottom of the ocean. In 1990, the USS Sunbird was replaced by a charter boat called the Carolyn Shaw West, which was used as a support ship to the end of the NR-1's career. Oh, and I should mention again that while being towed, the NR-1, once it got into deep enough water, would submerge to approximately 150 feet and down there and just be towed along by the ship. And the reactor was critical during that time to provide electricity for the NR-1. So a very unique situation where a submarine is being towed, also being submerged, and the reactor also being critical. Working as intended, but being towed underwater. So 1969 sea trials, here's Admiral Rickover. He personally oversaw every step of the construction, funding, operation, and of course sea trials of the NR-1. And here you can see him climbing out of the doghouse into the bridge of the NR-1, where there's only room for maybe one or two people up there. So obviously the photographer and the Admiral in this case. On the right-hand side, you can see him sitting on the con with the control stick in hand, driving the submarine around. A really funny story about this photo on the right where he's driving the submarine is this is like day 2 of the sea trials. And Admiral Rickover is in charge of the sea trials. He doesn't necessarily have anything written down. He's just like, well, let's go down to 3,000 feet. Okay. Just kind of making these things up as he goes along. Of course, he's got a plan. It's just not written down anywhere. So on day 2, the captain, the XO have all been up for like 2 days now. Everyone's getting exhausted. The captain refuses to go to bed because he wants to make sure everything goes smoothly. He's very, hands-on, which is fine. But Admiral Rickover says, Captain, go get some sleep. I have the con. And whenever the Admiral tells you that, well, the Admiral has the con, And so the captain did not want to go to sleep because he wanted to make sure everything was okay. He gets ordered to the rack, and he sits down with the most junior crew member, who's still a first-class petty officer, senior guy in the Navy, and kind of looks over at him and says, son, you can drive this thing, right? And of course, the sailor's like, yes, sir. We've been in the trainer down in Virginia, so we can drive this thing around. So he sent the captain to bed, trusting that the crew member could actually perform his duties. And everything went fine on the sea trials. So one of the first things it did was very secret. And it's not very much of this is known publicly, so we're going to not talk a lot about it. But in the early 70s, NR1 was instrumental in surveying the continental shelf off the coast of the United States and all the way down through the South Atlantic as well, to install or guide the Navy as the Navy is installing the SOSUS hydrophones. The SOSUS hydrophones had a very limited number of arrays and lengths that they could use. So they used multiple SOSUS hydrophone arrays all over the Atlantic and eventually the Pacific as well. But they wanted to optimize the location. Like, they didn't want to just lay down a string of hydrophones and hope that it worked. That's not how the Navy works. So they sent out the NR1 to use its side scan sonar, map the bottom, and they took advantage of, surveyed canyons and natural topography to help kind of focus sound towards one location. And then they would put that array in that location. Now, the map you see here is not the array locations. Those are still secret today, and you'll never get them out of me. But what these are the control stations, the shore-based facilities that ran the arrays, ran the power to them, recorded the information from them. We're all the way down. We even had one, well, never mind. There they are. October 1976, she's pulled off SOSUS duty, and she's operating up in Scotland at that time for SOSUS, obviously duties up there as well, when there's a mishap on board an aircraft carrier off the coast of Scotland. This is attributed to throttle failure, so I assume a stuck throttle drove an F-14 right off the deck of an aircraft carrier, just right over the side. And they had weapons on board because they were prepping the plane for action. One of the weapons in 1976 was the highly secret, at the time, Phoenix missile. Phoenix missile was not public knowledge in 1976. This long-range missile that could knock bombers out of the sky from 100 miles away was not public knowledge as it is today. So they wanted to go down, recover as much of the craft as possible, but make sure you get this Phoenix missile, because the Russians have a very successful deep submergence recovery program already in the Uniform and the Paltus. They're off the coast of Norway every year collecting items, and that's very close to where this F-14 sank. So sure enough, they send in the NR-1 with a support ship Sunbird, and they go down, they find the airplane, they find the missile, they recover it, and here's a photo of the captain of the NR-1 and the captain of the Sunfish with the recovered missile topside. Look how happy they look. Anyway, great story of recovering some secret material off the bottom of the ocean that has been declassified now. In 1986, she's pulled off her SOSUS duty again to recover parts of the Challenger space shuttle that exploded during its launch into space in 1986. So a very macabre operation, recovering body parts and equipment. But she did her role to help bring this investigation some clarity to find out what happened. And so she was, among other submarines, down there collecting parts. In 1994 to 1995, she's back in Key West. Like I said, she spends a lot of time in Gulf of Mexico and the Caribbean, including the Key West, which we had a base down there for a long time, so she would pull into that. But she found a large sinkhole in 1984. This was an unmapped, undocumented sinkhole that went who knows how deep. We're like, hey, there's a huge hole here, as they're doing other things. And then in 1995, they're ordered to go back and map the sinkhole. So this huge sinkhole, they take the NR-1 over it, and then they just submerge. They flood that variable ballast tank I showed you, and they slowly go down till they get close to about 3,000 feet, and they still don't reach the bottom. So they found this very large sinkhole off the coast of Key West, which is pretty cool. No one knew it was there, and it was right off our coast. That shows you how undocumented our oceans actually are, that it was that close to shore and no one even knew about it because it's under the water. In 1995, when she's done exploring sinkholes, she's towed over to the Mediterranean, where retired naval officer and oceanographer Robert Ballard uses the NR-1 to explore the wreck of the HMHS Britannic. So this ship is a sister ship of the Titanic. She was used as a hospital ship during World War I, where she struck a sea mine in there off the coast of Greece and sank there. Very sad story, hospital ship, being sunk. So they explored and mapped the wreck with the side scan sonar, got very detailed computer drawings of it, as you see here, and very successful operation. She also, while was in the Med, was asked to help universities find and document the location of Roman and Phoenician shipwrecks. And she was finding so many shipwrecks that they eventually asked her to stop because they had more exploration documentation than they could actually take advantage of. So if they had continued finding more wrecks, they couldn't have, they didn't have time to go out and pick everything up. So they were like, thank you very much for all the information. That's all we need from you right now. So she did a lot of really great work in the 90s over in the Mediterranean. All right. In 2008, she's deactivated from service after approximately 40 years, one of the longest serving submarines in United States Navy history, even though she wasn't commissioned. She is finally deactivated, towed to Portsmouth Naval Shipyard, which is on the East Coast up there in Kittery, Maine, tore apart. And then after she's tore apart, she's towed or defueled. I'm sorry, defueled. She's towed through the Panama Canal all the way around to Mare Island in Washington State, where she's then tore apart for scrapped. She doesn't have a reactor at this point, so she's just sitting there, just a bunch of metal. And it's in 2010, Congress steps in with a House Resolution 2647 and authorizes the Navy to preserve the NR-1 as a historical site, citing her contributions to naval research and exploration and oceanography. Everything she did in her career was pretty amazing, and it would be a shame to lose that. So they decided to save as much of the vessel as they could and bring it to the Submarine Museum in Groton, Connecticut. So she gets another trip, this time on the back of a truck, across the nation back to Connecticut, where she is now, at the Submarine Force Library Museum in Groton. There you can see them assembling all the parts and pieces. They saved the sail. They got the little grappling arm there, the propellers and the rudders all there. And it's very cool that they managed to save as much of that. It is really weird for me to see this as a museum piece, because I remember walking by it for years when she was operational to go to my submarine. You had to walk right by the NR-1. So yeah, it's just crazy to see it. I'm glad they saved it, though. All right, so my final thoughts. Man, I'm a little bit all over the place on this one. So this is one of the few times, if you go back to the very beginning, where one person, a bureaucrat, this time I'm talking about committee member Rickover, made a bureaucratic decision to take action without sharing responsibility with anybody. If the NR-1 program had failed or gone terribly wrong, only one person was to blame, and that was going to be Admiral Rickover. He took a real risk. You don't see that anymore, anywhere. I don't know of any bureaucrat that will take action on a construction project worth millions of dollars that he's going to be the sole person responsible for. Everybody likes to make a decision by committee now in the United States bureaucracy, so that if something goes wrong, we can point fingers in all sorts of different directions. Well, Rickover wasn't having any of that. He's like, I don't want any of you guys involved in my project. I'm doing this. And it's one of the few times in the United States history that we get to see that in action, and it worked. It was great. This is one of the smallest nuclear reactors ever used on a naval vessel. This is similar to reactors that, in size anyway, that they put on satellites. Very, very small. It is an unshielded nuclear reactor, which made the entire engine room basically a reactor compartment. It is very unlike Rickover to do that. I'm sure he didn't want to, but it was a necessity because the small amount of power this reactor created. It was very, like I said, it's like a diesel engine in terms of, energy that it puts out. Very, very small. So they had to save weight. And one of the ways they saved weight was by making the reactor less shielded. They didn't have any shielding on the reactor itself, on the vessel itself. All the shielding was simply between the crew compartment and the engine room, right there on that wall, lead shielding. Very unlike Rickover to do that. Okay, it had to be towed everywhere, which is weird since it was a nuclear-powered vessel, but it was only capable of 5 knots on the surface, and that's kind of rounding up a little bit. So in order to get anywhere within a reasonable amount of time, it had to be towed. But considering all that, it's still an engineering marvel that they made something so small, nuclear-powered, function for about 40 years. this is a great success story. And like I said, you can see it now. It's on display at the Submarine Museum in Groton, Connecticut. It's right off the main highway. So if you're ever driving through Connecticut on I-95, consider taking an hour or two out of your day to go by the Submarine Museum and take a look at this. It's really incredible. Delta 3 SSBN Project 667BDR. We're adding a letter to each one of these. Delta 3 has 3 letters, BDR. Project name is Kalmar, which is Russian for squid. And this is the subbrief. All right, so our story for the Delta 3 begins in February 1973 when the Mechanical Engineering Design Bureau builds a new missile, the R-29R. It's going to be a brand new missile. It's a little bit taller, a little bit bigger than the previous missile. So they approach Chief Designer Kovalev and says, hey, we got this new missile for your Delta series. Why don't you go ahead and make us a new Delta to fire this R-29R? And sure enough, that's what he does. They take the Delta design, they rip out from the design paperwork the complex, the missile complex, and they put in the new missile complex called the D9R complex, which is a lot taller. It rides up a lot higher topside than the previous one and is designed to launch the R-29 missiles. A few other things that they added, they improved the fire control system for the salvo launch so that they could launch all 16 missiles in one salvo. If you remember, the Delta II had that unique old school from the Delta 1 fire control system where they could only launch 12, but they had 16 missiles. So they had to launch 12, rebalance everything, repressurize everything, and then launch the last 4, right? So obviously that wasn't ideal. So they did improve the fire control system so they could launch all 16 silos or tubes in one salvo. They have the VM4 reactor, which is the same reactor on the other Deltas, but the vessel's a little bit bigger. So it holds 16,000 liters of primary coolant now, what that means is they can move more coolant or heat more coolant and send that coolant to the steam generator, which would create more steam. But it's also the same engine room. So they're not really getting any more power from it, but they do have the ability to send more steam to it. So if they're not careful, they could break it, basically. But they do have a larger vessel around the reactor now, up to 60,000 liters of coolant. The Tobel M2 is the new underwater navigation system. That's the inertial navigation system. And the M2 can go 2 days, or I'm sorry, more than 2 days between fixes. The Tobel M1, they had to fix their position on the globe every 48 hours. Now we can go longer than that. So it's a significant upgrade, which means they can stay submerged for longer periods of time without surfacing or at least coming to periscope depth and getting some kind of astral fix from the stars. And they also have the Schmel fathometer. Now, this is a very complex fathometer that actually maps the bottom directly below the submarine. It doesn't look out very far, but what they have is some very detailed charts. Russians have very detailed oceanographic charts of the Arctic region, Norwegian Sea, and other places around the globe, but we're talking about this region primarily. And what they can do is they can do like a star pattern, crossing the same point over and over again and looking at the area around it a few hundred meters. And they take that data, the depth, the slope, the bottom composition, and then they go to their chart and they have an idea of where they're at, but they want to see exactly where this point that they're crossing over and over again is on the chart. And they can get a fix using the Schmel fathometer doing that method. This is the first high resolution fathometer the Russians have that has the ability to do this bottom mapping for location purposes. So very good tool. They no longer need to come to PD to get a fix. They don't need to get a GPS as they would today with a radio antenna. They can stay submerged and, every 3 or 4 days, just refix their position without ever coming to periscope depth. Very powerful. Force multiplier. Okay, the R-29R is the SSN-18 NATO name Stingray. It is the third missile there, the one that's in the very center of your chart. As we go through the deltas, we are slowly working our way through all of these. We only have one more to go, and that's the Delta IV, which we'll be doing next. But for right now, we're talking about the R-29R, the SSN-18 Stingray, was operational in 1979. A caveat to that is the original Mod 1 which was obviously the one they tested first, was technically operational in 1977, but the full range of variants was operational by 1979. It is a 2-stage liquid-fueled rocket. It has multiple warheads. It can have a 1.45 megaton warhead or up to 7.1 megaton warheads. And there was 3 versions of these. It's 14.6 meters tall. It is 1.8 meters in diameter. The 8 kilometer I would say got an 8,000 kilometer Mod 1 range. That's with the 1.545 megaton warhead, or the Mod 2, the Mod 3 has a shorter range of only 6,500 kilometers, but it has multiple warheads. The Mod 2 has, I believe it's 3 warheads. The Mod 3 has 7 warheads, 7.1, smaller nuclear warheads. It has the same accuracy because it has the same azimuthal astral correction that the earlier, R-29D had. So it's 1 kilometer accuracy there. Okay, so the R-29 submarine launched ballistic missile tested at Kasputzen Yar Missile Facility. It's the SN-19 or SN-18 NATO name. Comes in 3 versions. And there we see that the Mod 2, which has 3 warheads, each one of those is only 0.2 megatons. And here you can see them loading one of the missiles, one of the variants, into a test tube, if you will. And they're getting ready to do a launch. That is in Kasputzen Yar. All right, so the Delta III SSBN by the numbers. She's a little bit bigger because we're putting a bigger missile deck on her. So 13,700 tons submerged. She's 157 meters long, 11.8 meters a beam. With the missile housing, now she goes up to 19 meters tall. So the beam is the widest point of the submarine at or near the water line. But if you wanted to measure from the keel to the very top of the missile deck, that would be 19 meters. And I added that in there just to give you an idea of how much larger the missile housing is in the Delta III from the Delta II. It's significant. Her speed is 24 knots, which I believe is only 1 knot less than the Delta II. So they're, in that range. They'll never go 24 knots. I mean, there's no point, unless they're running from a torpedo, they're not going to be going 24 knots. Even though in the picture we show the 7-bladed screws, she also began her life with the 5-bladed screws, but they installed the 7-bladed screws after the 1990s on the ones that were still operational. Test depth is 400 meters. That seems to be the standard unclassified test depth. We know they can go deeper, but typically they stay, 400 meters or shallower during normal operations. Launch depth is near the surface, so there's really no reason to go that deep, unless they're trying to hide, or they're under ice. They need to be that deep. Okay, at sea days is about 80. The officer and crew are 130 warm bodies, and they have the Millennia M satellite communication system, which is the same one they had on the previous version. It just works, so why bother with it, right? They have the 2 VM4 reactors that we talked about, 2 shafts, 5 7 blades apiece. Again, they began their life with 5 and they went to 7. They never mix 5 and 7 at the same time. Let's make that clear. You either have 2 5s or you have 2 7s. All right, so the D9R missile complex has 16 missile tubes. The names of the 3 versions of the missiles are the R-29R for the single warhead 0.45 megaton. R-29RK is the 3 warhead 0.2 megaton, and the R-29L is the 7 warhead 0.1 megaton apiece. And those are designed for soft targets like cities and stuff. You may say, well, 0.1 megaton isn't a lot. Well, it's not a lot compared to maybe some mega bombs, but it'll still screw up a city. So, but they normally went underway with the R-29R and R-29RK. The 7 warhead one was deployed, but it was not often. All right, so we have 4 53-centimeter torpedo tubes. They did carry a complement of 8 shoulder-launched, man-portable Strela SAM missiles that they would take up to the sail during surface transit. And that's just to deter any, maritime aircraft from coming around too close. It's a very short-range missile. Think of it like the American Stinger. They have the Rubicon sonar, the Tobel M2 navigation systems that we talked about, and the Cascade radar, also known as Snoop Tray. And I always love hearing Snoop Tray come in from the ESM operator, because I knew that whenever we had Snoop Tray, we had submarines in the vicinity, and they were on the surface, obviously using the radar. They were going to dive, and as soon as they dive, they were going to come into my territory. We were going to snap them up, and we're going to trail them for a few days, run some tape on them. Yeah, submit that. That's right. Submit that to the Office of Naval Intelligence. So Snoop Tray, one of my favorite radars. Always love hearing Snoop Trays out there. All right, let's talk about Delta III missile hatch sequence. Some great photos here from our friend Saturn X. Starting on the left, moving to the right, they begin opening up the missile hatches. Now, one thing I want to point out is all the missile hatches appear to begin opening at about the same time, so it's not one at a time. But look at the hatch all the way on the front of the submarine on the left-hand side. You can see the front hatch, hatch 1 we'll call it, is almost all the way open immediately before any of the other hatches begin to come up or have any severe, any progress. So that one is, slammed open right away, it looks like, and then the other ones are coming open too. This tells us a couple things. First of all, the D9 missile complex is cut up into 2 compartments. You have the compartment 4 with 8 missiles, compartment 5 of 8 missiles. 2 should be completely independent systems. But in this case, if they are independent hydraulic systems, the hydraulic systems are cross-connected, so they act as if they're one system. And because missile hatch 1 popped open so fast, we know that the pressure from the hydraulic system 1 can't feed all the silos, all the missile tubes at the same time. So it doesn't have enough pressure. Whether it's 3,000 pounds or 4,500 pounds hydraulics, whatever it is, it's not enough. But the next thing we can tell is that it comes in from the forward of missile compartment 4 and feeds its way backwards. So the pressure hits tubes 1 and 2 first, pops those missile hatches open, and then whatever pressure energy is not used by 1 is used by 2 or 3 and 4, and then 5 and 6, because it's used in pairs, all the way back to the very last hatch. Now that's kind of a small, kind of an engineering something I noticed, but whenever you're doing analysis of these pictures, it's little details like that you want to make a note of and submit to the people that use this information. You have, there's a very clear difference in the responsibility of the analyst, which is what I was in the Navy, sonar analyst, and the people that use that information for either engineering or tactical information. The rate at which the hatches open is important. It's a small piece of the puzzle of how long it takes to launch a missile, to prepare the missile for launch. And one of the big advantages we had when we were tracking them is whenever they began missile preparations, it took them a long time. By the time that Delta III came around, it was under 7 minutes to go from absolutely nothing to launching the missile, under 7 minutes. But in the Deltas 1 and 2, that was upwards of 20 minutes, So while they're getting better, measuring these hatch times is just a small component of that formula. But as you can see, as more and more of the hatches are kind of lifted out and they have some leverage because they're pivoting on that hinge, they begin to all kind of open at the same time. But if you're thinking about, working for the government as an analyst, that's the kind of mindset you need, is look at the details and then try to find out why is that hatch on the left-hand side fully open before any of the other ones even begin. And that is my analysis of the hydraulic system of the D9R. Okay, here's some pictures from the top side looking at the hatches all the way fully open. I want you to notice, for those of you that haven't noticed yet, I'm going to go and point it out. Hatch 9 didn't even open. So there's obviously a casualty, or that hatch is tagged out for maintenance, but they've only got 15 of the 16 hatches open right now. Now, if you look at the right-hand picture, you see the little what do you call them? I don't know, bars that are coming up from topside. Those bars screw in, and then you loop a little white safety rope around it just to keep people from accidentally walking into a tube that could be empty and could fall down, 11 meters to the bottom. That would hurt, 19 meters to the bottom. The thing that's funny about these rods that hold the safety line, the exact same rods are used by the United States Navy. The company that makes these little safety lines is selling to the Russians and the Americans. They're double dipping, those guys. But anyway, I thought that was kind of unique how they seem to use the same safety lines that we use. And I'm sure it's just a coincidence, but little details like that made me chuckle when I saw these pictures from Saturn X. All right, let's get on with our first hull. K424. Keel was laid 1974, and she was launched. That's out of the construction building, rolled back into the floating dry dock, and that floating dry dock takes her over to the pier side, where she submerges. She's pulled out of the floating dry dock and tugboat over to the pier. That's what the launching process is. From there, she goes on sea trials, where in 1976 she promptly runs aground and damages the hull a little bit. So not a good start to the Delta III program. All right, in November of 1976, after she repairs the damage from the September collision, she does the first successful launch in Soviet history of the R-29R missile from a submarine. And she's finally, with that missile test successful, is commissioned at the end of the year, New Year's Eve, right? No, just before that, 30 December 1976, she is commissioned. 1977 to 78, she does extensive missile testing for the R-29R, and that makes sense. This is the first missile boat with this missile. They want to, work out all the kinks and the bugs. They've got 3 variants to test. So she's throwing a lot of missiles over to Kamchatka from the Barents Sea and White Sea right now. In 1980, she test launched from the Norwegian Sea. And the reason why I point this out is, if you look at the top of a globe, you can go from the Norwegian Sea to the Kamchatka Peninsula without really violating anybody's airspace. It's kind of like you're going over the Arctic airspace that nobody really owns. But the Norwegians always got real upset because every time they launched something from the Norwegian Sea, they would claim that the missile body went or violated their airspace. And you know what? Maybe it did a little bit, but if you were a dum-dum civilian looking at the nightly news and they show the Norwegian Sea and they show the globe from the side and the Kamchatka Peninsula is way over here on the right, it looks like the missile trajectory would go over Norway and Finland and Sweden and everything else, all the other countries. So it was real easy for the Norwegians to make these protests going, hey, stop launching over our airspace, when in reality, they were launching these over the Arctic Circle. But so that's just something to look out for whenever you see protests in the future. We see this right now with North Korea violating Japan's airspace, launching short-range ballistic missiles into the Sea of Japan. And, that's an entirely different case. But know that their complaints are kind of, political, more political than anything else. Okay, 1982, they surfaced 14 times through the ice. They basically wrote the book on Arctic launch operations. So they would just surface through the ice. They'd go topside with their big boat hooks and just push off these large, iceberg-sized pieces of ice off the hatch. The hatches could actually open with up to like 6 feet of ice on top of them. And some of these pictures coming up, you'll see that ice. It's huge. And they flop open the hatches and toss the ice off like it's nothing. But they also send the crew members up there to push as much of the ice off as they can. And, here we have the R-29 missile test. Again, she tested 4 of the R-29Ls, 6 of the R-29Rs, which have the 3 warhead, 0.2 megatons, and 12 of the R-29RKs, which have the 7 warheads. Very busy boat. Continuing with the K424, in 1983, she dry docked in Nurpa shipyard. That's up there in the Kola Peninsula by Murmansk for some, dry dock time. In 1984, a missile patrol on the equator goes down the Atlantic side. So what she's doing down by the equator, even though she wouldn't normally have her missions down there, she's testing the navigational system, because the navigation in the Arctic and the navigation on the equator are 2 different methods of navigation. And this is the lead boat in a brand new version of the Delta. So she's basically doing sea trials as an operational submarine, making sure that everything is copacetic. And so she demonstrates that she can cross the equator and not lose her bearings. In 1984, while loading missiles, a mechanical failure occurs and kills 2 sailors. This happened in port while loading missiles. It's not explained what the mechanical failure is, but it probably had something to do with the hoisting system, I assume, and sadly took 2 sailors' lives in 1984. Very sad incident happening while loading weapons. Loading weapons is very dangerous, and it's not from explosions. It's from dropping the flipping weapon on you. Okay, in 1986, while launching a missile from the pier, which is insane that they do this, but they launch missiles from port, the ejection failed, and the missile landed back on top of the submarine. And to make things even better, the Red Banner fleet, the top admiral, Gromov, was on board at the time. So after they successfully launched and ejected the missile, the rocket motor didn't ignite, so it just freaking slammed back down on the deck, broke into a million pieces. The liquid fuel immediately ignited, caught everything on fire topside, scorched topside. But because all the other hatches were closed, no smoke got inside, it pretty much burned topside up, but it didn't damage any other missiles. And I'm sure they had a chat with the admiral after that investigation happened, because of all the times for the rocket motor to not ignite, being surfaced in port with the admiral, just bad luck. All right, 1986, she goes on a missile patrol near Iceland, which is interesting because she doesn't normally operate out that way. You can rest assured NATO is tracking her every move at this point in 1986. I can confirm that personally. In 1987, dry dock at Sevmash for repairs. And from 1989, after dry dock, to 1992, she has 3 missile patrols. And in 1995, she's removed from service. And in 2011, her reactor is in long-term storage at Saudi Bay. All right, so let's talk about some of these shipyards. We talked about her going into NERPA shipyard. I thought I would show you where that's at. Again, it's on the Kola Peninsula. It's right outside the Polyarny Inlet, which has, on the south side of the Polyarny Inlet, the inland side, is where Sevmash is, or Severnensk. And Severnensk Machine Shop is in Severnensk. You see NERPA right there. The Kola Peninsula is clustered with these relatively small, by American standards, naval bases. And they just park squadrons of submarines at different bases and kind of keep them spread out. So they're not all in one base. They don't keep all their eggs in one basket, if you will. But the basket spans, half the Kola Peninsula, the Russian side of it anyway. All right, so she's in the Murmansk region. That's her address. If you wanted to contact their public affairs office, you could actually call them if you want to. I don't recommend that. But if you wanted to write to them and request, what their PAO has for a public release, you could write to 184680 Russia Murmansk region, NERPA, address it to the public affairs office. You might want to write that in Russian and see what you get. You never know. Even though I do provide you the phone numbers, do not call them. That's not cool. I don't want to get any nasty grams from Russia. Anyway, K441, keel laid 1974. You'll notice that 1974 to 76 was when these submarines were made for the most part. I mean, they will be built all the way up into the 1980, I think it is. But 74, 76, they started pumping these suckers out. Probably, I suspect, this is my opinion, they had already started laying down or had plans and the materials to lay down these keels as Delta 2s when the Delta 3 program came out. And they were like, well, we're already ready to go. Let's go ahead and start building them, calling them Delta 3s with the new missile complex. That's why I think 74 to 76 was so busy building Delta 3s. Okay, so K441, commissioned 1976, does 52 missile tests, 52 of them from the White Sea and the Barents. An insane number of missile tests. This is the second boat of this version, and she's just throwing missiles all over the planet. 1979 to 84, she does 6 patrols under the ice. And in 1986, she's modernized to the Gaz Avora 1 auto throttle. So this is something that the Soviets are famous for. They automate everything. And as of 1986, they're beginning to put the auto throttle on the Delta 3. And that is from the control room in compartment 3, up there where the captain's at, the periscopes are at. It's the heart of the submarine. They simply dial a speed, 10 knots, comrade, hit the go button, and the throttles in the engine room let just enough steam into the engine to get 10 knots by log as ordered. and there's not a human involved other than dialing in the speed. It's kind of an interesting thing. Americans don't use that. We probably should. It'd be easier. But this is one way that they can cut down on the number of crewmen that they have, is by automating everything. The torpedo room has been automated since the beginning of time for Russia. That's one of the first things they automated, because they don't trust their sailors to handle heavy weapons. Anyway, so 1988, under ice transit to the Pacific Fleet to Krasnikov Bay. This happens a lot. A lot of these Delta 3s are going to be built in the, Sevmash, the western part of Russia, the Atlantic side of Russia, and within a year or two, going to be stationed in the Pacific. So that 441 is the first one to do that. She's going over the Kamchatka Peninsula, where she serves over there for an unknown number of patrols. We don't have the dates, but she was removed from service 7 years later. So she served in the Pacific for 7 years. Obviously with distinction. We don't know what happened to her, and then was removed. And then her reactor is now in temporary storage as of year 2000. I don't have an update after that. So hopefully by year 2020, that reactor's in long-term storage, but was unable to confirm that. Okay, K449, the third one we're building here. Again, 74 to 76 construction time. She immediately does 5 patrols under ice through 1982. In 1983, she has a collision underway with something, but has no damage. And I've checked the American logs. There was no NATO or American entry of a submarine collision in 1983 with a Soviet submarine. We had some collisions with ourselves because we're idiots. But in 1983, they had there was no collision between a NATO submarine and a Russian submarine. So it's possible that they hit a whale. They could have hit some ice. It doesn't mean it was a submarine, but they did have a collision. In 1985, they collided again, this time with an ice keel at 300 feet, damaging the superstructure and multiple systems in the sail. That's like the antennas and the periscopes, things like that. But despite that, she completed her 39-day patrol with limited comms, because even though she had some antenna damage, she didn't lose every means of communication, so she was able to continue her patrol safely. In 1987, she dry docked at Sevmash for maintenance. 1990, she does transit to the Pacific Fleet. 1995, she conducts a patrol in the North Pacific east of Japan. So if you go south of Kamchatka on the map, east of Japan in that region, that's where she hung out for 60 days. In 2001, she's removed from service. And in 2002 to 2003, the United States funds the disposal and long-term storage of the reactor. Now, I want to talk about this a minute, because this topic has come up before in previous subbrief lectures, where other countries often fund the dismantlement and safe stowage of the nuclear components of Russian nuclear submarines. And you have to think about this in kind of an ecological and safety way. It makes sense that if Russia is decomming these old submarines and letting them sit by a pier until they rust and sink, they're literally sinking because rust is eating a hole through the steel hull in some cases. That's not good for anybody if that reactor fails and begins contaminating the entire seaboard of whatever country. It doesn't matter what country it is. Even though it starts in Russia, it's not going to stay there. It's going to go around the world eventually. So paying to have them decom these reactors is just the right thing to do. The obvious problem with this program is although Japan, EU to some extent, but the Americans especially, we've been involved in a lot of paying for their decoms quietly without telling the American public about it, is that they obviously take that savings that they don't have to spend, Russia, and they put it back into developing the next submarine and building it. And so we're kind of helping our enemy by protecting the environment. We're doing the right thing, and the Russians are taking advantage of it. And this is going on today. This hasn't stopped. So I just think everyone should be aware of it, no matter what country you're listening to this from, whether it's from Russia or from America or anybody in between. That's what's happening. And if you want it to stop, then you need to, talk to your own leaders about this. I'm not making a judgment of whether it's right or wrong. Although I am leaning towards protecting the world. I mean, protect the environment. We don't want these sinking submarines to be contaminating, large swaths of seashore. But that appears to be that's kind of where we're at with this long-term storage. Is Russia builds it, the rest of the world pays for decomming it. All right, construction is assigned to Sevmash Shipyard. Here you can see the construction building. They have multiple construction buildings. The largest one is the white one on the left-hand side there. They have a smaller one there on the other side. I have some pictures of inside these construction shops where they build all sorts of things. They build small boats. They build submarines. It's quite a busy place. Sevmash is famous, one, for quality of work. They're very good engineers and craftsmen at Sevmash, and my hat's off to them because they build great submarines. It's just the maintenance of these submarines that is lacking. If God forbid, if they maintain their submarines as well as they built them, they would be a much more formidable foe. And this is where it happens. Sevmash is the model other Russian shipyards try to meet in terms of quality, production, and scheduling. All right, let's move on to K455. Keel laid in 74, launched in 76, commissioned in 76 as well. In 1979, she transits to the Pacific via the Atlantics. So this is one of the cases where they don't go across the top of Russia, kind of evading the ice along the way. They take the long way around. They go down through the Atlantic, around South America, and then back up through the Pacific. It takes like 2 months to do this transit because it's a long way. But she does it, ends up in Krasnikov Bay. In 1980, 1985, she's in the Pacific. She does 6 patrols. She's refit at Zvezda Shipyard. Now, this is a little confusing to me. There's a Zvezda Shipyard in Far East Russia, which is by Japan, even though I guess that'd be West Russia. And there's a Zvezda Dalshe Shipyard by Sevmash over in the Kola Peninsula. So I'm just going to point out that this Zvezda Shipyard is over there by Vladivostok. It's right across the bay from Vladivostok. Okay, 1989, 1998, almost 10 years. She does 4 patrols in those 10 years and is removed from service in 2000. In 2015, her reactor is put in long-term storage. All right, so here's the Zvezda Shipyard near Vladivostok in the Sea of Japan. You can see that she's located in a town or city called Bolshiye-Kamen. I've heard this referred to as the Bolshiye-Kamen Shipyard, but that's technically not correct. It's the Zvezda. She's owned by the United Shipbuilding Corporation, so this is a private company operating a military shipyard. And they do other things too. They build, large merchant ships, and they do it all. And you can see right there, they have these great assembly slips where they build the ship or submarine. They just back it right out onto a floating dry dock there. You can see at the bottom of the picture, you can see the top of it anyway. And that floating dry dock will take it away from the pier a little bit, submerge it, floating whatever's inside the floating dry dock, whether it's a ship or a submarine. Anyway, Zvezda Shipyard. All right, K490. Let's move on. 1975 to 77, she is launched during sea trials, leaking upon the dive due to a pressure hull not replacing a steel plug. There's a plastic plug. Let me back this up. Okay, so there is holes in the pressure hull that you run cables and stuff through during the construction of a submarine. So whenever you're done with the cabling and stuff, you or before the cabling goes in, even sometimes you'll put a plastic plug in there just to keep dirt and stuff from outside the submarine from getting inside the submarine and contaminating the area that you're working on. Because after you run cables through there, in the case of a cable run, you need to keep it clean and then pack it with watertight material, right? Well, one of these plugs never gets used, or they never finish running the cable through it, or something happens where the plastic plug that leads to the outside of the submarine to the inside of the submarine stays plastic. It can't withstand any pressure whatsoever. So the moment they dive, they have a stream of water that goes into the control room, comrade. And they're like, hey, stop that. They put something in front of it. They obviously surface immediately, pull back into the pier and be like, hey, finish building our submarine. They put a steel plug in it to finish making the internal part of the submarine watertight again. Thank God they didn't get any more than a few feet down before they saw the water come in. It wasn't that big of a deal, but whenever an oversight like that happens, it makes you wonder, it's like, well, what else did they miss? So after I just talk about how good Sevmest Shipyard is, they pull something like this. Anyway, they get through sea trials. They commissioned at the end of September 1977. They participate in war games in 1978 in the Barents Sea, and they collide with a Charlie SSGN, have minor hull damage to both. So not a good time for K490 after sea trials. Their first real public war game, they end up colliding with somebody. 1979, they're like, get out of here, go to the Pacific Fleet, so you stop running into our submarines and trying to sink in our Barents Sea. They send them over to Krasnikov Bay. And in 1984, Missile Patrol in the North Atlantic is her first actual missile patrol after her commissioning. 1984. Almost, 7 years later? All right, K490 continued. 1986, she pulls into Zvezda Repair Yard. That's the one we just looked at. And in 1993, she does conduct a successful missile test. And in 2003, she's removed from service. 2006, again, the United States comes in with the cash, funds the removal of reactor. You're welcome. It's in long-term storage. Okay, Russia's Pavlovsky Bay and Krasnikov Bay. I just want to show you where these are geographically on the Kamchatka Peninsula, which is that big-ass peninsula that comes down out of Siberia, right across from the Alaska-Bering Strait. Now, Pavlovsky Bay is on the actual mainland peninsula. It is the larger base. It has a shipyard and a lot of ships that, after they go into their first dry dock period, long-term dry dock period for maintenance or whatever, they'll just stay in Pavlovsky Bay and operate out of there. But whenever ships move from Sevmest and the Barents Sea and are transferred to the Pacific Fleet, they are almost always initially stationed at a Krasnikov Bay, which is a large submarine base as well. Look at it right there on the picture. It takes up a good portion of the little island that it's on. And one of the advantages that it has is that the transit time between Pavlovsky Bay and Krasnikov Bay is about 1 day. So round trip, that would be 2 days. That adds 2 days to their patrol time or at sea time or on station time just by being stationed out of the southernmost submarine base. They're adding at sea time for free, you know. So that's why a lot of them are stationed out of Krasnikov Bay. It's more of a geographical thing. There's more facilities up on the peninsula than there is in the Krasnikov Bay. All right, let's go to K487, another Delta III. This one built 1975, commissioned in 1977. From 79 to 1980, she has 4 missile patrols in the Arctic Sea. 2 patrols of the 4 were a 60-30-60 rotation. And this is where they do that push to, you know, if this was a war situation, this is how you would rotate. And so they practice this. They do a 60-day, missile patrol. They pull in for 30 days, which is enough to do maintenance, restock the food, swap out the crew if there's any swapping going on, retrain the crew if they do the swap, and then go back out again for 60 days. The U.S. Navy does this, and we recently did this with one of our carriers in, I want to say 2017, 2018. A carrier in the Pacific Fleet, United States carrier, deployed from San Diego, went to Japan, which is normally like a 9-month deployment, and then operated in the Pacific for 9 months, came back home for 30 or 45 days, and was ordered back to sea for a full deployment. And it's just to practice wartime rotation to make sure that our supply system and material training can handle that kind of stress. It really sucks for the crew when that happens, but it has to be done. And the Russians are doing it too, just to make sure that they can operate at a wartime tempo. And they do this 2 times between 1979 and 1980. January 1981, fire in the third compartment near Spitsbergen Archipelago. That's in the Norwegian Sea. They use the LOX fire extinguishing agent to put out the fire, but 5 sailors in the compartment are unable to escape and are asphyxiated by the fire extinguishing agent. Again, adding to the kill count of this fire suppression system. At this point, by 1981, this fire suppression system the Russian Navy uses has killed far more sailors than any fire has. It's lethal. And the problem seems to be they have a procedure to seal the compartment, which obviously is a good idea if it's on fire, but they're not letting the sailors in there out. If they don't get out in time, sorry, comrade, You're just going to have to wait until we're done fighting the fire. And it's never enough time. Every Russian sailor, if you've seen pictures of them underway, carries around a portable respirator that has a small amount of air for them. And whether that air is 5 minutes or 15 minutes, I don't know. But I can tell you this, it's certainly not enough. The way the American sailors do it is we have piped air from the high pressure air tanks that are reduced, obviously, so you don't breathe in 4,500 pound air, but you have a ton of air, big ass air supply, forward and aft in the main ballast tanks that feed these emergency air breathing manifolds that are, at waist high level and in the overhead, and they alternate. So that if you're ever in a compartment that you can't get out of, you could always grab an EAB breathing mask, plug it into this manifold, and have hours and hours of breathing. The Russians don't have that system, and it's killing sailors when they have sailors trapped in a compartment full of smoke. It's kind of sad, but that's how they operate. Okay, in 1982, 1985, they do 4 patrols under the ice. In August 1985, they use 2 torpedoes to make a hole in the ice, which is crazy as shooting a freaking ballistic missile from a pier. They shoot live torpedoes underneath the ice, detonate them at about the same spot to break the ice apart, and then they go and they surface through the hole and conduct a missile test. In 1985, for the first time, the escorting Victor, which is a fast attack, surfaces beside her a few hundred meters away, and they're both sitting there on the surface after the missile launch, bobbing around, playing soccer on the ice, looking for polar bears. In 1987, she goes to the shipyard Sevmash, that's again near the Barents Sea on the Kola Peninsula, for maintenance. K-487 continued. After she comes out of the shipyard, she goes to sea again, conducts 3 patrols in 3 years, 1992 to 1994. In 1994, while underway, she collides with B-138, which is a Victor III fast attack submarine. It is not clear if this was her escorting submarine, but it probably was, because the Delta IIIs are going underway with fast attacks with them all the time at this point. It just makes sense, because the fast attack can keep us, Amerikanskis, away, at least at arm's length, while they go and do their missile patrol. It's not stopping us from watching them, but it certainly is keeping us from getting too close to them. Anyway, and you can see the damage there. Pretty significant damage to the forward part of the missile housing right as it reaches the sail is where they bumped. They're very lucky they didn't damage that missile. That could have turned into a real disaster. Okay, 1995, a small primary coolant leak of 30 liters a day, quote, small, is discovered, and they pull into port for repairs. Keep in mind that the vessel carries 60,000 liters total, and they have a feed tank where they can keep feeding, primary into the vessel. But still, whenever you leak a single drop of primary in the American Navy, it's all stop, decontaminate the sailor, even though it's a drop of water. It's a big deal. They do 30 liters a day. That's over a liter an hour gushing into the bilge, and that's a small event. It's just 2 very different perspectives on nuclear safety here. 1998, she was finally removed from service, and in 2011, the reactors moved to long-term storage. KE-44 Raisin. Keel's laid in 1980. We're jumping a little bit ahead here, but we're going to jump up to 1980, commissioned in 1982, because K-44 is a special boat. In 1983, missile patrols with Victor III escorts are observed again. So by now we're seeing a pattern of that. In 1984, her towed array is damaged by her screws because her auto throttle failed. Remember, we talked about that throttle being automatic. And part of the reason why American navies like to have a man on that throttle instead of it being automated is because of things like this. So they probably threw on a backing bell is what I think happened. And this could have been operator error too, because the auto throttle works in forward and reverse. So maybe the auto throttle did exactly what it was told to do. And instead of going forward 10 knots, it went backwards 10 knots. Anyway, anytime you got a towed body behind you, whether it's a radio buoy or it's a towed sonar array, if you put on a backing bell, you're going to chew up that cable right into the screws like it's a blender. And that's what happened in 1984. 1985, fouled both propellers in a trawler net, just like it had done the year before with its freaking towed array cable. And was towed to port because they had fouled the propeller so bad, they couldn't turn the shaft. No word on what happened to the trawler. Trawler nets do have an automatic breakaway after a certain number of pounds of pressure are put on them, so they don't drag the trawler underwater. But in the 1980s, trawlers, especially in the Sea of Japan, had been pulled underwater by American submarines or Asian, Japanese, whatever submarines, not just Americans, and injured or killed some of the crew. So, but in this case, there's no entry about what happened to the trawler. We can assume that it simply lost its net. Also, this net could have been lost previously, months ago even, and just drifting around. And whenever that happens, that sounds creepy. Let me tell you about this. I've heard this a couple times. It sounds like wind chimes. And the things that are the wind chimes on these trawler nets, if they're just floating around the ocean, is they have these little hooks, relatively little to the size of the net anyway. And the hooks obviously are made of metal, and they have a hinge that allows them to freely swing back and forth as they go through the water. And so if the net is just floating around and the current, the ocean current, is just kind of pushing the net back and forth, those hooks hang down like wind chimes, and they bang against each other, or they bang against the housing, making this eerie, horror movie-like sound of high pitch, nonsense, musical tones almost. And you could recognize it right away once you've heard it a few times, and you just stay the hell away from it because you don't want to get it fouled in your net. But that's what happened to them in 1985. Okay, they completed 6 missile patrols under the ice during the 80s total, besides those incidents. In 1990, her post-dry dock sea trials found damage to the ballast tank vents not sealing, which is really bad. So obviously, whenever they try to blow main ballast tanks, they can't keep air in the ballast tanks, which means water's coming in the bottom, making them negatively buoyant and slowly sinking out. In 1984, she's fully repaired and test fires a submarine launched ballistic missile, becoming operational again in 1984. All right, K-44 Rizon continued here. In 1997, Missile Patrol in the Arctic Sea, she's awarded the name Rizan in 1998. Up to this point, she doesn't have that honorary designation. 1990, while conducting submerged missile test, the rocket separated in 2 parts as it left the tube. So it hasn't even reached the surface of the water yet. It's already broken up into 2 parts. Which obviously it exploded, caught on fire, but it exploded outside the submarine, throwing the missile nose, away from the submarine, but near the vicinity of the submarine, and it was able to be recovered by another submarine later on. Russians have AS, or special submarines, that can go deep, very deep, and pick things up off the bottom. They used one of those submarines to pick up the nose module. Again, it was a test missile. It didn't have a warhead on it, but it does have guidance and other valuable things that they don't want the Americans to come and snag, because we definitely would have done that. So they got it recovered. In 2002, Submerged launched on experimental satellite Demonstrator 2. This is a little known program that they had in the Deltas, Delta 3, Delta 4, which we'll talk about the Delta 4 in the next lecture. But Demonstrator program was to launch observational heliocentric satellites for the military, and they could have been used for civilian use, I suppose, to provide observation or signal intelligence over certain points of the globe at the same point every day. So a heliocentric orbit is a low Earth orbit of a satellite, a recon satellite, that passes the same point on the globe every time of every day. So if they wanted to pass Washington, D.C. at noon, they could launch that, and every day at noon, it would pass Washington, D.C. And the same satellite would pass, Norfolk at 1 p.m. an hour later. As it slowly goes around the globe every day, it's keeping the same schedule. So Demonstrator 2 was a program to try to use submarines to launch those satellites instead of shore facilities. Now, there's a couple reasons why you'd want to do this. Obviously, it's more expensive to do this, so it's not the ideal choice. But in the event of a war, they're going to take out our satellites, and we're going to take out their satellites. There's going to be a bunch of space junk up there, all blown apart, and, it's going to be a long time before we get mass media communications up again in the event of a real war between China, Russia, and the United States or the EU. Any 4 of those operators, space is gone. You can say goodbye to Netflix. You're going to be doing local broadcasting for a while until we reestablish satellite communications. Well, these satellites you could start and end a war quickly with a ballistic missile submarine, and after all the shooting's done, launch a few of these satellites to begin communicating again with the Russian military and have the added benefit of reconnaissance, because that was the main purpose of these satellites. Of course, they had communication capability to share the information, but their primary purpose was recon. Anyway, Demonstrator 2 program, very rare, very little known program that I'm sharing with you here today. For the Delta 3s, it failed. Every single satellite that Delta 3 threw into the low Earth orbit either never achieved orbit, which was it in just about every case. And in one case that I'm thinking of, they launched it into low Earth orbit and then they lost it, because apparently that's real easy to do. It's not easy to track things in orbit all the time. Anyway, so that's interesting. Demonstrator 2 program, everybody. 2005, 3 years later, she enters dry dock for modernization and its service life extension. 2008, she's operational again and launches a missile successfully just as a test. She's back to being a ballistic missile submarine in 2008. She transits to the Pacific Fleet, going to be stationed over there for a while, operating out of the Kamchatka Peninsula. She pulls into the Zvezda shipyard. That's the one over there on the Pacific Fleet side in 2011. 2015, she first missile test fire in years is a success. Simultaneous missile test with Barents Sea Fleet, but not operational. She returns to the shipyard. So she kind of came out of the shipyard to shoot this test as part of this larger program where they launched ballistic missiles from the Barents Sea using another submarine, obviously, at the same time coordinating a launch with the Pacific Fleet. And that is a command and control war game to make sure that they can launch nuclear weapons nearly simultaneously from multiple fleets around the globe. Anyway, but she's not done in the shipyard, so she goes back. In 2019, she's out of the shipyard. She takes part in war games in the Pacific, Thunder 2019. She launches 2 SLBMs, but were amended after the first flight due to a failed launch. So she's scheduled to launch 2 missiles. The first one fails. They don't even try the second one. And in 2020, as of this recording, K44 is operational in the Pacific Fleet. This Delta 3 is still out there poking holes in the ocean with 16 missiles on board, doing her thing. That's the K44 reason. All right, Demonstrator Experimental Satellite Program. I already talked a lot about this, but here's what they did. And this is not the entire program, by the way. We will continue this discussion when we talk about Delta 4, which has a lot more involvement. But for the Delta 3s, they took the R-29R, modified it to become a still carrier missile, or STIL, which is the term they used for their rocket program, basically their NASA launching satellites into orbit. So if it's a still carrier missile, it's a orbital deployment missile, or rocket. So they modified the R-29R to carry this payload up into, heliocentric orbit. It simply doesn't have enough energy, though. It doesn't have enough fuel. Like the 2-stage liquid fuel rocket is designed to throw, ballistic missiles, warheads in a suborbital flight to their target. And that's all it has energy for. And that's why these fail. And so it does have a payload of 1 to 3 microsatellites, and that is staying consistent with the 2 of the 3 mods of the R-29R missile that they have. Remember, they can have 1 warhead, 3 warheads, or 7 warheads. Well, they can have 1 satellite or 3 satellites. They try both. They all fail. This program does not work for the Delta 3. And the primary root cause of the failure is this missile doesn't have enough energy to attain low Earth orbit. They need another missile. We need a Delta 4, comrade. And that's what's going to solve it. But we'll cover that in another lecture. Okay, the Delta 3 launched program has been halted after 2002 and goes on to the Delta 4. Something for you guys to look forward to. K496 Boris Olgoblisk. I nailed that. Built 1975, 1977. From 1978 to 83, she does 10 missile patrols in a 5-year period. So that is high tempo for the Russians. That's normal for the United States, but high tempo for the Russians. 1983 coolant leak in the steam generator caused a return to shipyard for replacement and upgrade to a new steam generator. It's not clear as to what the new steam generator is. It's probably the OK 700, but it's probably a version of that because they had the OK 700 in the old one. The point is, because they have this larger vessel making more steam, they can upgrade the steam generator to generate the more steam, but they're still limited by the same ship or engine that they had in the other Deltas 1 and 2. They haven't changed that. So all they're doing is increasing their ability to break their own submarine by having so much steam created. Okay, 1984, 1985, they do 5 missile patrols under the ice. This is a hot boat. 1991, she dry docks in Sevmash for an overhaul. She comes out of that a few years later. These dry dock periods are long. We're talking 1-2 years. Then you got a sea trial for another year. It takes a long time to get through these long overhauls. 1995, though, she does a missile patrol. She's operational again. 1997, she deploys off the coast of Greenland and mapped a 70 square kilometer part of the ocean. In 1999, she's awarded the Borisoglovsk honorary name. In 2005, she's launched a spacecraft Cosmos 1, but in 2005, it failed to reach orbit because they're still using the R-29R, from 2002 when they failed this with the previous boat. They're still trying again in 2005. They can't get it. Just can't get it up there. They're trying all sorts of math tricks where they try a high trajectory, a low trajectory, different ways to get the payload in. But if you just don't have enough energy, you don't have enough energy. And that's really what they're faced with. But kudos to them to keep trying. They're trying to find a more efficient way to get it up there. In 2005, she launches another spacecraft with modified airfoils. Spacecraft cannot be found. This is the one that's missing. It could be in orbit. We don't know. So they threw it up there and it never came back down again, as far as I know. Surprised they didn't call that a success. Anyway, K496, the Boris. I'm just going to call it the Boris now. 2008, she's removed from service. 2014, the Kotlas Maritime Assembly. Kotlas is a small town near Severnensk. They bought the outer hull. That normally means the sail. That's where the Fairwater Plains are and the bridge is at. They bought the outer hull for 2.7 million rubles, and they're going to make a maritime museum out of it. That was in 2014, 6 years ago. It's probably already a museum by now. So if you're ever near Kotlas, Russia, which is on a river, same river that goes up to the White Sea, past the shipyard, you may be able to see this. They also have a few other things in Kotlas, like they have a large locomotive train. They're big on their museums. They're there at Kotlas. And here you can see the remains of K496 being ripped apart in the shipyard. A lot of those materials, that's a steel hull, is being recycled. That's why you see large parts of it being cut away the way that they are. All right, let's move on to the K506. Built from 75 to 78, she completes 3 missile patrols under the ice from 79 to 80. In 1981, she transits to the Pacific Fleet stationed out of Krasnyannikov Bay. In 1983, she does 2 missile patrols to 1985. In 1990, she heads over to Zvezda shipyard, that's across the bay from Vladivostok, for overhaul. 8 years later, she gets the honorary name Zelninograd. Nailed it. In 2003, she test fires 1 SLBM. That's a success. And in 2008, she launches another missile during Wargames Stability 2008. I like the positive name of that war game. A lot of these war games are like, Thunder or We're going to Kick Your Butt 2019. This one's just called Stability. Like, everybody calm down, launching ballistic missiles. In 2010, she's removed from service, and in 2017, her reactor is confirmed in long-term storage. K211, Petrolovsky Kamchatsky. Built from 1976 to 1976 to 1979. In 1980, she completes 2 missile patrols in 1 year. Hot boat, hot running. Back-to-back missile patrols in a 12-month period. In May 23rd, 1981, she collides with a U.S. submarine, damaging both. Both return to port under their own power. The United States never acknowledged this collision. But it was pretty clearly a United States submarine. It was a, what was the class? It's a Sturgeon class, a 637 class, pulled into Holy Loch, Scotland, about 2 days after this collision with clear damage to the top side of her sail. So there was a collision. I don't know the name of the submarine. Again, it was never officially recognized because the American submarine did not have to surface. They collided. They didn't have flooding. They maintained their trim. So they simply exited the area and returned to Holy Lock. But it most certainly was a United States submarine that collided with them. In this case, the K211 surfaced right away and pulled into port. All right, so 1982 to 1985, 4 missile patrols under the ice. From 1984 to 88, she received numerous awards. These were too many to list, so I just put them all together here. She has Courage of Military Valor, the Pennant of the Central Committee. Central Committee is one of the primary political institutions of Russia. And she has 4 different Challenge Red banners. So different entities inside the government can award them a Challenge Red banner. So you could have like a Challenge Red banner of Sevmash Shipyard or Challenge Red banner of Moscow. You know, she earned 4 of those in 4 years. So hot boat, hot running, you know, making U.S. submarines return to port one way or another, and out there fighting the good fight, being awarded for it. In 1990, she enters dry dock for scheduled maintenance, and in 1998, she's awarded the honorary name Petropavlovsky-Kamchatsky. Continuing with K211, in 2006, she dry docks for maintenance that is not finished. This sadly happens to a lot of Russian submarines, especially after 1992, where they'll pull in for maintenance, especially if they're on the Pacific side, because the Pacific dry docks don't get as much funding as Sevmash gets on the other side, on the Atlantic side. So she pulls in for dry dock, never seen again, and she never comes out of it. In 2008, she's moved to the Naval Reserve Fleet, which is still kind of sort of an operational platform, has a crew, not doing anything. In 2010, she's finally just removed from service because there's no point funding her, you know, and maintaining her if she's never going to go back to sea again. And then in 2008, the reactor cores are confirmed in long-term storage. In 2020, and this is the first evidence I've seen of this, although it's probably happened before, recycling of precious materials begins from inside the submarine. So, for example, they're going to rip out all the equipment and harvest all the copper and all the rare materials that are built in these computer chips. The cable runs in these submarines are miles and miles long, and the cable runs, for electrical cabling anyway, are all copper. That copper is very valuable. It's also very expensive to strip it out of a cable run and strip the binding out from it. But copper's become so valuable that it's made that process profitable. So now private companies are coming in to the shells of submarines that no longer have a reactor in them because it's been cut out. But you have a forward section and an after section just sitting there on blocks, kind of half torn apart because they've recycled a lot of the steel hull. But a lot of the internal equipment is still there. You know, it's open to the elements, it's rusted, it's a mess, but they can recycle a lot of the precious materials. And that's beginning to happen in 2020. K211 is not the only submarine that has private companies recycling them. And as long as they're recycling the materials and not digging the materials out of the ground, I support it. I think it's a good idea. It's a good program. Okay, K223, the Polsk. 1977 and 1979, she transits after her commissioning in 1979 to the Pacific Fleet stationed at a Krasnyannikov Bay. She does 5 missile patrols in the North Pacific from 1981 to 1985. Then she pulls into the dry dock in Zvezda Shipyard in 1986. Unlike other submarines, she comes back out again and conducts 2 missile patrols from 1995 to 1996, almost 10 years later. So again, these Pacific shipyards, underfunded, very slow, inefficient, poor workmanship, poor craftsmanship, poorly managed to the point of corruption level of embezzlement of government funds. Very shady, but this K223 survives all that, comes back out and is operational again in the 90s. It isn't until 1998 that she's given the honorary name Podolsk. And in 2001, she test fires an R-29R missile successfully. So she's out there on patrol, doing her business through the late 90s and 2000s. Into 2004, an air pressure reducer fails in the torpedo room, and this is scary. 4,500 pound air is reduced to 3,000 pounds, and that's reduced to 2,000 pounds, 1,000, and then you have 750, and it just keeps getting lower and lower. And these are all air reducers, air manifolds that begin at like 4,500 pounds. They're really high pressure. Well, one of these big honking blocks of metal that this air passes through as it is reduced fails. Like it just rips apart, and it explodes like a grenade in the torpedo room. The sailor, unfortunately, his name is not recorded in the logs, sees this about to happen. He's like the torpedo man of the watch. This is important, by the way. So he's in the torpedo room. He's got a couple guys in the torpedo room. He calls the alarm. He's like, get out of the torpedo room. And everybody's getting out as fast as they can through the watertight door that is in the back of the torpedo room going to the next compartment. Anyway, so he's the last guy coming through the watertight door when this thing finally explodes. And just by bad luck, of course, hits him in the back of the head, causing him internal bleeding and kills him immediately because this thing exploded. So, but he saved a lot of lives, and his name should be recorded. But unfortunately, in the source that I have, it is not. In 2006, dry dock for routine maintenance in Zvezda shipyard. They're on the Pacific side of things. 2010, she's back at sea testing R-29R ballistic missiles. In 2011, 2014, and 2015, she's conducting VIP underways for Russian and foreign dignitaries, also during war games. And so they're kind of showing off all the new modifications they've done to the Delta III, keeping this workhorse of the Russian ballistic missile fleet at sea. Kind of showing her off that even though this build is 30 years old and going, older, they're still operational, and this is why. This is what they can do. Americans do this a lot. NATO does it a lot. I've never been on the EU boat, so I don't know if they do it, but the Russians are doing this too. And this is more of just if you can't demonstrate yourself in a real war, because obviously that's devastating, especially nuclear war, how else do you show the world how capable you are? Well, you invite their secretaries of the Navy and their admirals, and in a lot of cases, other sailors. We have a great program here in the United States where we send our sailors and officers to British Royal Navy boats for months, almost a year at a time, and they spend a year over there operating their submarines. And then they come back with the experiences that they had, tell us about it, and they do the same to us. Well, this isn't quite that program. This is bringing VIPs underway for either a couple hours or in a few cases even overnight, showing them what they can do. And they do that multiple times from 2011 to 2015. 2017, she's finally removed from service. And in 2020, her reactor is in long-term storage. K-180 Delta III, keel laid in 1977, commissioned in 1980. In 1981, 2 missile patrols are conducted under the ice. She's fully operational. In 1982, she's moved over to the Pacific Fleet, where she does a successful missile test. She operates there through the 1980s, is awarded Best in Fleet and the Courage Banner in 1986 and 87. 1991, Missile Patrol in North Pacific is done successfully with no problems. And I want to take a moment here to pause. Look at how many submarines from the Delta III we've talked about that have not had major nuclear incidents. It is beginning with the Delta III that the Soviet Navy is shedding its laissez-faire attitude towards reactor operation and maintenance. They finally get it that if they don't do their due diligence, they cross every T, dot every I on their maintenance, procedures, they're going to have these terrible incidents. And with the Delta III, we're getting into the 90s and 2000s with no incidents. And whenever they decom their vessels, they're doing it in an ecologically rational manner, even with the help of funding from Japan and the United States. Even though we're helping them with that, they're still doing the right thing. And so it's with the Delta III, they've kind of pivoted from being this almost reckless nuclear power to a more professional nuclear power. All right, continuing, 1995, the she enters Zvezda shipyard for maintenance. Unfortunately, this maintenance is never finished. It is 8 years later, after she's sitting in dry dock, they finally just remove her from service. They're like, we're not going to use her anymore. In 2008, her reactor is moved to temporary storage. I was unable to confirm permanent storage, but it's been 12 years, probably in permanent storage. All right, K433, St. George the Victorious. And I want to take a moment to just talk about St. George the Victorious. In the Russian culture, St. George the Victorious is the patron saint of the sailor and soldier. So he's the guy that protects you in war and will shield you. And this submarine has that honorary name. It's a great morale booster. Soldiers and sailors from eons ago, for throughout history, are awfully, I don't want to say religious, but they're awfully, I think religious is probably a good word to use. Even myself, as I'm not very, very religious. Whenever you're about to go into a situation where, and it's combat, and there's one of two things that are going to happen in combat. You're either going to become a murderer, where you're murdering people in war, or you're going to get killed. And those are the only two options. There's no other option than that. So there's two horrible outcomes. And how do you rationalize that? Well, you do it by starting believing in mystical things and powers, above yourself, that you're doing the right thing, even though it's about to be horrible. And you have somebody like St. George the Victorious looking over you. So this is the patron saint of the Russian sailor and soldier. This keel is laid in 1979 to 1980. She goes on 3 patrols in 2 years, 1981 to 82, hot running boat. She is transferred in 1983 to the Pacific Fleet. She takes a Victor 3 with her, so presumably the Victor 3 transferred as well. A lot of these transits, because they're so long, are unescorted, but this is one that is escorted. In 1984, she tests the R-29RL missile. That's the one with 7 warheads. That's the scary one, because that's the one that's going after civilian targets. Because a 0.1 megaton warhead isn't going to do a lot to a shielded or reinforced military target. The R-29RL is to kill cities. Anyway, so she tests that with success. 1993, she's dry docked in Zvezdas for repairs. The repairs are halted. So while she's in dry dock is when she's awarded the honorary name St. George the Victorious. And it must work, because in 2003, 10 years after going into dry dock, repairs are complete. So George did something for him, and they start doing sea trials in the Sea of Japan. Not that they're trying to provoke Japan, but the Sea of Japan is right outside the shipyard. It's just the common sense place to do it. In 2005, she's launched the R-29R test missile, which is the regular missile. And in 2010, she takes part in Pacific Fleet exercises. 2010. Okay, so the K439 St. George the Victorious, she did a lot of Arctic voyages. Even though she's stationed in the Pacific, she's going up through the Bering Strait and doing Arctic voyages there. And here's some great shots taken from the bridge as they go through the ice. And it's very dangerous to pass through ice like this, even though the ice looks like it's kind of broken up. If you bunch a bunch of this ice up together as you're trying to push through it, the mass and weight of the ice will begin to damage your hull. Even though the hull's made out of steel, it's not impervious. So, but here you can see them doing a surface transit through what looks like a marginal ice zone. If I was the captain, I'd be looking for a place to dive really soon. All right, continuing with K433. In 2011, she collides with a small fishing trawler in Avacha Bay with light damage. It's over on the Pacific side. There's no word as to what happened to the trawler, or assume that she survived, but you can see in the picture there that the port side of the sail is smashed in. So this was no fishing boat. This was like a steel hull fishing trawler that they ran into. The next year, 2012, she fires a salvo of 4 R-29R missiles, demonstrating the salvo capability of the system. In 2013, a surprise inspection of all nuclear deterrent submarines results in a satisfactory grade and is declared the best Navy in the world. So the Navy, or the Russians, declare their Navy the best Navy in the world after the inspection. I suppose that means they didn't have any incidents. They didn't find anything. They're like, well, since we're not killing our own sailors with radiation anymore, and we haven't spilled any missiles into the Barents Sea recently, we must be the best in the world. But all the navies tend to do that. The American Navy is guilty of this as well. Of course, we call ourselves the best, and I honestly believe that we are. But and we have proof to show we have some kind of material. In this case, they just had one inspection and said, well, good enough. We're the best. And I just want to point out that it's not just the Russians making declarations like that. In 2015, she completes a missile patrol in the North Pacific with no problems. So again, keeping that record up, the Delta III is a reliable operational platform. They're doing the right things. They're doing their maintenance, at least on the nuclear reactor side of things, and they're not having all these incidents. We're not killing sailors for like the first time in Russian Navy submarine history, which is great. Okay, in 2016, successful missile test of one ballistic missile, and in 2018, she is removed from service after a great career. You know, a few hiccups along the way with the fishing trawler, but overall, a very high-tempo boat doing the right thing. In 2020, she's in a Northeast Repair Center awaiting disposal. So, her reactor is still on board. Obviously, it's shut down, but it needs to be cut out. It needs to be put in long-term storage, and the inside components need to be harvested for recycling. So, if you're in that business, they're looking for someone to tear apart K433. All right, so let's talk about K129. K129 is a very special submarine. It began its life as a Delta III, but it did not finish its life as a Delta III. So here at the end of the subbrief, we're gonna bring it up. This could almost be its own lecture, but I wanted to keep it with the Delta III lecture because in 1979, when her keel is laid, and in 1981, when she's commissioned, she is a Delta III. In 1984, she's doing missile patrols under the ice. In 1985, she's colliding with American submarines. She's doing all the things Delta IIIs do. In 1986 to 88, she does 4 more missile patrols under the ice. In June 1989, she suffers a power plant casualty, keeping with Russian tradition, and returns to Sevmash for repairs. So, typical Russian submarine. In 1994, she's removed from service and begins life as a new submarine in Project 09786. She's going to become a mothership submarine to a science deep submergence submarine called the Poultice, and later on, another one called the Low Shark. So she's going to begin her life as BS-136 Special Project Submarine in 1994. This is her in dry dock undergoing conversion. This is her new look. I immediately want to point your attention to the missile deck. Look how much lower the missile deck is than it is in the previous picture. Look at this missile deck here. This is the typical Delta III missile deck that goes above the fair water planes on the sail. Now look at it. It is much shorter. That's because they ripped out the D9R missile complex. This doesn't have any missile silos in it. That entire missile compartment section, compartment 4, compartment 5, that is science, laboratory, and berthing now for all the engineers and scientists that she's taking underway with them. I want you to look also at the new shape of the hull underneath the missile deck. Going around the bottom of the submarine, you can see what looks to be flat sides. That is a docking bay for the mini subs. She can take the Poultice underway with her, just one, or the Low Shark. Here's a little drawing from the side view of her, of the Orenburg. Delta 3 or Delta Stretch is what the NATO name is calling her now. In 2002, she is renamed BS-136 Special Operations Submarine Mothership. She's the mothership for Deep Submergence Submarine Project 10831, which is Low Shark. Low Shark submarine is a deep submergence submarine with little grappling arms like they see in the Titanic movie and go down there and pick stuff up off the bottom, cut communication lines, recover missile warheads that didn't fire properly. Yeah, Low Shark is the little submarine that goes out there and picks all those things up, and Orenburg is the mothership that takes her there. In 2006, she becomes operational officially. She did some sea trials and stuff before then in 2004. 2006, she's officially doing her job. In 2012, she deploys to the Arctic Sea for months doing a geological and geographical survey where they're mapping the Arctic bottom in this high-resolution side-scan sonar using the Low Shark. Again, she can use the Poultice too. The Poultice is the older mini-sub that's been retired, but she can do either one. In 2020, Orenburg is operational in the Northern Fleet, operating out of the Kola Peninsula. Now, sadly, the Low Shark who is the mini sub that docks with her in that middle section at the bottom, did suffer a catastrophic fire last year that killed all of the crew and one of the civilians on board at the time. Somehow, she managed to dock with the mothership either during or after this fire, so presumably someone survived. But she's crewed by 14 military sailors and however many civilian scientists are on her, and all of the 14 sailors in the effort of putting out this fire died of either heat or asphyxiation. Sadly, it was an absolute tragedy that happened last year. Anyway, so she is currently in dry dock, being repaired. They're going to make her operational again. As of the recording of this video, she is not operational right now, but she's definitely going to be operational and paired back up with her Orenburg mothership and doing operations just as soon as they can. But yeah, this is the AS-12 Project 1083-1 Low Shark. All right, so my final thoughts on the Delta III is, one, it is known in the Russian Navy and around the world as the workhorse of the Russian submarine Navy. And she deserves that name because even though she was built, in the 70s and 80s, she's still working today. She has one of the best track records as far as safety and operational, deployments go of any of their programs. Russia was able for the first time in the 1980s to have at least one ballistic missile submarine at sea at all times. There was never a gap in their coverage. And the Delta III was the submarine program that brought that capability to them. She's also the most versatile submarine launched ballistic missile. She had, 3 versions of that missile. So they could send her out with a lot of small warheads or just, one rather large warhead or any mix in between, up to 16 missiles. She has the least number of nuclear incidents of any previous class. Like I said, her continuous at-sea presence through the 80s was key. She's difficult to track with the SSN escort. Okay, so here's the deal with the Deltas. Of course, the Deltas are quieter than the Delta IIs. Delta IIIs are, but they're not that quiet. The fact that they didn't change their engine room really hurt them. And I'm not going to go into detail. I probably will at some point, but not soon. But the Delta I, the Yankee, they all have the same engine room and they all have the same problems. If they would just simply have changed the engine room, then at least we would have had a challenge. It would have been different. I'm not saying it would have been better, but because they used the same thing they used on the Yankee, we knew what to look for, And again, designing a submarine engine room is a big deal. That's why they didn't redo it, right? It's expensive. You got to go through testing. It takes time. It's just a big involvement. So while they're upgrading the electronics and the missile complex, the most important thing from a sonar perspective is that engine room. And they just never changed it. So what they did is they started deploying fast attack or SSN submarines with them. And the point is that the American or Royal Navy would have to stay outside the escort and try and monitor the ballistic missile from an even farther distance than if the SSN had not been there, right? If the SSN's not there, we can go right up to the submarine, knock on the hatch and be like, hey, how's it going, comrade? But the escort kind of keeps us from doing that. And there's some tactical advantages and intelligence advantages to being able to go right up to a ballistic missile submarine. Okay. And we're definitely not talking about that, but so the SSN escort served its purpose. Even though we tracked both of them and they probably knew that we were tracking both of them, it kept us from getting really close to the Delta IIIs. And they would continue this escort service all the way. They do it today. If there's a boat available, it's out there with the Delta IV poking holes in the ocean under the ice. All right. So in my opinion, this is the first modern professional ballistic missile submarine of the submarine fleet. That is my conclusion. This is what I think. The Delta III brings in a new era of professionalism, deployment capability to Russia. And, I have to give my hats off to them. They finally got it. This is their Trident submarine. Obviously it's not as good as the Trident, but this is their evolutionary Trident step. What the Trident program was for the United States compared to the Polaris program is what the Delta III is compared to simply the Delta II and everything before it. This is the beginning of a very capable nuclear deterrent. Delta Force Subbrief, Project 667 BDRM. All right, so the Delta Force story begins in 1975. As with all of our other submarine stories dealing with Russia or back then the Soviet Union, it begins with a governmental decree to build a new submarine launch platform for this new ballistic missile called the R-29RM. NATO name is SSN-23 Skiff. The missile complex that's going to be on the submarine is the D9R. It has 16 missile tubes, just like the previous submarine version have. This is one of the few cases or rare cases where missile development began after submarine development. Usually it's the other way around. So missile development really gets going in 1979, 4 years later after the submarine program has started. They simply add a third liquid propellant stage to the previous missile, causing it to be a little bit taller. Therefore, the missile deck behind the sail is going to be a lot taller than the Delta III. That's one of the ways you can tell the difference between the Delta II, the 3, and the 4 is by watching the missile deck get higher and higher but behind the sail. So this is going to be the largest missile deck of the Deltas. This missile upgrade will get 2 upgrades, and each time the missile gets an upgrade, these submarines will go in for a midlife upgrade as well. The first midlife is 2.0 called the Sneva. And then the second one is 2.1 called Lanier. And we'll go into what those are when that comes up. All right, so we're going to come back to this slide one last time. We are completing the loop with this subbrief of the R-29RM SSN-23 Skiff there for the Delta IV. Over the course of all of our submarine briefings, we have covered every one of these missiles in great detail, including the subbrief. The Skiff becomes operational in 1986. 3-stage liquid fuel rocket can reach out and touch a target over 9,000 kilometers away. And we had some fellow Patreons ask me to double check this range because they couldn't believe it. But that's absolutely what it is. I've checked it twice, over 9,000 kilometers. This Delta IV can hit targets inside the continental United States from its pier in the Kola Peninsula. That's how much range this has. It doesn't even have to go to sea. It simply goes to sea to try and hide, but it can hit its targets from just about anywhere in the world. 4 to 10 100 kiloton warheads is the payload. They usually don't take 10, but they could have up to 10. The accuracy is less than 1 kilometer circle. It's using the astro correction system, and after 1988, it has the GLONASS system, which is the Russian GPS. And in 1999, we're begin getting these upgrades where they have the 2,000 kilogram, which is a large conventional warhead, so they can shoot non-nuclear payloads. So just because you see one of these things go off in time of war doesn't necessarily mean it's a nuclear payload. It probably is, but it doesn't have to be. And then in 2009, the R-29RMU 2.1 upgrade uses medium warheads, which those are the low-yield tactical nuclear warheads, and decoys. They added decoys to them. All right, so Delta IV by the numbers, very similar to Delta III, displaces a few more tons at 18,200 tons. Similar length of 167 meters. Beams a little bit wider at 11.7. Speeds right around 24 knots. Check this out. This is the first Soviet submarine that we've talked about, nuclear submarine, that's had less than 6 torpedo tubes. She only has 4 torpedo tubes. And I don't know why I didn't even think about this until I was writing this lecture, but this is really incredible. This really shows how much, one, the torpedoes are getting so good they don't need to launch 6 or 8 at a time anymore. And the mission of the submarine is not tactical, it's strategic. So they didn't spend the money, the time, the maintenance on 6 or 8 or even more torpedo tubes. They gave her just enough torpedo tubes to launch a defensive weapon, maybe launch a submarine launched decoy, and then, continue to do her strategic mission, which is take those 16 submarine launched ballistic missile tubes, the D9RM complex, out under the ice and hide it. She has 2 VM-4SG reactors. She has 2 shafts with 7 blades on each. Skate sonar, gateway navigation system, which is a upgrade to the Tobel that it had, and the crew of approximately 135 sailors. That's officers and men. All right, very first Delta IV is the K-51. Its honorary name is in the name of the 26th Congress of the CPSU. That's the Communist Party's People's Senate, something like that. CPSU. She's laid in 1981, launched in 84. During sea trials, she launched 1 and then 2 missiles from the White Sea, and then she launched 4 missiles. A total of 10 missiles were launched during sea trials because she was the first boat launching this R-29RM missile. After she gets done with all those sea trials that last about 5 months, shooting 10 missiles, she is finally commissioned at the end of December 1984. August 1985, she cruised under the ice to 82 degrees north latitude, or longitude rather, to test navigation system. She didn't fire any missiles up there. She's just verifying that she can navigate under the ice without relying on magnetic compasses, and she successfully does that. August 86 of the next year, she does further navigation testing of the new Gateway navigation system. Again, it's just a better, like the Tobel was better. It's just the next evolution of the Tobel system called Gateway. In September 1987, a year after the previous test, she goes up there. She launches 2 missiles. The rockets failed in flight due to improper separation of the stages, destroying 1 and 2 missiles. Between stages 1 and 2, destroying the missile. In the same submarine, K-51, November 1987, she returns to port using radar navigation to turn into harbor because of low visibility. The radar operator miscalculates the turn by 800 meters. And depending on how far away the navigational, not waypoint, but whatever they're marking the turn off of, that's an easy calculation to miss. Normally, they'll have landmarks that these radar beams bounce off of, and that can be a lighthouse, even though you can't see it, the radar can see it, and they'll make the turn based on this lighthouse. So if whatever they're using to make the turn off of is a long ways away, it's easy to make an 800-meter mistake. But it cost them because they turned too early. They were not in the channel coming into port. The navigator, who's sitting there with his calculator and stopwatch, catches the error and tells the captain, he says, "Hey, we turned too early. We're not in the channel. We're off course." The captain immediately slows down to 5 knots, and 2 minutes later, they run aground. Thankfully, they don't do a lot of damage to the bottom of the submarine because they had slowed down from the 10 knots that they were at. They got a couple 4 rescue tubs out there to pull them off the bottom a little bit, back into the channel, and then they proceeded into port. But this is the first casualty of the first Delta IV. She runs aground outside port in 1987. 1989, she completes her first missile patrol in the Arctic Sea, and then in 91 and 92, she does 2 more missile patrols. In 1992, Russia collapsed, and she is removed the honorary name because the Congress 26 no longer applies. So she's back to being just K-51. All right, K-51, she goes to Sevmash for modernization. While in modernization, she is named after a Russian city called Verkhotyr. 2001, testing the new upgrade missile, R-29RMU-2. This is the 2.0 missile, the one that has the upgraded, warheads. She can carry up to 10 warheads now. From 2003 to 2009, she does 8 missile patrols with the new missiles. In 2010, she goes back into Sevmash shipyard for modernization. This is the second modernization of her life. In 2013, she's part of a movie called Journey to the Depth by Polygon Studio. You can look that up and watch the movie if you like. It's online. 2015, missile test successful, reported at 27th successful launch from K-51. So during her life, up to 2015, she's tested 27 of these ballistic missiles. That's a lot for any one submarine to be throwing around. A big part of that was she's the first one in flight. Therefore, she was the only one in the beginning doing these tests. In 2021, she is still operational in the Northern Fleet. And you can see the crew right there taking a little crew picture. Okay, so let's talk a little bit about these missiles because they're getting pretty advanced at this stage. R-29RMU-2, that's the modernized, upgraded second version, SNEVA. SNEVA stands for dark blue. She can have 10 reentry vehicles, each at 100 kilotons apiece. It uses the GLONASS navigation satellites to correct the course. The RMU 2.1 Lanier, which is an even more advanced version, added some anti-missile defense defeating capability to the reentry vehicle. Up to 12 decoys can be replaced where one warhead would be. So as they re-enter, the decoys kind of fan out or blossom and shower the target with what looks like real warheads when there's only one or two actual warheads coming in on the target. And with the Lanier, they can change their course during re-entry. So as the re-entry vehicle is coming in like a meteor out of space at extremely high velocity, it can move in 3 dimensions, effectively dodging any kind of anti-ballistic missile defense that may be in the area. Here's a picture of the 2.0 Svina being loaded onto the Delta IV. Here's a picture of it being unloaded, SNEVA. You can see where the missile has just a little bit of a twist as it comes out of the tube being launched. And towards the nose, you can see the big thrusters that are there to help it maneuver once it gets up into its suborbital flight. This is the payload. This is what it looks like. This is the business end of these ballistic missiles. These reentry vehicles rather, are on the workbench. They are incomplete. Probably don't have any kind of warheads. It looks like they have telemetry boxes being added to them. So this is probably, and big caveat, big asterisk, probably for missile testing, reentry telemetry, making sure that they can find where the warheads go as they're being dropped back down onto the test field, which is in Kamchatka Peninsula. If you look in the background there, you can see the nose of the missile that's going to be placed over top of these to protect them as they get launched up into flight. But I thought this would be interesting for you to see the business end of these submarine launched ballistic missiles. If these were real warheads, they would look like complete cones with pointy little tips. But it looks like they have a lot of telemetry and testing going on. Again, they're incomplete. Even at this stage, they need to put the rest of them together before they would be used. But this is what it looks like on a workbench. Okay, K-84, laid in 1982, launched in 1985, commissioned at the end of 85. This is the second of the Delta IVs. From 1988 to 96, she does 6 patrols in the Arctic Sea. She gets her midlife upgrade at SEVMASH in 1998. All of these submarines, all the Delta IVs are built in SEVMASH, upgraded in SEVMASH, and serve in the Northern Fleet. All of them. In 1999, she gets her honorary name, Yekaterinburg. In 2003, first successful missile test with this under the SNEVA program. That's the 2.0 program. That happens in 2003. 2005, 2009, she does 3 patrols during this time. In 2009, she shoots 2 of the RSM-54 missiles successfully. The RSM-54 is the name of the missile body itself. So RSM-54 and the R-29 RMU-2, same thing. 2011, she caught fire in dry dock, did over 1 billion rubles in damage, a lot of damage with this fire. Nobody was hurt, but a lot of damage done inside the submarine. Took a couple years to recover from that. It's not until 2014 that she does return to service after fixing the fire that happened in port. And as of today, she is still operational. K-84 out of the Northern Fleet. All right, here's the SEVMASH shipyard. This is where they build them. This is where they upgrade them, repair them. You can see the 2 large assembly buildings there. They use both assembly buildings during construction. They use the floating dry dock during upgrades. Their home port is very close to the SEVMASH shipyard too. SEVMASH shipyard is in the White Sea. You can see there on the right. And their home port is in the Kola Peninsula, which is that large peninsula just north of the White Sea. So this is where they're built and maintained and upgraded whenever they have large maintenance that needs to be done every 10 or so years. All right, K-64 Pod Moskvy or Moscow. Laid in 1982, launched in 86, commissioned at the end of 86. From 1988 to 99, she goes on 10 missile patrols. Very high tempo submarine, doing about 1 a year for the Delta IVs. And then in 2000, she goes into dry dock as expected. This is about the time she'd be getting her midlife upgrade. But the midlife upgrade is halted. And that is a picture of her coming out of the midlife upgrade. So I'll give you guys a second to look at that and see if you can see what significant change has been done there. That's right. Look at the missile deck. The missile complex, the D9R missile complex is gone. They took it out. So what'd they do with her? They turned her into a mothership. That's right. K-64 after 2000 is no longer a ballistic missile submarine. And in 2008, she is officially assigned to Project 09787, Special Purpose Submarine. In 2015, so 15 years after going into dry dock, she is launched with the missile compartment removed, officially as a mothership now. And that's a nice drawing by H.I. Sutton there of what she would look like with the mini sub attached to the bottom and the reactor pod topside. Now, sadly, in 2019, a fire broke out on AS-31 Low Shark, which is the mini sub attached to the bottom there, killing 14 sailors, which was every single sailor on board at the time. Somehow, someone survived. Apparently, civilian contractors were on board with her, and they managed to get her redocked to the to BS-64 and pulled her back into port. And in 2021, BS-64 remains in port awaiting Low Shark repairs. We're assuming Low Shark will go to sea again despite the disaster that happened. Now, I want to talk a little bit about this pod because this is important. This is a picture of BS-64. BS is for Special Purpose Submarine. Her name has been changed from K-64 to BS-64. That's the cradle topside of the what was the missile deck. That's topside now of the hangar with the mini sub docks on the underside of that of. And on top of that cradle is going to be this pod. This pod is an autonomous, an automatic, running on its own nuclear turbine generator. Self-contained nuclear power plant, creates steam, turns a generator to make electricity. All closed loop inside this pod that sits on top of that. And you'll notice that it's gone now. Yeah, it's because it's on the bottom of the ocean. Yep. So what this thing does, BS-64 goes underway with Low Shark on the bottom of it attached once they get out of harbor. And then they have this autonomous nuclear reactor topside. The mini sub detaches, floats up to the top, grabs the little pod, and takes the pod over to this network of drilling and underwater sensors and provides electricity for it. So this autonomous nuclear reactor generates about 50 kilowatts of power estimated. These are all estimated numbers. Russia's not coming out and telling us exactly how good it works. It runs by itself safely for 5,000 hours before it has to be picked back up again and brought back in to have maintenance done on it and whatnot. And they've got multiple of these, so they can just swap them out. So that's what the submarine was doing through 2019 until that fire broke out on the mini sub. Now, what else this autonomous nuclear turbine generator provides power for is the Harmony Russian underwater SOSUS array that is under the ice right now. Now, Russia will not acknowledge this program even exists, so we have no pictures of it. We have no data of it, other than that we know that it does exist. Russia does have their own SOSUS field that's pretty advanced. It's more advanced than the NATO SOSUS that was put out in the 60s and 70s. And it's nuclear powered, and it's powered by these little pods. That's about all we know about it. But I thought you'd find that interesting that is what she's doing. And as soon as the Low Shark is repaired again, she'll be going out to sea doing those missions. Let's move on to K-114, the Tula. She's laid down in 1984, launched 1987, commissioned the end of October 1987. She does 7 patrols from 1989 to 2000. She goes in for a midlife upgrade from 2001 to 2004. So far, a very standard, no problems submarine. In 2007, test fires the new RSM-54M Seneva ballistic missile. with no problems. In 2008, she test fires the same missile, but this time from the Pacific equator. So what she does in 2008, she takes about 60 days. She spends about 30 of them leaving the Kola Peninsula, going under the ice, over to the Pacific by Alaska, and sails all the way down by Hawaii and launches a ballistic missile to the Kamchatka Peninsula. And then, without surfacing, comes all the way back up past Alaska, under the ice, and pulls back into her port on this 60-day round trip to go down to the Pacific equator and launch a ballistic missile. What this demonstrates is that their navigation is so good and their targeting is so reliable that they can put these platforms anywhere in the world and still hit their targets. It was a very strong demonstration of the capability of not only this new submarine, but the missile as well. In 2017, she pulls into SEVMASH for modernization. In 2019, she is finished with that, successfully test a missile from the Barents Sea to the Kamchatka Peninsula. And in 2021, she is still operational, ladies and gentlemen, out of the Northern Fleet. K-117, the Brynask. She's laid down in 1985, commissioned in 1988. From 1989 to 92, she does 3 missile patrols under ice. In 1993, she has a rupture seawater line in the engine room that floods approximately 3 tons of seawater into the engine room. The flooding is isolated, and she continues her missile patrol. She's not going to let a little thing like flooding in the engine room deter her. She was on alert, on patrol when this happened. She finished her patrol. So good on her with dealing with a pretty significant casualty. 3 tons of water is a lot of water, but apparently it didn't damage anything that would significantly stop them from performing their duties. So they stayed out there. 1994, she surfaces at the North Pole, which is just something submarines do at this point. In 1998, she gets the honorary name Bryansk. And from 1999 to 2001, she does 3 missile patrols. In 2002, she pulls in a SEVMASH for modernization. She comes out in 2004 and performs some missile tests with the new missile to make sure that it works. It does. In 2006, she surfaces at the North Pole again. This time she launches a missile from the North Pole to the Kamchatka Peninsula. And that is just as significant as launching from the equator, if not more so, because the magnetic compasses are useless at the poles. And she's still able to successfully target a missile from a point on the Earth where every direction is south. So if you think about that, you can understand how difficult it is to navigate and aim things where no matter what direction you face, as you spin 360 degrees, it is all the same direction. It's all south. But that's just magnetically. Obviously, geographically, it's different. And that's what they're proving, is that they can launch from anywhere in the world, including the North Pole. In 2008, 2009, she does 3 missile tests from the Barents Sea. In 2013, a surprise missile drill from Putin himself orders a coordinated missile launch from both the North Sea Fleet and the Pacific Fleet, and they simultaneously launch multiple submarine ballistic missiles into Kamchatka Peninsula missile range successfully. In 2017, she pulls in the SEVMASH for her second modernization, and as of 2020, she's still in SEVMASH getting these upgrades. I expect in 2021, she'll be out. She'll be shooting the new layer version of the missile, the R-29 RMU 2.1, and we'll be testing that probably in summer of 2021. All right, next submarine is the K-18 Karela. She's laid down in 1986, launched in 1989, Barents Sea wargames in 1991. They had to medevac the sailor to a Utiloi for an appendicitis. This is interesting because I was present at this war game, and I remember the Utiloi. I remember the Delta IV. We had no idea that there was a medical emergency. I remember the helicopters. Helicopters were everywhere. But that's what happens in a war game, is you have Utilois, you have submarines, and you have helicopters. Apparently, during this time, there was a medical emergency. And I did not know about this until I read the ship's logs doing this video. Anyway, so I'm sure the sailor is okay. I'm sure he got the medical assistance he needed. In 1993 to 96, missile patrols under ice, does 3 of them. In 1996, she's awarded her honorary name, Karelia. In 1996 to 2000, she does 5 missile patrols in 4 years. So the tempo is getting higher and higher. They're doing more with these Delta IVs. In 2000, she launched 2 ballistic missiles for testing. Both were successful. In 2000 and 2003, a 3-year period, she does 4 missile patrols. So they're doing more than 1 missile patrol a year now, very similar to the Ohio Trident tempo the Americans have. In 2005, she returns to SEVMASH for her modernization. In 2010, the modernization is complete. It's kind of a 5-year modernization. She carries the R-29MU-2 ballistic missile at this point. That's the Sneva. In 2019, she launches the missile at wargame Thunder 19, which is a big annual wargame they have up there in the Northern Fleet. And in 2021, she is still operational in the Northern Fleet. I really like the picture there on the left where you can see the towed array tube. It gives you an idea of how big the Russian towed arrays are. Modern towed arrays are very, very thin compared to what they were back then. But there is such a thing as a tactical towed array, which is much shorter. And the shorter tactical towed arrays have a lot of are a lot thicker, and that's for a couple reasons. One, the processing and electronics inside take up a little bit more space, but they also have to displace a little bit more water so they don't sink out. Whereas the longer towed arrays, they can, make themselves buoyancy neutral over a longer plane, making them thinner. But if you have a short tactical towed array and you want it to be neutrally buoyant where it won't sink or float, it has to displace a certain amount of water. And so that's why it's a little bit thicker. But boy, that is a really thick towed array tube right there. It's much thicker than either it needs to be or they have really large tactical arrays, and it might be the latter. All right, let's talk about K407, the Novomoskiv. She's laid down in 1987. She's launched in 1990, commissioned at the end of November 1990. 1991, she fires a full salvo of 16 R-29RM missiles for testing. This has never been done before. Not by Americans, not by NATO, not by any other country. A full 16 missile salvo launch. Extremely expensive test, and it works. It goes off swimmingly. All the missiles reach their intended target. She blows her entire load over a 1 to 2 minute period. It is an incredible test. And if they ever declassify the video of it, I will bring it to you because it's amazing. And it's the first time they've ever done it. They just wanted to see if they could, I guess, and they did, and it worked. In March 1993, she collides with the U.S. submarine Grayling, SSN 646, which is it's not a 688. It's one of the older 637 ones. Minor damage to both submarines. They surfaced. Our submarine did not. They separated, and the Grayling ended up pulling into port in Holyloch, Scotland for repairs a couple days later, which is how the Russians found out who it was. I mean, they figured it was us, and they were right. They just didn't know which one it was until they saw the Grayling pull in. 1996, she test fires R-29RM successfully. And in July 1998, she launches 2 satellites, TubSat-N, TubSat-N1, from a submerged position. Both of these satellites are successfully launched. They do orbit the Earth for a couple years for a university in Germany that sponsored the program, and are no longer in orbit. They've come out of orbit by now. But this is just demonstrating that they could put satellites in orbit from a submerged ballistic missile submarine if they wanted to, using the R-29RM missile. Because the R-29RM with the third stage has enough energy to deploy satellites. That's something that other rockets before them could not do. In 2000, R-29RM missile is successfully tested again in 2000. In 2001, she does it again. So she's testing them like 1 a year now at this point. In 2004, missile testing is aborted due to a crew error. This is a little bit embarrassing because in 2004, President Putin was topside of a missile destroyer waiting for the missile test to proceed. They were supposed to launch 2 missiles, and because of the error on the first missile, they canceled the entire test, leaving an awkward moment with the president of Russia with his binoculars waiting for the rockets to come out of the water. And some lucky sailor got to go inform him that he would not be seeing his rockets today. In 2006, Father Leonid carries out baptisms on board the submarine. This is not the first time this happens, but I added it to the lecture because I wanted to point out the connection of religion with the Russian military and especially the submarine service. They appear to have become, they've always had a little bit of mysticism and religion around the military of the Soviet Union and Russia throughout history. That's not new. What is new is they're inviting these clerics onto the submarines. They're blessing the submarines. They're blessing the crews. Now they're doing baptismals as if the submarine itself is a temple of the sailors. And so there is a strong mythological or spiritual connection between God and these sailors and these machines than ever before. And like I said, this is not the first time, certainly not, that this happened, but this is becoming more and more common as I read more about these ballistic missile submarines, whether they're fast tech submarines. The clergy from Russia is very involved in the military to the point of doing baptisms on board submarines. Okay, in 2010, she reports to Sevmesh for modernization. 5 years later, she's out participating in war games in the Barents Sea. In 2016, the following year, she launches the improved R-29 RMU-2 missile, the Sneva. And in 2021, K-407 is still operational. Still out there punching holes in the ocean under the ice and doing her mission. So, final thoughts on the Delta IV program. It is the pinnacle of Russian ballistic missile capability up to this point. Okay, so we're still talking about 1990s to 2000s. Whenever these were being built, these were the best that the Soviet era engineers had designed and the post-Soviet Union Russian craftsmen had built. And the crews now are so experienced in operating the Yankee and the Delta 1 and the 2 and the Delta 3. By the time the Delta 4 comes out, a lot of the systems are very familiar to the crew. They've seen similar things on previous boats. Those of the Navy that have stayed in from one boat to another. And so we're seeing the number of casualties go down. They're following their procedures. They have fewer and fewer accidents with the reactor, fewer collisions, fewer negative events are happening now. So this is really good. And at the time of the Delta 4 operation, she is the absolute best that they've built. She has the longest strike range with this R-29 RM missile. This is up to the Bori that's out now. We're not including the Bori in this, but as far as the Deltas go, she has the longest strike range. She has the highest reliability of any Russian SSBN. A strong second would be the Delta 3. So Deltas in general, very reliable. She's less expensive to operate than the Typhoon, which is the big reason why they only built 6 Typhoons and they built 7 Delta 4s. And they have a ton of Delta 3s. She supports gas and oil exploration in the Arctic Sea. So the Delta 4s are not only doing ballistic missile missions anymore. They're launching satellites. They're bringing autonomous nuclear reactors under the Arctic Sea. They're providing support for unmanned underwater vehicles with the nuclear pods, supporting power and electricity to the Harmony system, which is Russia's SOSUS system called Harmony. Again, officially does not exist, but I'm telling you it's there, and that's the name of it. Succeeded by the Bori class in 2013. So, we could say this is the pinnacle of Russian ballistic missile engineering all the way up until 2013, if you wanted to be specific about it, because the Bori is a very well-designed submarine. We already have a brief on that. I recommend you go listen to that after this one if you want to know more about the Bori. And something that many of you may find surprising, but the Delta IV is the quietest nuclear submarine in the Russian fleet that I have ever tracked. And I've tracked most of them. In terms of classes, I've gotten almost all of them. Okay, so I'm able to put real life experience towards the Victor 1 versus the Victor 3 versus the Akula, and then versus, of course, all these ballistic missile submarines. And the Delta 4s were so quiet. They were very difficult to get a hold of. And once you had a hold of them, it was hard to maintain that hold because they're so quiet, you could lose them at any moment. Every time we wanted to make a turn, my ass was in control going, I recommend we don't do that because after we turn, we may not have the submarine anymore. Okay. But of course we had to turn and do our job as well. So up until 2013, I cannot speak for the Bori because unfortunately I've never tracked the Bori. She is the quietest nuclear submarine that I personally have ever tracked. And that is saying something. She is like a hole in the water. She's very, very quiet. Type 039 Alpha Yan subbrief. Now we're going to start with the shipyard that builds these submarines. There's 2 shipyards in China that build all of the type 039 and its variants, and there's lots of variants. The shipyard that we're going to begin with is the Wuchang shipyard in Wuhan, China. That's the address right there if you wanted to send them a letter and request the visitor center welcome aboard package. It'd be interesting to see what you guys get in return, if anything. But if anybody does do that, definitely let me know because I think that'd be pretty fun. All right, founded in 1934, relatively recently compared to the other shipyard up here. They employ approximately 11,000 shipyard workers. That is not an accurate number. It's an estimation based on the size of the shipyard, the number of housing that they have, the number of projects they have going on at any one time. We have a rough estimate of 11,000 people. That is widely variable. But they don't just do military ships. They do yachts. Of course, they do the conventional subs. They don't do the nuclear subs here. But they build the minesweepers, the landing ships, and any of the warships, short of an aircraft carrier, are built here. It is 820 square kilometers, so rather large shipyard, and builds all variants of the Type 39 submarine. Now, I consider this, and this is my opinion, a core shipyard for the Navy. And it's not because of the size of the shipyard or how busy it is, because it is not the largest and it's not the busiest. But look at the location on the map. It is deep inside Chinese territory on the Yangtze River, which means that if there was ever a conflict with one of their neighbors, whether it's Taiwan, Laos, or Russia, this shipyard is in a very secure location far away from any front or coastline. So I believe that, if there was an invasion and a war, it would probably keep this one up and running while the other ones would be closer, more of a threat. All right, so we're going to begin this brief with the Type 039. The Type 039 is not the Yan. The Type 039 is the Song. The Song is the foundation on which the Yan is based. So Type 039, Song, Hull 1 of 1, is a one-of-a-kind submarine. Begins sea trials in August 1995. It has a very distinct step sail. So the sail goes up and then it raises up again a little bit farther aft, and it has a large metal protrusion coming out of the back of the sail. It's very easily identifiable, and they only made one of this kind of submarine. There's only one Type 039. It was commissioned in 1994. The anti-sub, it's an anti-sub and anti-ship attack submarine. Its primary mission is anti-ship. It launches the anti-ship cruise missile at up to 80 kilometers away. And then they have a Tomahawk version as well, or a Chinese version of a Tomahawk that goes over 650 kilometers to attack a ship as well. Now, what they did with this is they purchased a German MTU 16-cylinder diesel engine. This is a very common German-based, German-design maritime diesel engine. And over 20 navies in the world use this kind of engine on submarines and on other vessels as well. There's lots of different variants of this MTU, and each one is kind of custom designed for its ship. So we're not sure where they got this German MTU. When I say they, I'm talking about China. They did purchase one. It could have come from any of those other 20 nations, or it could have came from Germany, but they definitely hired German engineers and technicians to help them reverse engineer this German MTU. It is believed they did not go through the German government to do this. They, hired people that know about this engine, freelancers, contractors, if you will, to come to China, tear down this engine, and rebuild a Chinese copy of it. The Chinese copy of this German MTU is what's in the Type 39 Song and Yan submarines. They did the same thing with the sonar systems. The French TSMS 2233 bow passive active sonar. And not on this particular hull, but in future hulls, they also copied the French low-frequency hull array. And I'll point that out to you whenever we get to it. But just know that they're buying a copy, or at least getting the plans for, and then they're hiring contractors that know about these systems, whether it's a diesel or a sonar system. They're offering them money to come over to China and help them build a Chinese copy of it. So the new passive intercept sonar system, they have the name of H/SQG04. That's like if they hear active, it gives them how loud it is, what direction it came from, and so they can use that to their tactical advantage. Because this was a one-of-one build, she conducted over 320 sea trials to try and identify problems with the systems and the design so that future builds based on the song would be better. So she was very loud underway. She was very inefficient, especially at high speeds, largely part to the sail design, which they completely redid. She does have 6 53-centimeter torpedo tubes that shoot a 40-knot electric torpedo and the YJ-8 anti-ship cruise missile. That's basically the Chinese version of the American Harpoon. She does have mine laying capability, and this design, the Type 39, was the replacement for the Ming class submarine. All right, so one of one. Let's talk about this German MTU. Generates about 1,600 kilowatts consistently. It's a 4-stroke liquid cool fuel injected diesel engine. It does have a turbo exhaust, so there's a fan on the exhaust pushing the exhaust out. The exhaust, goes topside and comes out the back of the submarine. And it does have an air pressure start. This is something that if you're not familiar with marine engines, most marine engines don't have an electrical starter for larger engines. They use compressed air, 700-pound air or even higher in some larger, cargo ship engines to actually push the piston down and back up again with air. And then once they get the compression with the diesel fuel, it runs on its own after that. Now, this German MTU is not physically or mechanically connected to the shaft, which means in order to change the speed of the submarine, they do not need to change the speed of the engine. So because this engine is generating electricity, which then powers systems on the submarine, charges the battery, and turns the screw, they just run this diesel engine at 1 RPM, typically. And that's 1,800 RPM, which means you can set your sonar system to 30 hertz and 480 hertz and look for lines there. And as soon as you do see that, one, you're too close because this is a quiet engine, but you've got a detection of a German MTU. You certainly can't hang your hat that it's going to be a Type 39. No, because a lot of navies use this engine, but these are the frequencies that you want to be looking for. And the lube oil pump is the loudest component of this engine. Now, because some NATO nations use this, like Germany, use this engine, I'm not going to tell you what the reduction ratio is, but there is a ratio that you multiply by 30. And if you look for that line, that will classify this as an MTU 16 valve 396. The reduction ratio of the lube oil is very specific to this engine. Anyway, so that's how the sonar men look for these submarines. They look for these frequencies. And I'm just telling you the general ones. Okay, so the second shipyard that is building today's submarine is the Jiangnan shipyard. And this is the one that's been around forever. Late in the 1800s, late 19th century, the Qing dynasty had a self-strength movement. This was a movement basically to modernize and strengthen China after all of its civil wars, revolutions, and unrest that it had throughout Chinese history. Chinese history is very complicated and detailed. I recommend you read about it if you're interested in more about it. But just know that in the late 1800s, they went through a self-strengthening movement to unify the country and try to bring them up to the standards of the European countries and America. America and China during this time had very close relationships. And so they purchased a lot of American equipment and they built the Jiangnan Machine Works and the Jiangnan Arsenal, which is on an island at the mouth of the Yangtze River, right next to the East China Sea. It's a great location for a shipyard. The shipyard is actually located on a large island right at the mouth, and so they can use all sides of the island for production if they want to. The American engineers went to China after they bought some of our equipment, helped them set everything up and build some gunboats for the United States Navy in 1905. And then in 1949, they did rename the shipyard, the Machine Works and the Arsenal to just shipyard, the Jiangnan shipyard. All right, let's take a closer look at it. It is a very busy shipyard. It's one of the largest and always has ships under construction. 2/3 of the shipyard is used for commercial use. So most of the shipyard is building cargo ships and civilian use ships. But 1/3 of the shipyard is military and is very busy. They have anything between 8 and 9 ships being constructed or pierside testing at any one time. And they roll these ships out like a conveyor belt. As soon as one is finished and going off to its port, they begin another one. China's been doing this for decades. They've been greatly enhancing their Navy at a high rate. They will exceed a greater number of ships than the United States Navy soon. And they show no signs of slowing down. They have the infrastructure, they certainly have the manpower, and they just need the experience, which they've been getting for a long time, to have a good blue water Navy. Over on the right, you can see some new fabrication and assembly facilities, as well as along the top edge there. You can see how they have plenty of room on this island to expand as they need to. They probably will be expanding this. And there's a housing area too, because this is a partial military base, or there is a military side of the shipyard. The military personnel will actually live on the base, close to their ships. And up in the top, you can see there's some warehouse and storage areas up there. So this is the large shipyard, the second shipyard that is building today's submarine. All right, so I told you that the Song Type 39 was a one of one because it was such a terrible design that did not work very well. But they did build a total of 13 songs. So what were the other songs? The other songs were called Type 039G and Type 039G1. They improved the song design twice. 9 of these were 039G1. So the majority of them were the second version. The first Chinese sub to have a teardrop shape. This is the first diesel boat Chinese sub to have a teardrop shape. I should clarify that statement. It does have rubber coating on the hull. It has a 7-bladed propeller with a 50-man crew, 75 meters in length, which is about 246 feet, standard size for a diesel boat. Some diesel boats are smaller than this, but it's in the ballpark. 8.4 meters beam, 27 feet wide. Again, standard. It's 2,200 tons submerged. So obviously if it's on the surface, it's a little bit less than that. It can travel submerged at 22 knots. It just can't maintain that speed for very long. It's draining its battery quick when it's going that fast, but it can make up that speed for a little while, enough to get out of the way of a torpedo. Mine laying capability. It's got the same number of weapon stows as the original Type 039. And this is just the improved version of it. So the way you're going to identify this, if you're looking at a recognition guide or if you see the submarine at sea, look at the top of the sail. The forward part of the sail is squared. It no longer has that step, but it still has the metal step hanging off the back. So if it has a square front and that metal step hanging off the back, it is a Song 039G or G1. And also look at the round top. The round top will help you identify this versus future versions as well. Okay. All right. Now we're getting into the submarine this subbrief is about. The rest of this before this has been foundation. On that foundation, China went back to the drawing board. They hired Russian advisors, or had Russian advisors, and they built a new submarine. The first photo of this submarine came out in 2005 and impressed NATO, an American, analyst, and we thought that they had a new submarine. So you will often see this submarine referred to as the Type 041 Yawn class because it looks significantly different than the Song. It's got a kilo style sail, sans the Fairwater planes, and it also has the little hump over the topside deck of the body of the submarine, like the Kilo has. It has 2/4 torpedo tubes, so very Kilo-ish looking with the exception of the Fairwater planes on the sail. The Kilo does not have that. So we called it a new type of submarine, but whenever we started recording the submarine at sea in the East China Sea during her sea trials, we found that she had the same prime mover as the Song, the 039. And the way NATO classifies contacts is by their prime mover. The prime mover is the main engine that turns the screw. And it's not just the diesel, no, it's the whole string. It's the reduction gears, it's the shaft rate, it's the, of course, the main engine, the diesel itself. And because the prime mover of the Yawn is the same as the Song, they went back and they redesignated it a Type 039, but gave it the Alpha designation. And instead of changing the name to Song, they kept the Yawn name. So this gets a little confusing. You may see the submarine designated as Type 041 Yawn, and that would be old. It's not updated. The new name, or the more recent name, is Type 039A Yawn class, because it is a significant improvement in capability from the Song. But it has the same prime mover. So technically it's the same class. All right. So they have improved fire control system. It can shoot the electric and wire guided thermal torpedoes. It shoots both the Chinese version of the Harpoon and the Chinese version of the Tomahawk anti-ship missiles. And again, that is the primary mission of the submarine. While it does have ASW capability, it is specific or purpose built to go out into the East China Sea, South China Sea, deep water, and target ships as they come close, as they come into range. She does use the Stirling cycle independent propulsion, air independent propulsion, heat exchanging engine. And we'll go over what that is in this brief. We've talked about that before, but for our new members, we're going to explain that again. And can stay submerged at 4 knots for 14 days without charging the battery. Those 4 knots at 14 days is using the Stirling cycle air independent heat exchanging engine as propulsion. All right, so what is a Stirling engine? Now, Stirling engine has been around for centuries. Like the Stirling brothers patented this design back in 1807. It was a long time ago. It's a very efficient engine, and it is a closed loop engine, which means there's no exhaust, which makes it great for submarines. Because if you can keep the gas of the engine inside a container, then you don't have to worry about detectability or refreshing it with fresh air like you do a normal diesel engine. So I'm going to walk you through the 4 steps of a Stirling engine cycle here. We're starting on the left. First, we're going to describe what it is. We see the flywheel of the motor at the top. That's going to be the mechanical energy that we're creating with our engine. A Stirling engine has 2 pistons or more, but 2 pistons at least, in a regenerator. The regenerator is like the cylinder. Now, that is only for the example that I have here. The regenerator can be its own body, but let's not get too complicated. The regenerator in this example is the cylinder between the 2 pistons. Okay, so the heat sink is on one end of the cylinder. The heat source is on the other end. So all this engine needs to run is a difference in temperature. If you have a difference in temperature, one temperature is going to be hotter than the other. So you want the hotter temperature at one end, the heat source, and the heat sink or the colder temperature at the other end. And the more change, the more delta between the hot and the cold end of the regenerator, the more efficient this engine is. So you want a really hot and a really cold in opposite ends of the cylinder. So as you heat up the hot end of the cylinder, it expands the gas that's in there. It's like literally a gas. And that gas, as it expands, pushes that cylinder, the bottom cylinder, up. Look closely at the cylinder. It doesn't touch the sides. So some gas is allowed to go around the cylinders outside. This design makes it an external combustion engine. Okay, that's the part that makes it external. So as it pushes that cylinder up, it begins to compress the gas that's between the two cylinders. What happens when a gas compresses? It gets hot. So as that area between the two cylinders gets hot, it also expands, pushing that cylinder back down and pushing the second cylinder up with the same amount of force. And as you can see, that begins to turn the flywheel in a clockwise direction. Now that you have the cylinders at maximum change or space between the two, that's where the heatsink comes in and begins cooling off the gas between the two cylinders in the regenerator. And the more efficient it cools, the faster this will go. So as it cools, that gas loses energy and begins to compress again, begins to shrink, and that will bring the top piston down. Also, there's inertia in the flywheel. So flywheel helps keep the momentum of that top piston going down. And as the piston goes down, it compresses again and begins to heat the gas between the two cylinders. Then you simply maintain a heat source at the bottom. That's key. Maintain that heat source, and the cycle repeats itself. And once you get this going, it's very quiet. It's very efficient. You don't need to add fuel. You just need to add energy to the hot side. This is a Stirling engine. All right, so let's begin the subbrief with talking about a Type 039 Alpha Bravo, the Yawn variants by the numbers. There is now a Charlie that we'll also talk about, but the Alpha and Bravo are 77.6 meters long and 8.4 meters beam, so very similar dimensions to the Song. Can do 12 knots surfaced and 20 knots submerged, and has a test depth about 1,300 feet. It does have a crew of 55 people, and they have already built, at the time of this recording, 15 of these, with 5 more planned. The next 5 are going to be the Charlie ones that they've already built one of. See, it has very little physical difference between the Song, the 039G, G1, and the A. I will go over a recognition guide of how you tell all 4 of these apart. That's coming up. The sail reflects a Kilo design influence because we believe they had Russian designers or engineers help them with this improvement. And it really shows that this is basically the Chinese version of a Kilo in both capability and appearance. All right, let's talk about the recognition guide. We talked about the Type 039 Song. The one at the top left is the Type 039G Song because it has the square front and the metal coming out the back of the sail. Just below that is the Type 039A. So this is the one that has the square sail. It's square on the front, square on the back, and it doesn't have the metal prong coming out the back of the sail. So that's the Type 039A. That's how you're going to tell, is by looking at the sails of these. On the right, the Type 039 Bravo, Yawn, has a rounded sail at the top, and look at the bottom, how it kind of slopes off. So it's very similar to our Virginia class that has these sloping joints between the sail and the top side. But the difference between the Type 039B and the new Type 39C is the 39 Bravo has this ball, looks like a bowling ball, on top of the sail. It is some kind of sensor. We don't know what it is yet, but it's there on the forward port side of the sail. So just look at the sail. If you see the ball up there, you're looking at the Bravo version of the Yawn. If you have a rounded sail that does not have this ball, you have a Charlie version of the Yawn. That's how you tell. All right, Type 039 Bravo Yawn. The difference between that and the Type 39A or AG is they've added a flank array. So as you read about the Yawn, if you do your own research, you will see references to a Type 39 AG. Now, all the Type 039 AGs, as of time of this recording, have been upgraded to Bravo. So they don't exist anymore. They were a thing in the past. So if you are reading about AGs, just know that they were there. They're all Bravos now. They've all been upgraded. So we're not going to cover the AG. What is the difference between the Yawn Alpha and the Yawn Bravo? It's this flank array. And this flank array is kind of big. It's a big deal because it is a line of low frequency hydrophones that give the Yawn deep water, long range sonar detection capability. So this submarine is more effective in deep water than it is in shallow water, because this low frequency array in shallow water has very limited detectability. Low frequencies, of course, will still travel farther than high frequency. That's just physics. But when you get in shallow water and these sounds begin bouncing between the bottom and the surface multiple times, it absorbs that energy rapidly. And it also confuses the sonar environment. It becomes very complex because things don't always bounce in a straight line. So not only are you worrying about absorption and reflection, you got signal degradation as well. With this sonar array, China is, designing a submarine to go out into deep water where there's plenty of depth for low frequency to travel very long ranges. And this would be the primary long range sensor of this submarine. It is the H/SQG7 flank passive sonar array. All right, so there is a Type 039 Charlie variant. It is very similar physically appearance and dimensions to the Alpha and Bravo. It doesn't have that ball sensor on the sail. That's how you're going to tell the difference between this and the Bravo. They have built one of these. She did see trials in 2017. The findings from that are still classified. So while we do know about the submarine and we have details about it, when I say we, I'm talking about the United States Navy. It's all classified. We don't, so I can't share it with you. We think that possibly they installed a lithium-ion battery in the 039 Charlie. Again, they're not telling us if they did or not, but we know that China intends on doing this. Whether or not they've done it yet has not been confirmed. Her primary mission is anti-ship cruise missile strikes. She has 6 torpedo tubes. We expect that she has the capability of salvoing 4 of those tubes at once. And so she could shoot 4, recycle her ejection pumps, and then shoot 2 more after that. And then after that, they would have to reload all the tubes. So 4 and 2 first strike capability. And this is a very advanced version of the Yawn. It's very quiet. It's not very fast unless she has the lithium-ion battery. Then she can maintain submerged speeds for a long period of time. If I ever get more information on this lithium-ion install, I will certainly update this brief and let you guys know. There you can see some great pictures of the inside of the Type 039 Charlie, courtesy of Saturn X, the crew at their stations. And interestingly, the officer of the deck watching the periscope doesn't have an eyepiece anymore. He has what looks like a camera with a LCD screen. This is very similar to what the Americans use, except we have flat screen televisions around control. But with that camera, you can just quickly snap a picture. And also, he doesn't have to have his eye pressed up against the periscope, which gives him more situational awareness around the control room as to what's going on. And over on the right, you can see the periscope operator is using an eyepiece. So this camera is detachable. And that is the Type 039 Charlie. There is an export variant of the Song and Yawn. It's called the S20T. Pakistan was the first to order these. They ordered 8 with the stipulation that 4 of the 8 would be built in Karachi. The reason why they do this is obviously they want the submarines, but India and Pakistan and other nations that are developing want to give their shipyards and their shipyard workers experience in building these submarines. While it's just too expensive to rely on another country to build your submarines for you, it's also dangerous because now you're relying on other nations to support your military. Every country wants to have an indigenous military equipment so that if they ever go to war with a country that is supplying them with their equipment, they don't lose that supplier. So every country, it's always best for them to build their own equipment. Pakistan has reached an agreement with China to build 4 of these in China, 4 of these in Pakistan. Thailand has contracted to have one S-20T built, and that is actually under construction right now. These are a double hull submarine, just like the On is. It does not have AIP, so it's shorter. It's only 66 meters long, 8 meters beam, displaces approximately 2,300 tons. That's submerged, of course. 18 knots, 60-day endurance is being generous. The only way it's going to reach a 16-day endurance is if they bring enough food with them. And it has a crew of 38, so it's got a significantly smaller crew, which probably helps the endurance stay out as long as that. So know that they are also exporting, a scaled down version of this. Also, this is a modular design submarine. So China has offered Pakistan and Thailand the AIP package if they want to install it at a later date. So now that they have a Chinese version of the Sterling engine, they are offering that as an export to nations that are developing their own AIP engines as well. I've talked about the Pakistan AIP engine in other briefs. India has one too. India and Pakistan are very interesting, but we'll cover that in a different topic. All right, so final thoughts on China. They're developing and improving their construction capabilities. Yeah, their shipyards are getting very efficient at pumping out vessels, whether it's a ship or submarine, doesn't matter. And they're pretty well designed. I mean, in the past, they haven't necessarily been the best equipment or the most reliable or even quiet, which is important for submarines, or efficient. But they're getting better, and they will eventually match parity with NATO nations. It's going to happen soon. They have better performance in all categories. So, for instance, the Yan A is better than the Song. The Yan B has more capability than the Yan A, especially with that low frequency flank array. And the Yan C is so new, we don't know much about it, but it might have that lithium ion battery. And if it does, that's a hunter right there. That thing is coming after your fleet instead of being a passive defensive anti-ship platform. Let's see, a fleet of 20 Yans are expected to be built. Yeah, I expect 5 of those, 5 or more, will be the Charlie. Performs better in deep water with the flank array, like I said. Can submerge for weeks at a time, even without, because of that Sterling engine, it can stay down there for 2 weeks or more. And it is the next step in China's power projection. China is projecting itself economically, and has been for a long time, around the globe with the Belt and Road program. If you want to know more about that, I recommend you Google it. It's very interesting. It is making China really probably the strongest economic power. It's going to eventually rival the United States with this Belt Road programming economically. But with that, they're also expanding their military influence. Right now, it's focusing on the South China Sea as this recording is being made. And they're building a navy to defend it. They're going to claim eventually the South China Sea and the islands around the Spratly Islands, islands whether that are there already or the islands that they are creating, and they will have a navy to defend it. And it's going to be a good navy, and anybody that goes in there to try and take it away from them is going to have a fight on their hands. And these submarines will be part of that fight, and these submarines are good. Don't underestimate the Chinese. It's easy to do in American culture and Western culture, but the reality is these are capable, lethal machines crewed by experienced sailors that have a good doctrine. Take them seriously. China's Type 94 Alpha SSBN, a subbrief. We're starting the story kind of in the beginning, or in the middle rather, of China's nuclear power program. So just to give you a little backstory, this is a second generation ballistic missile nuclear powered submarine. And so the first generation was called the JA. That program began in the 50s and 60s. A little unclear as to when it actually began. They wanted it to begin in the 50s, but they actually got developing on their SSBN in the 60s rather. And this story is about the follow-on submarine of the JA. So second generation SSBN, Russia came in and helped them design this one. The Rubin Design Bureau that had built the Yankee ballistic missile submarine and the Delta ballistic missile submarines for Russia helped Chinese engineers design this thing in the 80s. They continued on through the 90s, but China really wanted to take the reins as soon as they could and make this a new nuclear power plant design different than the JA, which that's very important. It needed to have higher power, last longer, so they didn't need to refuel it as often. Of course, have more reliability because the Jive was very unreliable to the point they didn't want it to go to sea, and they didn't put weapons on it ever. So it wasn't really a ballistic missile submarine, I suppose, but in name it was. So they wanted to correct all those things by building this Type 94, include some automation that the Russians are very good at. And that process from the 80s to the 90s took about 15 years. And that brings us to 1994. 1994, development of the Jin ballistic missile submarine officially begins, according to Chinese sources and records. The design happens at the Wuhan Ship Design Institute of China Shipbuilding Industry Corporation. This is commonly called CSIC. The China Shipbuilding Industry Corporation owns many different design and development buildings and dry docks and shipyards all over China. So the one in Wuhan is the one that designed this. It was 10 years since they had designed the Jia. And in that 10 years, they had a lot of rotation. A lot of staff retired, moved out of the business for whatever reason. And so they had what we call in the engineering world brain drain, which is a silly term for something that's pretty devastating when it happens to your design bureau, is you lose all that senior experience and leadership. So a lot of the new young engineers are designing this Jin, and they're heavily dependent on the Russian advisors, if you will, to help them do this. A lot of new people are building this Jin. So they struggle to improve, especially like the power levels. This is a new design. It's different than the first generation Jia SSBN. And they've struggled to get the power for this new reactor to be up to standards. And what they end up doing, really, is taking a lot of the old systems that are not power plant related from the Jia and just moving them into the Jin, which ends up being a huge mistake because the Jia, those systems were not reliable then, and they're not going to be reliable again in the Jin at first. A note about the Type 94. There are two variants. The original variant will be very similar to the Jia in terms of unreliability, low capability. The second version, that they make almost immediately, is the 94 Alpha. We'll be talking about both, but I want you to know up front that there are two variants of the Type 94 ballistic missile submarine. So where are they built? We know where they're designed. It's in Wuhan. But they're actually assembled and built in this Hulado shipyard, also called Bohai. I think Bohai might be the older name for it. It's in the Hulado port up in the Yellow Sea, that's northern part of China, right on the coast, in the Liaoning province. Very, very close to, the Korean Peninsula. Very shallow water, by the way. Out here, they have to go a long way to get out of the Yellow Sea into any kind of deep water. But the assembly building that you see there on the left-hand side, I have a zoomed-in picture courtesy of Mr. H.I. Sutton. This is where they assemble all their nuclear submarines. It's from the Type 92 all the way down to the Type 98. Today we're talking about the Type 94, one that's kind of in there in the middle. So they assemble the submarine in that large barn-like building, and they can assemble multiple submarines at once. There's several different assembly paths that lead out to the launch area, so they can do more than one at a time. And what we're going to do is we're going to show you this in detail. This is an incredibly important port and shipyard for China because of its capability to build these nuclear submarines more than one at a time, very similar to American capability. The submarine construction building, often called assembly building, is there on the left. It's the white building that's multi-stories high, 5-6 stories high. From there, after they assemble all the hull pieces and weld them together and put the systems inside, they will wheel it out into an area behind that building where they'll find a dry dock. And the dry dock can be flooded, it can be dry. They can launch them either way. If it's dry, of course, they'll eventually flood the dry dock and float the submarine, where they then will open up the gate, if you will. It's also called a caisson with a tugboat. They just pull it off. And I'll show that to you in detail in a second. And they can tug the Jin that just was floated over to one of the pier where they begin pier testing. And there you can see close-ups of how that happens. They have a bridge crane to help move the submarine along these train tracks into the launch area, dry dock basin, and then they have these piers out in this little shallow area where you see all these other ships where they can continue to work on the submarine after it's been assembled. Here's another picture of what I'm talking about. The assembly building is outlined in yellow on the left. Very large building. You can see multiple train tracks that go towards the water. And you can see on the top, they're assembling what appears to be some sort of ship. And that ship will eventually be tugged or pulled into the launch basin that's there at the top of the picture. For what we're talking about today, it appears that they've just recently assembled one submarine that is sitting in the dry dock that has been flooded, and that submarine is floated now. So you can see the path it takes from the assembly building down these railroad tracks, if you will, down a slope into this basin. And like I said, this basin can be dry when they do this. It can also be wet. It's up to them on how they want to launch it. But once it's in that basin, they do eventually flood it with water. And this can happen over the course of a couple days. This isn't exactly, this doesn't happen quick. It can, but typically it doesn't. Everything they do here is very calculated and methodical because they don't want to damage the submarine just getting it into the water. It's a very hazardous operation, and it's something you do carefully. So here at this arrow where I've got my cursor now, you can see that there's a door there, what looks like a door. And whenever there's water on both sides of that door, it's very easy to move. So they just put a tugboat to that, and they can swing it out, completely detach it, and move it off to the side so it's completely out of the way. And at that time, that's when they'll come in with the tugboats and begin tugging, literally pulling that submarine out of the little flooded dry dock area and over to one of the piers on the right hand side. And that happens on launch day. And again, launch day this whole process can take more than one day, but that's the launching process. And that's the difference between keel laying, which happens in the assembly building. Years later, when it's assembled, it gets launched, which is what I just described to you. And then once it's pierside and it's finished all of its pierside test, which can take months and sometimes years, it will then be commissioned into service at that pier. And that's kind of the process from commission to launch, keel laying, launch to commission. So let's talk about the type 094 by the numbers. Displacement wise, these are very similar submarines. So we're just going to combine the 94 and the alpha variant into one description here. They displaces about 11,000 tons submerged. That's with its armament installed. It's about 450 feet long. So it is a long submarine, but it needs to be because it's a ballistic missile submarine. And it's 40 feet abeam, which is in line with the dimensions of, say, a Delta, like a Delta 2 maybe. So it's basically a Chinese variant of one of the Deltas, if you can think of it that way. It does have two reactors, just like the Deltas, that provide 3,000 shaft horsepower to a single shaft. And that's where it's a little bit different than some of the old Soviet boats. A lot of the older Soviet boats like to have two shafts. But here we only have one, but we still have two reactors. And they're very noisy reactors. They really did not improve hardly any of the sound silencing significantly from the JA. It is a 7-bladed screw. They did get that right. Thank you, Russia. But it does 20 knots on the surface, 25 knots submerged, and that's, I think, rounding up a little bit. I don't know if they'd be able to maintain that speed, but they can reach that speed. So the test depth is about 1,300 feet for this ballistic missile submarine. Its quietest lineup, the quietest we've ever recorded this thing, according to public records, of course, is 120 decibels, which is not quiet at all. That's in its patrol quiet lineup. It's still radiating like a rock and roll concert. It's just not good, sadly, for the Chinese. But it does shoot 12 of the JL-2 SLBM, submarine launched ballistic missiles. The A variant upgraded that to the JL-2C, also incorrectly, in my opinion, called the JL-3. Some public sources call the JL-2C JL-3. I believe those are wrong. Just know that they're talking about the same missile if they do that. It does have 6 torpedo tubes. They're all 53 centimeters, so no big long-range torpedoes, just regular tactical torpedoes. They are capable shooting of the Fish 3 torpedo, also known as the YU-3 torpedo. This is the same torpedo that they designed for the Han, which was first generation fast attack. Not a very capable torpedo at all, but it doesn't need to be. The mission of this boat is to take 12 missiles out into the China Seas and submerge them, hide them from satellites and so forth. So they're not too worried about tactical torpedoes. It can shoot the Set 65E though, which that's a Chinese version of a Russian torpedo. Know that the U-3 is just one of many different variant torpedoes. There's a U-4, 5, and 6 that are each more advanced, but we know that the Jin does shoot the U-3. She can stay at sea for about 90 days, which is comparable to just about any other ballistic missile submarine in any Navy, and has a 100-person crew, which is, again, typical. So where do they base these out of? Well, a major base in China, and it's the largest in Asia, the largest submarine base. Let me caveat that. The largest submarine base in Asia is in Yulin, also known as Sanya. And it's ironically a resort island. So you could get a hotel room across the bay from the submarine base, walk out on your balcony with your coffee in the morning, and watch naval operations happen across the way. There's a few interesting Instagram accounts out there that have taken photos of the little cave that they take submarines into. There's an underground bunker, if you will, something straight out of a James Bond movie, but that you can see from the hotel. Yeah, across the bay. But getting back to the base, they have 16 submarine berths and 4 maintenance piers. So, and you can put multiple submarines on a maintenance pier. So this is a very large base. They also have an underground submarine pen that we're not sure exactly how big it is, but we've seen the Jin, the large ballistic missile submarine, being tugged in and out of the submarine pen. So we know it's at least big enough to hold one ballistic missile submarine at a time. It is possible that in this underground pin is where they conduct the missile loading. So they do that out of the sight of satellites. So no one really knows how many weapons are on the Jin. And like I told you, the Ja went to sea rarely. And when it did, they didn't dare put a nuclear weapon on it because they didn't know if it was going to come back, which is something that not too many people know. Okay, the Type 94 hulls 1 and 2 and Type 94 Alpha hulls 3 and 4 are all based out of Yulin. So the first 4 of the 8 that they're going to build are based out of this southern submarine base. This is in southern China. So here's some expanded photos of what I'm talking about. At the top of the base, because it's on this peninsula where you see that shoreline right there, they have these underground tunnels going to an underground facility. And this is where they can train in nuclear weapons and rocket bodies, and they store them all underground, which is a great place to put them in case something terrible happens. It's contained. Down at the bottom, you can see one of the new Jin-class SSBNs sitting along one of the piers right there. And on the right-hand side, you have the cave entrance. The Federation of American Scientists have blown that up for you so you can see a little bit better as to what it's like. It's literally looks like a train tunnel, but it has water going into it instead of train tracks. Yeah. And notice the demagnetization facility over there on the right-hand side where they can demagnetize these boats, which is a pain in the butt to do. I can describe it for you. Basically, days before you go into this facility on the surface, of course, you just get tugboat over there. You don't even drive over there. They push you over there. But because you're demagnetizing the entire submarine, you have to take all magnetic media off the submarine. And back in the 80s and 90s, you know, we didn't have that many hard drives and stuff, which we had to take those off too because those were magnetic back then. They weren't like the SSDs we have today. We had to take all this stuff off the boat, and it took days to do. And a lot of it was secret, which meant 2-person control on every little thing, whether it was a floppy disk or a huge hard drive that weighed 50 pounds. You know, you had to have 2-person control the entire time. And talk about a logistic nightmare. The entire weapons department, pretty much the entire crew, had to get together, organize how they were going to take all this information, hard drives and magnetic media, tape drives, reel-to-reels we had back then, everything. It was a mess. And put it somewhere safe and then secure that location for the day that it took to go into the demag facility and then come back out again. Yeah, crazy operation. Really sucks when you have to do it, but whenever you come out, you don't it kind of resets your hull, magnet signature down to 0, which is great because that's what you want. Because the longer you go underway, the more you drive around the globe, that signature becomes louder and louder on the magnetic spectrum, which is something that maritime airplanes use to find submarines. So very important facility there on the right. All right, the other submarine base is up north in the Yellow Sea. And it's the Yangzheng, or also known as Loshan submarine base. Again, 2 names. On the Yellow Sea, it's very shallow water, so whenever the Jin ballistic missile submarines transit out of this, they have to go a very long way to find deep water. A lot of times, they won't bother. They'll just go out into the Yellow Sea, submerge, and just stay right there, because it's very hard for any other Navy to get into the Yellow Sea, other than, like, say, South Korea. And South Korea doesn't have a lot of ASW capability. They are getting better, by the way, but yeah. And this is where hulls 5 through 8 are. And again, 8's not built yet at the time of this recording. We're going to get into that. But this is where they keep them up north. It's in this Loshan submarine base. There's the coordinates for you if you want to look it up on Google Earth. You may see something interesting if they've updated it since then. They also have an underground submarine pen up here. It's a very common trait, it seems, with these submarine bases. It's also a very smart way to protect nuclear weapons in case there's an incident where one gets dropped or something. And if there's any kind of casualty, it's at least contained, inside this underground bunker. So, and on the right-hand side, you can see kind of the perimeter wall around the base there. I think they've done a great job. This is from Federation of American Scientists, by the way, of labeling everything. They're very meticulous, the people over there. So thank you for this. All right, so let's talk about what they launch. The JL2C is the improved version of the JL2. Remember, the first 2 gens shoot the JL2. Hulls 3 through 8 will launch JL2C, which is also called Giant Wave. That's what the name in Chinese means. The American or NATO designation is the CSS-N5 Sabo. It's the naval variant of the DF-31, which is a land-launched, truck-launched Chinese ballistic missile. Has a range of about 5,000 miles. Can carry, a single warhead anywhere between 250 kilotons to 1 megaton. So variable yields on these warheads. And more commonly, it'll carry multiple reentry vehicles, 3 maximum, each with 90 kilotons. Those are like little city killers is what they refer to them as. And so each one of these missiles could potentially take out 3 cities within 5,000 miles. Very deadly missile. The missile, ironically, more capable than the submarine. All right, let's talk about the U-3 Fish torpedo. And remember, there's a YU-1 all the way up to a YU-6, but we know that they shoot the YU-3, so we'll talk about this one specifically. Its service began in 1984. It is the first indigenous to China, large scale, in other words, they mass produce these, sound-guided deep water torpedoes. So they have a lot of new capabilities with the YU-3 that the previous versions didn't have. They did originally make this for the Han, which is the fast attack first generation submarine China has. We have a subbrief on that as well. It is a 53 centimeter diameter torpedo. It's 7.8 meters long. It is battery powered, so it is not combustion like the Mark 48 is, for example, or the Spearfish. This has a battery in it. And it's passively guided, which is one of the major upgrades that they had. This thing goes out to a specific range where it is told before it's launched to turn on its sonar. And it just listens to whatever is the loudest noise. It points the nose of the torpedo so the loudest noise is right in front of it. And that noise can be anything. It could be a trawler, it could be a submarine, it could be a warship. Yeah, whatever. It has very little target discrimination, which makes this weapon terrifying, kind of. Because if you're making more noise than your target, you could potentially become the target. And like I said, these things are not exactly quiet submarines. So the YU-3 Bravo is an improvement on this YU-3 torpedo. And what they did with the Bravo version is they added active sonar. So it can actually ping out a high frequency ping It's above human hearing, so if you were a diver in the water, you would never even hear it because the energy level, the frequency is too high for your human ear. But sonar systems can hear it, and that's how it works. It's a high-resolution, short-range, active homing to help lock onto a target essentially. But in order to do that and make it work, they had to reduce the top speed down to 35 knots. And that's really a problem because a lot of modern ships and attack submarines can do close to 35 knots. So if they have just a little bit of a head start, a couple thousand yards, they can probably outrun this torpedo until it runs out of battery power. And something about battery powered torpedoes in general is that they will kind of slow down as that battery gets below 50% power. Just a little bit. They'll kind of ramp down on you, and then they cut off all of a sudden whenever the battery isn't strong enough to turn the motor anymore. Another upgrade to this was the YU-3C, where they increased that speed back up to 40 knots. The range is only 15 kilometers, though, which is relatively short range, so it's got to get close to you to hit you with one of these things. It does have a 205 kilo warhead, which is about 450 pounds. That's reasonable for a heavyweight torpedo. I think it would call it a heavyweight. The torpedo must slow down near a target to lock onto it. So it's going to run at you for 40 knots. And then just to make sure it hits you, it'll probably go down to 35 or whatever it needs to get down to make sure that it gets close enough for a detonation. In 1992, we found one of their torpedoes and realized when we took it apart that they were using a Mark 48 guidance circuitry in it. And that blew our mind because how did they get that, right? So China either got the design over some kind of network or through espionage. We don't know. But they're using, as of 1992, we know that the Mark 48, this is not the ADCAP, by the way. This is the old school 1980s Mark 48 guidance system, was found on a YU-3C that I suppose we had acquired from them and found that they had acquired it from us. And that's the way it works. All right, let's talk about these hulls that they built. So I told you the first two hulls are the older ones. They're the Type 94s. They shoot the older missiles, the JL2s, not the 2Cs, the old JL2s. The first hull was laid in 1999, commissioned in 2007. So it took 8 years to build, and they build these two at a time. So the other one was 2002 to 2009, and there you can see pictures of them. They're down in the Yulin Island base, and their common operating areas there are either right off the coast in the South China Sea, or they could go over to the Philippine Sea. They often go to the Philippine Sea because that puts them within strike distance of cities like Seattle and west coast of the United States. So you could see them over there. But they knew that they had to make improvements. They knew that the Jin was not significantly better than the Jia. It certainly wasn't more reliable, and so they had to change a few things. So one of the first things they did was improve the missile itself, because while all this is going on with the submarine, you have an entire division of people separate from the submarine division working on improving missiles. And they're like, hey, we've got a better JL2C now. It's got, it can carry more, it can shoot a lot farther, but it's a little bit taller. So you're going to have to adjust your submarine design so it fits in the submarine now. So they do that. They change the missile deck a little bit. It's a little bit taller now. They also make it a little more round, a little more smooth. So it's more hydrodynamic. It doesn't vibrate as much whenever it's moving through the water. It also doesn't slow the submarine down with hydrodynamic drag as much. They also removed the sail windows in the forward part of the sail, and that's very much a Russian feature on a lot of Russian boats because they have very cold water ports. And so in really bad weather, you would keep the crew down inside the sail looking out these windows. The problem with those windows is that they make noise. They are removable, but even after you remove them, you have a bunch of holes in your sail that can whistle as water flows through them, just like you whistle when you blow air through a whistle. It has that same effect when water goes through these windows. They just got rid of all that. They were like, we don't need those. We're going to use a sail at the top, just like everybody else. So the enlarged missile bay was one. They removed the sails. They maintained the same number of missile tubes as the Type 94. I need to stress this point because there is a lot of misinformation out there that I don't want you to get tricked by, where people think that they changed the number of missile tubes. They did not. They simply made the missile tube a little bit taller, but they kept the same number. It's 12, a dozen. Very easy to remember. They also have a retractable towed array there on the back. All right, so this new and improved Type 94 Alpha SSBN begins with Hull 3. Laid down in 2003, commissioned in 2011. Again, they're building these two at a time. So 2003, 2004, that's Hull 3 and 4, commissioned 2011, 2012. These two are going to go down to the Yulin Naval Base as well in the South China Sea. So the first 4 hulls total, South China Sea based. Here's a great chart that I found for you. It gives you an idea of how loud these submarines are compared to other submarines. So at the very noisy part of the list is the JA SSBN, where they literally didn't sound silence anything. When they start that thing up, you can hear it from space. It's extremely loud. It's actually louder than the Han, which is hard to beat. Really hard to beat. So the Han and the JA, loudest nuclear submarines ever created in the history of naval warfare, period. Second is the Shang and the Jin. So China just has a bad record of not being able to make quiet boats. And this is before the crew gets on them and starts banging doors and stuff. And they're all noisier than even the 1970s Victor 3, 1980s Victor 3. So they never even achieved Cold War level sound silencing. I will say this, in 2021, they've improved a lot, and they're still building these Jins. So each one that they build is a little more quiet. I must give them that credit. They are making improvements. But on a scale of Cold War nations, they're still behind what Russia was in the 1970s. So a little bit quieter than them is the Victor, the Akula, the Oscar, the Akula 2, improved Akula, as we would expect. And then the more modern Severnitsk, for example, one of the quietest submarines, also known as the Yasen, quietest submarines in the world right now. So that's the scale for you, just to give you an idea. These boats are easy to find. They're still deadly as hell. They carry 12 missiles that will destroy up to 3 cities apiece. Within 5,000 miles. And that's no joke. That is a very real capability. So just because they're noisy doesn't make them useless. They do go to sea with missiles, unlike the JA. All right, let's move on to hulls 5 and 6. Again, these are all being built in the same shipyard that we had talked about earlier. But with hull 5 and 6 being commissioned in 2018 and 2020, which these are being based out of the northern subbase, the North Fleet, China's North Fleet, at the Lo Shan submarine base. That's the one on the Yellow Sea. And oftentimes, whenever these are deployed, they may just stay in the Yellow Sea. They won't even try to venture out into the Philippine Sea. A large part of that is they have to go by Japan and South Korea to do it in shallow water. And it's really hard to sneak around those two countries. I'm not saying that they won't try, but a lot of times they'll just go to the Yellow Sea and submerge for months and then come back into port because it's easy. And if something happens, they can go help them real fast. You know, they can come to the surface, get towed back to port, and it's not a 100-mile journey. So a lot of times these guys will not go very far. And with them is hull 7 and 8, again, stationed out of the Northern Fleet. But hull 421 was just commissioned in 2021. So this is a relatively new boat. Don't know a lot about it. We assume that she's a lot quieter, but she does carry the same missile as the earlier versions, the JL2C with the 5,000 mile range, 3 warheads and whatnot. And she's going to be based out of that northern port as well. And at the time of this recording, there is one more under construction. And this surprised a lot of us. They had announced that they were going to build 5 of these Jins back in the 90s or early 2000s. They ended up building 8, and through bad luck and maybe some laziness, we didn't know about 7 and 8 until relatively recently. So they're continuing to build these, and who knows if they're going to stop. Maybe they build hulls 9 and 10. We don't know, but we know that hull 8 right now is under construction in the Huludao shipyard, right? It's been assembled and it's in the basin and it's going through pierside testing. We expect her to be commissioned next year in 2022. We don't know if that's going to happen. Sometimes these pierside tests, if they don't go well, it could be a couple years before she's commissioned. But if everything goes well, from launch to commission is typically a year, maybe a year and a couple months. And that is the 8 Type 094 SSBNs that China operates. 12 missile tubes apiece, 3 warheads maximum per missile, 5,000 mile range, city killers. All right, so my final thoughts on this. You probably get my impression just by describing these to you that this is a less than capable submarine. And you'd be right. Just to be honest with you, it's not great. But what I will say in doing the research for this is one of the most secretive development projects I've tried to find information on. There is so much misinformation on this topic on the internet. It's mind-boggling. And it made me really question a lot of my sources. I really had to buckle down and go to sources that I trust, like CSIS, H.I. Sutton, of course, Saturnax, people that I know what they're talking about. Because when you go to sources that are less than reliable, like journalist sites, even they get it wrong. And I believe some of it may be intentional. There may be some intentionally disinformation out there on the internet about the capability of these Chinese submarines. One, to make them sound better than they are, and in some cases to make them sound worse, so it's not as much of a threat. And the truth is somewhere in between those things. And that's what took most of my time in writing this. Very few public announcements. As far as open source intelligence goes, I just went to the ones that I knew I could count on, like globalsecurity.org. So a lot of credit to all those guys. This is a second strike threat. That is credible. In other words, if any country were to strike China with a nuclear attack and decimate it, any one of these submarines that are deployed, no matter if it's in the Pacific or if it's in the South China Sea, they could retaliate. So that's really their purpose, is to make sure that no one conducts a first strike on China. It is a very noisy submarine, and quite honestly, not much of an improvement over the JA. The Type 94 Alpha is more of an improvement, but the original Type 94, really not much better. And that was with Russian help too. Maybe they should get a refund. Papa SSGN Project 661. Our story begins on August 28th, 1958, with a resolution of the Central Committee for the CPSU and the Council of Ministers for the USSR to create a new high-speed submarine and a new type of power plant to push the submarine through the water. Project 661 Ankar is authorized, and TSKB 16, that's Submarine Design Bureau 16, now called Submarine Design Bureau Malachite, will design the new submarine. This is going to be a high-speed submarine that can launch a new anti-ship missile from a submerged position. And this is a new technology that they're testing. One, they want to push a submarine through the water as fast as possible. That's the first goal. The second goal is the missile boys over there in the missile factories have come up with this new anti-ship missile that can be launched from a submerged platform. Up to this point, all the anti-ship cruise missiles have been launched from submarines in a surfaced position. So the submarines need to expose themselves, which is not good for the survivability of the crew and the ship, and then launch their attack and then submerge again, which takes time as well. Well, with this new missile, they can launch from essentially periscope depth, which will add to the survivability of the submarine, and the effectiveness of the missile is improved due to the surprise factor of this attack. So they want to design a platform that can take advantage of this new missile. All right, Severnance Northern Machine Building Enterprise gets the orders to build the submarine. Technical design drawings are delivered in 1961, and they call for a titanium hull. The reason why they're using titanium is because it's lightweight, strong, low magnetic, anti-corrosion characteristics as well. Now, the tools, right now there's no tools that exist to make this hull, so they need to create the tools to create the ship, and they begin doing that in 1961. And that's what shipyards do. Every time they get a new design, there's some form of setup process that they have to begin before they actually begin construction of the ship. So it's a year later, 1962, where the first hull sections begin to be produced in Severnensk. It is a two-hull design. Both hulls are titanium. So it's an outer hull encompassing an inner hull, that is the pressure hull, Both are titanium, so this is a very expensive, very difficult process, but it's overall very lightweight. The reason why they're using titanium for the most part is for the weight restrictions, because again, they're trying to get that high speed, and titanium is much lighter than steel. Steel would have been the other option. Okay, construction lasted almost 10 years because it's a very difficult process, and it's the first time they're doing an all-titanium hull. Commissioned finally in December 31st, 1969, just before the end of the decade, literally just before the end of the decade. They had two choices of reactors to go into the Papa SSGN. One was the simpler and proven water pressurized reactor that they had used before. And one was a new idea up and coming that they would eventually use on the Alpha submarine that used a lead bismuth cooled reactor, which is a liquid metal cooled reactor. It gives you an idea of how hot these reactors are, that they can actually use metal as a coolant, liquid metal. Well, they went with the water pressurized reactor because it was more practical, and they had the design already, and they could just, use a modified version of the current idea of the current pressurized water reactor. One of the nice things about this reactor is that it has a pipe-in-pipe system. So if you imagine two pipes, one very thin is inside a much larger diameter pipe. The thin pipe is the primary loop. That's the pure water that actually touches the reactor core and gets very hot, but it's pressurized so it doesn't flash to steam. It just stays as a very hot liquid. That's why it's water pressurized reactor. And that goes through this very thin pipe through a fatter pipe that is the secondary loop. And that again is water, but it's not pressurized so that when it does get hot, it flashes the steam. And that steam is what turns all the generators and the main turbine that turns the shaft. That steam is what powers everything in the engine room. So it's a pipe-in-pipe system. The reason why the pipe-in-pipe system is so important is it allows for a very compact design. It doesn't take up as much space because you don't have two pipes running parallel to each other or in the vicinity of each other. One pipe is literally inside the other pipe, one just being a small pipe, one being a larger pipe. Now, because they put two reactors on this ship, two completely independent reactors, they didn't put a diesel generator, and this is a real first for a submarine. They don't need a diesel backup generator because they have two reactors. One reactor will be the backup for the other if either one goes down. Both reactors are identical and they're autonomous. In other words, they don't share any systems. So if there's a problem with one, if one scrams or is down for maintenance, the other one can still power the ship. And they still have a very strong battery as a backup source. In the unlikely event that they lose both reactors at the same time, they still have a battery to power emergency systems, get them to the surface, and radio for help. So a 2-reactor, no diesel engine, strong battery. One of the advantages of taking out the diesel generator is, one, it saves them a lot of weight. Diesel generator and all of its systems are very heavy, and the fuel oil that is just basically pushed around the ocean as they go on deployment and very rarely used, maybe only in an emergency, is a lot of weight as well. So while there is some additional weight, obviously, in adding a second reactor, but of course, they save themselves a lot of weight by taking out this diesel generator. All right, weapon systems. Let's talk about the Amethyst missile. Its NATO name, SSN-9 Cyrene. It's an anti-ship cruise missile. They put 10 of them on the Papa SSGN. There's 5 on the port side, 5 on the starboard side, just forward of the sail. They are in individual tubes that are on a 32-degree incline facing forward, and they're between the pressure hull and the outer hull. Remember, we said this is a 2-hull submarine. So you got the inner hull, you got these missile tubes facing forward, kind of at a 32-degree angle, aiming kind of up a little bit. And then you have an outer hull around all of that. 2-hull submarine, 10 missile tubes on the outside. So the Amethyst uses a solid fuel rocket motor to launch up to about 200 meters in altitude. Pretty high altitude for compared to today's cruise missile standards. But for them, this is still pretty revolutionary that this thing is even coming out of the water at all. So it goes up to 200 meters in altitude where the rocket motor burns out, and it transitions to a turbofan propulsion, much like today's cruise missiles do, whether it's the Tomahawk or the Harpoon. Those use turbofan propulsion. Well, this one did too, but it did it back in the 60s. So It does have a nose radar that's used for target acquisition and has also an infrared sensor on the top ventral wing as a backup for target detection, because they know as they close on the fleet or on the target, there's going to be electronic jamming. There's going to be ECM countermeasures to try and confuse and obscure the radar picture of the target in a hope that the missile will just miss the ship by enough to not damage it. So as a backup to that, during its terminal phase, it has an infrared seeker to assist the radar in case the radar begins to wash out. This is a great countermeasure to ECM. Okay, the launch depth is 30 meters, which that's a little bit deeper than periscope depth, but 30 meters is where they're going to launch it from. The cruise missile has a range of about 70 kilometers. It is a subsonic missile. It's about 0.9 Mach, so just below supersonic. Submerged launch is done in 2 salvos of 5 each. And this is a real limitation that the designers did not like, but because of the technology they had at the time with their fire control systems, they couldn't add enough data to the missiles to launch them all at once. So they had to launch them a maximum of 5 at a time. They couldn't do more than 5 at a time. So, and there was a 3-minute reset between each launch. And that's a real problem because you only get 1 surprise attack. You don't get 2 surprise attacks on the same target. So the choices were to shoot 5 missiles and run away, come back another day, or shoot 5 missiles, wait 3 minutes and hope you're not counterfired on or attacked, and shoot again 5 more missiles. And so that's a real tactical limitation, but it's the limitations they had at the time. There's 4 53 centimeter torpedo tubes in the bow, and those can be launched down to a depth of about 200 meters, so pretty deep. They have 12 torpedo stows in the torpedo room and the Lodaga fire control system. All right, sonar navigation and communication. Here you have the MGK 300 sonar, allowed for 2 simultaneous target tracks to go to fire control, which is pretty standard for the time. They had the Radion 1 mine detection sonar, which is a high-frequency forward-looking sonar. Sigma 661 navigation complex, allowed for under-ice operations, so she was Arctic capable, which makes sense because she was stationed out of the Northern Fleet, which is Kola Peninsula. They're on the western face, as they call it in Russia, towards the Atlantic. The automatic ship course and depth control was the Shapar system, and the Signal 661 general ship systems control. That's like opening and operating all the valves for ballasting and other operations around the ship. That's all kind of done by that. And the MTP-10 surface radar, just a short-range surface and navigational radar. Okay, Papa SSGN by the numbers. 106 meters long and 11.5 meters beam, which means wide. Approximately 7,000 tons displacement. There's a little bit of a flexibility in that number. Multiple sources have different tonnages, but they're in the vicinity of 7,000 tons, which would make sense for the speed that it goes with the horsepower that it has. So the 7,000 tons is about right. There's a 400 meter test depth estimated. She does have 2 shafts of 5-bladed propellers. The propellers were shrouded at one time, and then they were not shrouded towards the end of her life, so it's possible that the shrouds were removed at some point, but initially she did have shrouds around the propeller. Okay, she had 2 B5 Papa water pressurized reactors. Again, they're both autonomous, completely turning their own main turbines, which is the big engine turbine that turns the shaft and the thrust bearing all the way down to the screw. Those are completely independent of each other. And each one of those produces 40,000 horsepower. Now, just to give you an idea of how much that is, the American Navy Seawolf class submarine has 1 shaft that produces 45,000 horsepower. This one has 2 shafts in the 1960s that each produce 40,000 horsepower. It is an enormous amount of power and torque that is pushing the submarine through the water. And this is how they achieve such high speeds. It's relatively lightweight for as much as it has going on inside with like 2 reactors, which obviously is pretty heavy. But their power to weight ratio is so high, they're able to achieve 44.7 knots. Their officers to crew ratio is also kind of skewed a little. They have 25 officers to 55 crew. Now, typically on a submarine, you'll have 1 officer for every 8 to 10 enlisted men. In this case, they have about a 1-to-2 ratio of officers to crew. And that could be because of the high visibility this platform had. It was good for everyone's career, whether they were officer or enlisted, to serve well on the Papa SSGN. And she had approximately 80-day endurance, which is pretty good for the time. She could stay at sea for over almost 3 months. All right, let's talk about the one and only hull they made of this class. The K162 was her original name. Eventually, she would be renamed K222, which is what she's more popularly known as today. NATO designation Papa. The Russian Navy called her the Golden Fish. I've also seen this called Goldfish. So it's either golden or goldfish. Both apply in this case. The reason for this varies. 2 reasons. One of them are the titanium hull turned a golden color while during construction, and it kind of, before they had the paint and stuff on it, looked pretty golden, which is the less likely reason. The more likely reason is the sheer expense of this thing. This was an expensive submarine that took, a decade to build, and used the most expensive materials, and was just, a completely over budgeted project. And so that is the more likely reason it was called the Golden Fish by the Russian Navy crews. All right, in 1963, December 8th, the first keel section is laid in Workshop 42 in Severodvinsk. In 1965, January 27th, titanium welding is done in an airtight chamber with welders in diving suits using argon medium and tungsten electrodes. So right away, we're doing brand new construction techniques in a very unique airtight environment that is very dangerous and very expensive. And we haven't even got the construction done yet. So in 1969, after she's commissioned, during sea trials, she brings her reactors up to 80% power, and just at 80% achieves 42 knots for 12 hours. She transits for 12 hours, half a day at 42 knots. She travels an immense distance during this sea trial test, and everybody's really impressed. But during this test, she rips off 3 missile tube hatches, the sail access cover, and the emergency distress beacon buoy cover are just completely ripped off. And what blows my mind is that after they lost the first missile tube hatch, they didn't stop. They kept going. I wonder if they would have ripped them all off eventually, probably. So in 1979, the next year, December 9th, she does join the Northern Fleet and becomes operational. A few days later, about a week later, in December 17th and December 18th, a world record-setting test is scheduled with Admiral Maslov, Chief Designer Sholtenko, and construction contractor Palenko on board. And all 3 must agree to do this if they're going to try and bring the reactor up to 100%. Well, they agree to bring the reactor up to 97.7%, and they achieve a speed of 44.7 knots. There is immense vibration in the center line of the ship, and they don't go to a full 100%, but 97.7% is close enough for them, and they reach 44.7 knots, submerged, sustained. The next year, in 1971, in October, she is deployed to the North Atlantic, where she does trail the USS Saratoga battle group across the Atlantic. Now, she is not quiet at all. The Americans know that she's there, but there's nothing they can do about it. The ship is so fast. Every time they send out, a submarine to chase her away, or some helicopter units to detect her and lay down sonar buoy fields, she can simply go around them. She's not worried about being counter-detected as much as she is being a pain in the American side with her abilities. All she has to do is stay within 70 kilometers to apply her trade to shoot her missiles. And so she trails the USS Saratoga across the Atlantic. In 1974, she does go to dry dock. She has post-dry dock testing afterwards, resulting in seawater leaking from sonar transducers into the submarine. So as the sonar transducers are mounted on the little cylinder in the bow, there is an area between the inside of the cylinder and the outside that has a gasket on it. Well, one of the gaskets started leaking and had some water go inside there. It caused real damage and problems, but nobody was hurt. It's more common than you would think, the sonar transducers leaking. A Okay, 1975 took part in the Ocean 75 war games in the Atlantic. Those are Russian war games. And she was observed from a long distance away, obviously, because she's so loud. And we just observed her tactics and how she would conduct her attacks. And she was successful in those war games in conducting multiple attacks on Russian surface units. In 1978, January 15th, she's assigned the new number K222, and that's what she's known as today. All right, K222. In 1980, during post-dry dock testing, the reactor protection system failed. There's mechanical and electronic systems that keep the reactor from overpowering or doing something that would damage the reactor. Well, those protection systems failed, resulting in an increase in reactor temperature and pressure, which depressurized the primary loop. The problem with depressurizing the primary loop is, one, the only way that happens is if there's a leak, so there must have been a leak, and that primary loop that's under pressure flashes the steam. That's really bad because that steam has to go somewhere, which is probably the secondary loop, and it leaves the fuel exposed to air because that void that the steam leaves and fills becomes air. And without cooling on the reactor fuel, it will melt. It won't explode or anything like that, but it simply melts, and that causes a real problem when that happens. Well, thankfully, there were no injuries. They stopped the depressurization before any of that happened, and were able to get it all cleaned up. But there was a reactor incident on the K222 during post-dry dock testing in 1980. Okay, 1981, she conducted a 3-month patrol in the North Atlantic. It was uneventful. We watched her from a distance, a large distance. She demonstrated that she's fast and she's looking for people, but because she's so noisy, we were able to kind of go around her. When I say we, I'm talking about the NATO fleets. Okay, in 1984, she is finally decommissioned, and in 1988, she's put into dry dock at Severnensk for disposal. It is over almost 20 years later, just over 20 years later, when in 2010, she's eventually cut apart. The reason for this delay is because the disposal of these nuclear submarines are very expensive. And we've seen this time and time again with just about every single decommissioning of a nuclear submarine, whether it's in the Royal Navy or it's in even the American Navy or the Russian Navy. These ships sit, in dry dock until there's enough means and people and time to dismantle them. And in this case, it took over 20 years before they finally cut her apart, and the reactor compartment is kept afloat for defueling. So even after they're done cutting her apart, as you see here, the reactor compartment is still intact. So it isn't until 2014 and 15 that they remove over 700 fuel rods from both reactors. It takes over a year to do that. And today, the Papa's reactor is sitting in storage, long-term storage in Saidya Bay, Kola Peninsula. And Saidya Bay is one of the long-term nuclear reactor storages for the Russian Navy. You can see a lot of reactors just basically stacked up side by side, Russian reactor compartments, all just kind of sitting there. And they're in shielded containers now, and they'll just sit there forever. All right, so my final thoughts on the Papa SSGN is what a time the 1950s and 60s were. I mean, they did amazing things between launching Sputnik to producing, submerged submarines that do almost 45 knots. It was just really an incredible time for both the Americans and the Russians. Both countries made a lot of achievements and improvements in these 2 decades, 50s and 60s. Papa SSGN demonstrates the capability of submarine nuclear power taken to the extreme, which means we're capable of doing these incredible designs and pushing our submarines faster and faster. The reality is we can't afford to do that and maintain that. That's why, even though we have this ability and this technology, both NATO and Russia, we don't build these anymore to this level because of the cost it takes to maintain this fleet. So the Papa really was a demonstration in fiscal irresponsibility, and the feasibility of this program was ended after this one hull was built, just due to the cost of it. On the other hand, had they been able to afford even a squadron of these, much less a fleet, they would have done. It would have changed the Cold War, because this submarine was able to trail American carrier groups across the Atlantic, and they would have been able to do in the Pacific if they had some over there. There wouldn't have been any reason why they wouldn't. So thank goodness they couldn't afford to build more. So it was very ahead of its time. It had a high kill probability because of the surprise attack nature of its missile attack, even though it was limited to only 5 missiles per launch per salvo with a 3-minute period in between. And that is a severe tactical liability again. That initial surprise attack would probably get a ship or two. The Papa was very noisy, which was a problem for her, but the Americans didn't really have a counter to her, even though we could hear her coming a mile away. She was so fast by the time we got over to her and was dropping sonar buoys on her from airplanes and helicopters. She was simply moving out of the field, out of the sonar buoy field. We could keep up we could track her with our submarines, but we could not keep up with her. So we could watch her run away for miles and miles, but we couldn't keep up with her. We'd have to hand her off to another unit. So she was very tactically impressive. And a fleet, like I said, of Papa SSGNs would have changed the nature of the Cold War. I stand by that statement. Thank goodness they didn't build more. Welcome to the Oscar SSGN Subbrief, Project 949. All right, our story begins in 1969 when studies began circulating around the Central Research Institute of USSR Ministry of Defense, another one of those great bureaucratic names I love from the old Soviet Union. And these studies were referring to a project or an idea of a carrier of anti-ship cruise missiles. So at this time, we're thinking, well, the Slava class has a lot of missiles. The Kirov obviously is huge. They even have Kiev, which they have cruise missiles on an aircraft carrier. So what is this carrier of anti-ship cruise missiles? Are they just going to build a ship full of these? And then alongside these studies, it was mentioned a 3rd generation SSGN. And this got everyone's attention over in the West. This carrier of anti-ship cruise missiles was going to be submerged. That is insane. And the Russians are the perfect people to try and do this because they come up with new ideas all the time and make them work. These studies referred to defeating an American nuclear carrier group with a salvo of 20 to 24 supersonic anti-ship cruise missiles. And up to this point, the most that we had seen coming out of the Soviet Union was 12. Between 6 and 12 cruise missiles on their Echoes, and the Charlie had some SSGN capabilities. But we're talking something significantly larger here with 24 cruise missiles on one platform. So these technical documents are rotating around the halls of knowledge, basically. And in 1969, they finally come along with a technical task, which is kind of the next step in this process, to build a heavy submarine cruiser around this new Granite missile system, which is another project that's happening concurrently. So they want to take this missile that West is calling the Granite, and they're going to put it on this new submerged cruiser. They begin building shore-based test facilities for this Granite missile in 1969 and begin testing it. In 1970, the Ministry of Defense Resolution Project 949 is authorized. This officially gives the project its name and its funding, and it's going to be built in the 1970s, from 71 to 1980. It's led by P. Postentsev, and I messed that up, but that's his picture right there. He's the chief designer of the Granite missile system. So the guy that's making the missile system is now also in charge of making the delivery platform, which is going to be this submerged, large, anti-ship cruise missile platform that doesn't even have a name yet, but he's the guy in charge. He's making the weapon and he's making the launch platform. 1971, his staff goes over 100 different designs. They're thinking inside the box, outside the box. They're making new boxes. They have so many different ideas. And finally, the Presidium of Scientific and Technical Council of the Ministry of Industry of the USSR, another great name, chooses to design. They narrow it down to 2 ideas in 1971. And by 1972, this is what they chose. This is just a sketch of the technical drawing. This is what it was approved in 1972, and 3 years later, the keel is laid in Workshop 55 of Sevmas Shipyard. NATO name at this time is called Baton, based on the size and shape of the thing. They just call it a baton because we don't know what it's going to be yet until they finally decide on calling it the Oscar. Project 949 Oscar 1 ran from 1975 to 1976. And this is just the first step in a series of Oscars that have come down through the decades. So Oscar 1 had two hulls from 1975 to 1976, laid down in 1975, named Archangels, and was later renamed at its commissioning in 1980, or launching rather, of 1980, the Minsky Kosmolets. So the Russians do this a lot, and it can be confusing, is they change the names of their submarines and their ships regularly. And so what is the name of the ship one year may not be the same name of the ship, but it's still the same ship in following years. And that's the case here for Hull 1. Hull 2, K206, is the Murmansk. That keel was laid in 1979 and launched in 1982. And you can see I have the red pin there on where the shipyard is at. Okay, Oscar 1 specification. She's 143 meters long and 18 meters wide. And that ratio is very thick, width to length. You know, she is running around like a big old rectangle, pushing the water out of the way as she moves through the ocean. She doesn't really sail like a typical ship where she cuts through the water. She, bulges her way through the water. But she displaces 22,000 tons, which is huge. That is like 3 688s roughly. It's 3 times the size of the fast attack submarines we're running at the same time here. But she can get up to speeds of greater than 30 knots. Okay, they're taking 22,000 tons of displacement and pushing it at 30 some knots. And they're doing that with 2 pressurized water reactors that are turning different screw blades at different times, but either a tandem 4-bladed screw, which is what they began with. They later went to 2 5-bladed screws to give her more speed. But she didn't just have one screw blade configuration for her whole life. Different hulls had different screw blade configurations at different times, and they changed. They were never consistent. So just know that she had a tandem 4 and a 5-blader, like you see here in the picture. Those are 2 5s, and you'd be right. Unclassified test depth is 600 meters, but I'm here to tell you it's a lot deeper than that. She has approximately 130 crewmen. The Soviets and now the Russians continue to put a lot of automation into their submarines. So they can operate these submarines with much less crewmen than Western submarines do that have less automation. So I've seen estimates as low as 96 crewmen, but officially they have approximately 130 crewmen on these. She shoots 24 SSN-19 shipwreck missiles. That's the P700 Granite. She has 4 53-centimeter torpedoes that can shoot the SSN-15 Starfish, which is basically a 40-centimeter torpedo mounted on a 53-centimeter rocket that then flies up in the air, goes a measured distance of, say 10, 15,000 yards, and then drops down again. It can even go farther than that. The 2 65-centimeter torpedo tubes shoot the SSN-16 Stallion, which is the same 40-centimeter torpedo mounted on a 65-centimeter rocket, which does the same thing but can go a lot farther because it's got a larger motor. Really cool. And they can shoot torpedoes out of those, of course, as well. But the Starfish and the Stallion give them a great standoff range. All right, so Oscar class sensors, this is kind of a general overview of the whole thing. We'll go over specific differences later on. But for now, let's start with the Snoop pair or Snoop half surface radar. That's just your typical surface search navigation radar. Rim hat ESM, because it looks like a little hat when it's raised up. It receives radars and whatnot, can tell them who's out there searching. Shark gill sonar, mainframe sonar. It's a very modern sonar for the 80s, most modern that they have. Mouse roar, special pulse sonar. This is a special thing that I got to kind of dance around here. But mouse roar is designed to actively transmit sonar in a special pulse that is very hard to detect. So the idea is that they could go around the ocean transmitting active sonar with this mouse roar, and the Americans would never hear it because it is a special pulse. And I'm sorry, I cannot go into what the special pulse is, but let me tell you that this is scary. If you hear mouse roar, like for real, it'll get your attention because you're like, they're out here hunting us, because they believe that we can't hear the mouse roar. Okay, and then the Palladium towed array is a tactical towed array, much like the TB-16. It's like a very early version of the TB-16. It's very rudiment, but it gets the job done. It's a towed array, linear array towed behind them. All right, double hull construction. Like a lot of Soviet and Russian submarines, they have twin hulls. This hull uses AK-33 steel, codenamed Prometheus, It is 68 millimeters thick, which is 2.5 inches, and there are 2 hulls of this. So it is really thick. I mean, compared to American submarines, this is so thick. It's unbelievable. But she has got a very thick hull, and she has 2 of them. Inside this very thick hull, she's got 10 internal watertight compartments where the crew can, move from one to another, and they do. She also has a reinforced sail rudder topside designed to punch through the ice, but she cannot shoot her missiles through the ice, but she can surface through the ice. And there's even a little door on the sail where the crew can get out and walk on the ice if they wanted to. She is under ice capable is the point. All right, so here's a picture of the missile that we've been talking about, the AK-45 Granite, known in the West as the Shipwreck, and it's very well named because, as you can see, it's a fat, powerful missile. In the case of the Oscar, she's launched at a 45-degree angle, facing towards the direction of fire. The tube is flooded before launch. She is a wet-launched weapon. The launch can be submerged. She has an unclassified range of 550 kilometers, but it's a little bit longer than that. And these missiles are special. The guy that came up with this missile was brilliant, and my hat's off to him. He's very, very smart, his whole team. These missiles do a very early version of missile-to-missile communication, and they are launched in salvos. They're designed to be launched in salvos, and the missiles know this. So after they're launched and they do their spin up and they're on their course, they ping each other to see how many there are. This is all autonomous. They then choose one missile to get up off the seafloor because these are sea skimming missiles. This is a supersonic missile flying feet up over the water. It's hauling butt. And it's very low to the ground. But because of that, they can't see much with their radars in their nose. So they pick one missile to go up high. 1,000, 2,000, however many thousand feet, doesn't really matter. But that one missile is like the outlook. He looks for the target at the pre-designated point. Once he gets the radar picture, he can identify, the missile autonomously can identify large ships from small ships. And then it can choose based on whatever parameters it was set at launch to either target the small ships first with the missiles that are in the front of the pack, and then target the larger ships with the second wave, if you will, of the salvo, or vice versa. It has target discriminatory capabilities that are completely autonomous based on pre-flight programming parameters. Very, very advanced for the 1980s. This is incredible. I can't even compare it to American missiles because that would be probably crossing some lines that I don't want to cross. But this is very good. It's fast, it's deadly, and it works as a team. Okay, the Oscar I operations in 1982, 1996. I can personally vouch for some of these areas because we were able to track them during certain times. Let's see, headquarters. Their headquarters at this time, all out of the Northern Fleet, which is the Kola Peninsula. That's that little peninsula to the west of the Red Pin where they're built. There's several naval bases up there, and together those collection of naval bases are known as the Northern Fleet. She operates primarily in the Barents Sea because it's convenient, it's close. She's basically she's a test platform for future Oscars, because right from the very beginning, there were some shortcomings that they identified, even during construction. They're like, okay, we should probably change this and that in the future. So a lot of times they just go out to the Barents Sea, they do some testing, surfacing and divings, maybe some weapons test and pull right back in. 90%, if I had to pull a number out of the air, I would say 90% of the operations are in the Barents. Then they go into the Norwegian Sea a little more often, or less often, I should say. And then there was a few patrols or missions, if you want to call them that, down to the North Atlantic, because her operational design was to go to the North Atlantic and intercept those carrier groups and destroy them. So they did venture into the North Atlantic. It just wasn't very often. They had a lot to learn with this Oscar because it was such an ambitious, out-of-the-box design that they spent a lot of the time with the Oscar 1s, that's the first 2 hulls, doing a lot of at-sea testing in relatively shallow water of the Barents. It's also easily protected by, the Soviet fleet, where they can do their test in privacy, or they think they're not being tracked. And so it was very convenient for them. Most of the stuff happened in the Barents. So some design characteristics that they found right away, one that was kind of a surprise, at least in the West, is she's very slow to dive. She opens up her ballast tanks to dive. They fill with water, and she just barely goes down. They have to bring on extra pumps to pump water into the variable ballast tanks inside the Oscar to give it more negative buoyancy to make it dive a little bit faster. So from a naval architecture point of view, the ballasting wasn't quite right for the Oscar 1. Also, return radius was really wide. I mean, you have an 18 meter to 150 meter ratio. That thing is like a building, and you're trying to turn it in the ocean. So she doesn't turn very well. She needs a lot of help, especially coming in and out of port. I mean, she's got tugs all over her pushing her around. So these are some of the things that they identified at sea and they wanted to fix with the next generation of Oscars, Project 949 Alpha. Upgrades begin in 1982. Some of the things that they're addressing is better equipment locations. They want to place the equipment inside the sub in a more efficient manner so there's more room for the crew and maybe more equipment. The ballasting issue is addressed through, naval architecture and math. Sound silencing, they add a lot of sound silencing to this new project. These new boats are significantly quieter than hulls 1 and 2. They did go with a 7-bladed screw, which they stayed with that choice from this point on as a fleet. Submarines from now on coming out of Russia will have a 7-bladed screw. If they're serving Russia, the ones that they sell to other countries may not have it. But the Oscars 949 Alpha, 7-bladed screws, 2 of them. They also have the crew escape capsule, which they have a public number of 110 crew can fit inside. I'm sure they can fit the entire crew inside if it was an emergency, though. All right, so here is Oscar 2 949 Alpha. The interior compartments there, you can see them. Oh, sorry about that. Anyway, construction between 1985 and 1999. Jeez. Sorry, that threw me off, guys. 154 meters long. She's a little bit longer than Oscar 1. She has another compartment, we believe. We believe that she has 10 compartments now. That 10th compartment is in the rear end, past compartment 9 there, and it houses the electric motors that can help the submarine turn and whatnot. She displaces even more weight now, 24,000 tons, because of this extra compartment, 11 more meters of steel, and all that weight displaces a total of 24,000 tons. They're planning on building 11 hulls, and they do. That goal is achieved. 7 are in the Northern Fleet at time of planning. This is going back to when they're actually doing this, 1985 to 1990. And 4 are eventually shipped over to the Pacific Fleet. We'll talk about that in a minute. To give you an idea of how quiet they are, instead of giving you a decibel number like I have been doing, I'm just going to compare it to another submarine. She is as quiet as the improved Akula when the improved Akulas were operational. So very quiet whenever she comes out of this initial sea trials. We had a hard time tracking her. She quickly identified noise offenders during sea trials so that whenever she was operational, she was extremely quiet. This is a very good submarine, the Oscar II. They did a great job with this one. They're getting better as a nation, identifying sound shorts and fixing them. And that's a great concern to us because we kind of are, as a West, from a NATO point of view, we like them being noisy. And whenever they're starting to fix their noise sound shorts, it makes us nervous. And they're getting better at it with this project. All right, so here's the 11 that they built. I'm not going to read all their names, but we will kind of go over some of these because there's an interesting timeline with a lot of these right here. But there they are. You can pause this video if you need to, but we're going to move on. Okay, the operations of the Oscar II. We'll start in 1991. K-173 and 142 are moved to the Pacific Fleet, and 2 years later they are joined with K-420 and K-456. So those are your 4 Pacific Fleet, almost said Kursk, Pacific Fleet Oscar IIs over there. In 1996, K-132 and K-456 come together in some war games, and they both shoot Granite missiles submerged, demonstrating the capability of teamwork, and they could shoot the same target with as many as 48 of these supersonic anti-ship missiles. This is a capability unlike anything we've seen from Russia before. For a submerged launch is a surprise attack that can happen 100 miles away. It can happen, less than that. There's no telling when these missiles will come out of the water at you in extreme numbers. And the idea is to overwhelm the American air defense. And they believe that with these tactics, they can do that. In 2011, it is planned that the Oscar II will receive the Onyx and the Caliber missile capability. These are the improved missiles that will be launched from the Onyx is from the missile launchers on the sides, and the Caliber is a 53 centimeter torpedo size cruise missile. Think of it like a Tomahawk. It's similar in capability to the Tomahawk. 2013, the K-266 and K-119 launched the Granite missiles again as a team as well, working together. So they're practicing this capability of not just one Oscar attacking one fleet, multiple Oscars working together, simultaneous launching, overwhelming, and air defense. And they're getting better at it. Now, these Northern Fleet exercises continue a year after year. They're done in the early or late spring, early summertime, and they're usually done in the Barents Sea. But as you can see, in 2018, they were done in the Norwegian Sea. The Russians of today are much more capable and much more confident in their ability to project their power and conduct their exercises, closer and closer to NATO allies. All right, let's talk about the Kursk tragedy real quick. See, 12th of August, year 2000, operating in the Northern Fleet annual war games, like we had talked about. 2000 was a large war game here, over 30 ships, when suddenly two explosions that happen almost simultaneously are heard on sonars, around the world, quite literally, because our SOSA system picked it up in the Atlantic. If I can talk about the explosions, the first one is a relatively small explosion that immediately ignites a large secondary explosion. And what we think that is an explosion in the torpedo room of one weapon, causing a sympathetic explosion of every other weapon in the torpedo room. And if you can imagine that, it is just a huge explosion. I mean, the shockwave alone from this must have concussed the entire crew, including, obviously killing a lot of them as well. So the Kursk immediately is submerged when this happens and immediately sinks. She's in she's only in 330 feet of water, and she's 500 plus feet long. So if you were to stand her on end, a lot of the submarine would be sticking out of the water. That gives you an idea of how relatively shallow this is. We hear, and we have recordings of this, after the explosion, the reactor pumps are methodically shut down. Someone is operating the reactor after the incident. The Northern Fleet locate the Kursk because they're working together. They're already right there doing a war game, and they take station overhead. So nobody else is allowed or can get any closer without being counter detected at this point. But we hear on our sonar systems metallic hammering coming from the Kursk. And we're like, obviously there's some survivors there because they're trying to communicate in the only means that you can do at this point, and that's by taking a metal object and pounding it on the metal hull. So the next day, the 13th of August, the hammering stops, and that's very ominous for everybody because we think that that's the day that the rest of the crew may have run out of air. Again, at this point, nobody knows even what caused this. There's a lot of confusion, but everybody, including the NATO people, we all want to get in there and help them save this crew. But for right now, Russia's like, no, we got this. And on the 14th of August, they announced that they have rescue craft named Kolokol is feeding power and oxygen to the Kursk. This turns out to be propaganda. And in my opinion, I think it's just a lie. They just made that up. There was rescue craft overhead, but they were not connected to anything. And what they did the following day from the rescue craft, this is a Russian rescue craft, by the way, not Norwegian or any other nation. They send down the equivalent of a diving bell, which is designed to dock with the, escape trunks or hatches rather of these Soviet submarines. But because of the sea state is so high, they can't get a good seal, and they try for 2 days and they just can't get it to dock. And then, almost a week later, the chief of staff of the Russian Northern Fleet, Mikhail Mostak, announces that the Kursk is flooded, the crew is dead, there are no survivors. But we have evidence. When I say we, I mean NATO recordings that I have seen myself of the Kursk survivors hammering on the hull, and the explosion for a day and a half after the event. It's very sad. All right, some other Oscar II mishaps. Doesn't stop with the Kursk in the year 2000. In 2001, K-119 undergoes a 2-year dry dock period. This is completely unscheduled. We're not sure what happened, but we do know that her port shaft begins making a lot of noise. There's something happened to the port side of that engine room. It was unlikely to be a collision or anything, but it could have been lack of maintenance. It could have been some kind of over throttle, over stress, but something stressed the port side of the drivetrain to the point that it was immediately noticeable. Like every time I went to see it, made so much noise. There was like no point in even submerging because you could hear K119 for miles and miles. There was something wrong with the port side. So whenever she did go to sea, you would see her running around on one screw a lot of the times, the starboard side only. And that's how she operated when she was at sea, which was not often. So they finally, after she comes out of, dock and does some sea trials, she goes back into dock in 2006 for what they call emergency repairs to the port main turbine. So they're finally going to do that. And in order to do that, they have to rip the whole engine room apart practically. And they go ahead and they refuel her while they're doing that, since they have her in dry dock for a long period of time. She's then sent back to sea trials a couple years later, like 2008. And she has some other problems that I'm not even sure of what they are, but she has to be dry docked a third time in 2009 for technical readiness restoration, which tells us over here in the West that she was never tactically ready since 2001, and maybe even longer than that. K119, every class of ship has kind of a black sheep of the family, and this is kind of that ship. Out of all the Oscar IIs, K119 is the unlucky ship. And speaking of unlucky ships, they had a lot of fires recently, 2013, 14, 15, K150. These Oscars are going through their midlife upgrades at this point, or just regular maintenance that require dry docking, and they're catching on fire. So 150 had a fire, 2014, 148 had a fire. Now, K148 was already decommissioned, so they didn't lose any operational capability there, but still, a fire at any point is not good. And then K266 catches fire pierside, and that's a little bit important because she was actually going through her modernization to Project 949AM. So let's talk about Project 949AM. There's a caveat here. Right now, there's 3 hulls planned. They probably are going to do more, but right now I can give you 3 names that they're going to upgrade from 949A to the modernization package. The first is K132, and that's already done. She is good to go. She had a delay in 2017, but it's been 2 years, and she's operational now. And what this does, the big improvement here, is the launchers that are on the port and starboard side, those 24 missile tubes, shoot the new ANCS anti-ship missile. And we saw in Syria, 2016, I think it was, that this ANCS missile does have land attack capability, which kind of took everybody off guard. The ANCS is designed to be an anti-ship missile, but they shot it over Syria, so it hit something over there. Also, the Caliber missile we saw in Syria, it's a Tomahawk ski, we call it, Tomahawk capable missile. Obviously, it's a land attack missile. There is probably a anti-ship version of the Caliber, but we just haven't seen that yet. If you can attack a land target with a missile, you can easily modify it to attack a ship as well. So it has the ANCS for the launchers that go up and down the sides, and the Caliber missile comes out of the 53 centimeter torpedo tubes in the front. And she can ripple fire these torpedo tubes now. So she can launch the Calibers one after the other, as she's also shooting the ANCS missiles, or Onyx missiles, from her port and starboard sides. A big capability. It's a huge boost. This project was paid for and commissioned in 2012. Modernization began immediately. One of the nice things that they added was a camera for the crew in the escape pod. So if they ever do need to use the escape pod, as they bob around waiting for rescue, they can at least see the surface. That gives them peace of mind. It's a big morale booster adding that. I think that was a concession for what happened to the Curse. They're like, give the guys something, and this is what they gave them. Propulsion systems are identical to the Oscar II. That's 90% true. I'll go over that at the end. They added bow thrusters. I wasn't able to find a picture for you, but they have bow thrusters now on the front to help its maneuvering at low speeds. It's a 6-bladed bow thruster. I'm sure it's really noisy. It's only going to be used to operate import. I don't think they would ever use it at sea. The torpedo room holds 28 weapons. It could be 28 torpedoes. It could be 28 Caliber missiles. It can be a mixture of those in between, but just know that it holds 28 weapons in the tube, 24 missiles in the missile launchers along the sides. So a lot of weapons on this thing. Various systems are modernized. Oh yeah, they gutted the interior and gave new radios, new ship control systems. A lot of the electronics is all upgraded and brand new, and that's really what the M stands for, is modernization of the interior components. The reactor did receive a 30% cooling upgrade, so it can theoretically run at a higher temperature, and that would mean it's making more steam, but they still have the same turbine generators. So they're still making 190 megawatts, which is still, it's a lot of power. But just because they make more steam doesn't mean they can make more power. Now, that does mean that they can take more steam and move it to the main engines, which is how they turn the screw. But without upgrading the main engines to be able to handle more steam, they would not be able to do that reliably for a long period of time without breaking something. So the reactor has more cooling power. They can make more steam. They may not be able to use it. But another benefit of this is that it's a little bit safer. Running the reactor with more cooling is always good. So good for them for doing that. They did a lot of sound silencing changes and upgrades. These things are even quieter than the improved Akula, in my opinion, at this point. And as long as they maintain them, they will stay very quiet. And that's the key. Historically, Russian submarines, after 18 months, that seems to be the magic number, become noisy again. And just, once it's a year and a half old without a refit, it's going to be easier to detect. But that first 18 months is scary because these things are like shadows. Very, very quiet. Okay, so of the three planned, we have the K-132 is operational. K-442 is not confirmed to be operational yet. I couldn't find any confirmation. And K-266 is one of those submarines that had a fire in the shipyard. That was in 2015, and it delayed this upgrade so much that it's still not done. So that fire was significant. They're moving on with the modernization. They haven't stopped, but it's not finished yet, 4 years later. All right, and here's kind of an extra for you guys. It is not an Oscar, but it is based on the Oscar hull. They took an Oscar II hull and modified it. It has its own project number, which means it's going to have its own lecture in the future, but I thought I'd bring it up now so that I don't get questions about this. The Belgorod is Project 985. It's 9852, technically. It's basically they took an unused Oscar II that they, I guess, we're not going to build for budget reasons or whatnot, and they modified it significantly. It's shorter than an Oscar II. It's narrower than Oscar II. Instead of being 18 meters wide, it's only 15 meters wide, and it's pier side right now. One of the capabilities that this thing has is it can shoot the Canyon nuclear power autonomous torpedo. This is what a lot of the media call the doomsday weapon. It is a nuclear powered, long range, autonomously driven by itself nuclear weapon that can go anywhere in the world that there's an ocean and detonate. And the idea is to, cause a tsunami essentially and wipe out a coastal city and port facilities and whatnot with this weapon. This can also be a dirty bomb if they use cobalt instead of uranium in the warhead, which can be done. It's unlikely that will ever be done. But if they use cobalt, that would significantly contaminate the region of the explosion for greater than 100 years easily. And it's going to be much more than that. So this can be a very, very nasty weapon. So the Belgorod will get its own lecture in the future when we know more about it. But know that this did use originally an Oscar II hull. And as soon as we can find out more, we'll talk more about it. All right. Welcome to USS Nautilus Subbrief, SSN 571. Our story begins in 1900. Hyman G. Rickover is born in Russian Poland to a couple Jewish parents who then immigrate to America in 1905. Hyman G. Rickover is considered the father of the nuclear navy and also the cog, the kindly old gentleman. He had a couple negative nicknames in the Navy, but we won't go over those. He was simply referred to as the cog later in his life. He did well in school after he immigrated to America and managed to get a place in our Naval Academy, and he graduated the Naval Academy in 1922. His work ethic and study habits as a student were recognized, and he was recommended to the CO as a junior officer on board the USS Nevada, a battleship, in 1923, where he served a full tour as a junior officer. Got to know the CO very well, and that would come back to help him out in his career later on. From the USS Nevada, Rickover went to postgraduate school at Columbia University, where he got his engineering degree. So he's a very intelligent, meticulous, math-orientated person. And he sees, as he has experience on the Nevada on a big ship, a battleship, he sees a lot of officers are being promoted quickly on smaller ships and on submarines. So in 1929, he volunteers for submarine duty. But at this time, he's 29 years old and he's too old to volunteer for submarine service. So what he does is he goes back to his old CO of the USS Nevada and asks him to make an exception to kind of speak up or vouch for him so that he can qualify in submarines and, eventually serve on submarines. And so the CO of the Nevada, who's moved on as himself, does that for him. And so while Hyman Rickover is working at the Office of the Inspector of Naval Material in Philadelphia, Pennsylvania, in 1929, he's also going up to Groton, Connecticut, a couple hours away, and he's qualifying on submarines on S8, on one of the diesel boats up there, and then he qualifies as submarine command on another submarine and is finished with that inside of about 4 years. 1933, he is qualified in submarines and submarine command. During this time, not only is he the Office of Inspector Naval Museum, he translates the Germans' Das Unterseeboot book, which became required reading for the United States Navy submarine force. It's basically a book about how to operate diesel boats. He translates that from German to English, and this is before World War II. Okay, so in recognition of his work ethic and everything that he's doing, he is awarded command. He is Captain Rickover at this point, and he is commander of the Finch in the Pacific. It's a minesweeper in 1937. Well, Captain Rickover quickly realizes that he's not built to be a CO. He only lasts about 3 months on board this minesweeper, dealing with day-to-day life on a ship, managing a crew and a wardroom and navigation and all the other things that are involved in managing a ship at sea. He doesn't like doing any of that. He's not very good at it. He volunteers after only 3 months on board as the captain to become an engineering duty officer, an EDO. And this is a major career shift for anybody in the Navy at that time. If you volunteer for engineering duty officer, you're essentially taking out of the command promotional hierarchy, and you're moved over to a more subordinate or a supply and support role. And so he's essentially saying, I don't want to be the captain of a ship anymore. I want to be on the repair, shipyard, engineering side of the Navy. He volunteers for engineering duty officer, and that is accepted. Then Commander Rickover works as the Bureau of Engineering in Washington, D.C., 1939. That's where he has his first EDO or engineering job, is in Washington, D.C. And this is significant because this is his first time being stationed in Washington, D.C., where he's meeting the people that outrank anybody in the military. And that's the senators. The senators and representatives of Congress are the people that he begins to hobnob with and get to know and make personal relationships with the people above and outside the chain of command of the Navy or any other service. And this, again, will come back to help him. Of course, in 1941, Japanese attack Pearl Harbor while he's working in Washington, D.C., and he's reassigned to the USS California out in Pearl Harbor to help facilitate the repairs on board that ship. He's kept out in Pearl Harbor for a couple years, even though he is eventually relieved on the California. He is then resupplying back to his engineering duty officer duties to the supply depot in Mechanicsburg, Pennsylvania, to investigate insufficiencies or inefficiencies of the supply chain coming out of that base. So he's there in 1944, but the World War is still raging on. He's seeing naval officers that have combat experience are being promoted over those who don't. So he wants to get involved in the invasion of Japan while he's working in Pennsylvania. So he volunteers and is assigned to the repair facility in Okinawa, where he helps begin prepare the U.S. Navy for the invasion of Japan, logistically, engineering-wise, getting all the ships ready, assembling them together in Okinawa, getting ready for the final push when this is finally cut short by the dropping of the nuclear weapons on Japan and the war ending. And this is a full and successful naval career for most people. This is where his naval career would end and he would transition to something else. But in this case, this is where our story begins. At the end of World War II, Commander, now Captain Rickover, has a full over 20-year experience he's an engineering duty officer, and he has a successful war career. In 1946, he is assigned to Oak Ridge, Tennessee, the Oak Ridge National Laboratory. This is the laboratory that is trying to turn nuclear energy into a civilian use for power generation. So he's assigned there with a very small team of officers, and they're not given very specific goals. But one thing that the Navy wants out of this is they want to learn how they can use nuclear energy to drive the propulsion on their destroyers. And if they can make it work at the destroyer level, the Navy plans on upscaling that to cruisers and eventually aircraft carriers. That's the Navy's big picture. And that's really the only guidelines he has at this time. But Rickover is a submarine officer, and he knows that they can push a submarine under the water with far less power than it takes to push even a destroyer across the surface of the water. So he, on his own, changes his own directives, his own goals, to be from creating a propulsion system for a destroyer to propulsion system for a submarine. And this vision is not shared by his admiralty above him, and they see it as him undercutting their authority, and it's viewed very negatively. So what they do whenever he informs him, or they find out through back channels what he's done, they pull him out of Tennessee, out of Oak Ridge, him and his team of officers, just a couple guys, less than 10. And they move him back to Washington, D.C., one where they can kind of keep an eye on this captain who's kind of going off and doing his own thing, not listening to orders. And they give him an advisory role. So he'll be the advisor for nuclear energy to the Navy in Washington, D.C., essentially snubbing him. They don't plan on listening to him. They're just going to let him sit in his office, collect a paycheck until he finally retires. All right, so where does he work in Washington, D.C.? In 1947, he works for the Bureau of Ships. They give him a small office in a corner with his staff, and they don't even bother really regularly communicating with him. They're just letting him sit there. But he's not having any of it. He's still doing the same job that he was in Tennessee, now in Washington, D.C., working late hours, trying to figure out how to make this propulsion work in a very confined space of a submarine. Well, the Bureau of Ships building is very strict because it works with sensitive material. They have strict work shifts that are 8 hours apiece. They have a day shift, an evening shift, and then an overnight shift. Well, he only has passes for him and his team to work during the day shift. So Captain Rickover, being a very, hardworking person that likes to work late, tells his team, screw the shifts. We're going to work late every night until we figure out how to make the submarine propulsion work with nuclear power. And they do this for a while without getting caught. And then finally, one night when they're leaving the building, they are caught by security. They're asked for their badges that say they're only supposed to work from, morning hours to evening hours. And they're being caught here, 8 or 9 o'clock at night, violating their own security. So this gets reported to the chain of command. Once again, this Captain Rickover is causing problems. He's not obeying, the rules that are set out for him. And what they do, instead of punishing him, because he's a full bird captain at this point, they move him to an abandoned ladies' room inside the building, kind of as punishment. They rip out, the toilets and the sinks, and it's this tiled room with just, a little slit of a window to let a little bit of natural light in. They move his desk, his chairs, his file cabinets all into this ladies' room, and that's where he'll serve in the Bureau of Ships until he decides he wants to retire. Again, they're trying to motivate him out of the Navy. They don't want him anymore. He's causing waves. He's not following rules. He's off doing his own projects instead of what he's told. This guy's a maverick. He's a rebel, and they don't like that. Okay, so he sends from the ladies' bathroom, he finally collects all the data that they have together, and they construct a proposal and send it to the Chief of Naval Operations, who is at that time Admiral Chester Nimitz. Now, one thing about Admiral Nimitz is that he's a submarine officer too. He's actually served on submarines. He's taken them underway. He's a very successful submarine career. And he's also now the lead Navy person on active duty for the Navy, the Chief of Naval Operations. He reports directly to the president, right? That's his job. So Captain Rickover writes up this proposal, goes directly to the CNO, circumventing the entire chain of command between his position and the Chief of Naval Operations with this proposal to build a nuclear submarine. Chester Nimitz reviews it, and it gets returned to Captain Rickover, signed and approved. He has an approved document saying build a nuclear submarine using the ideas that you've researched both in Oak Ridge, Tennessee, and here at the Bureau of Ships. And he takes that piece of paper and he's off and running. So where do we build the first nuclear submarine? Well, the first thing Captain Rickover does is he takes his signed C&O piece of paper to the Navy shipyards. He goes to, or talks to Mare Island and actually goes to Kittery, Maine, where the Portsmouth Naval Shipyard is. And the Portsmouth Naval Shipyards, they're like, we'll be happy to build your ship, but we already have a full schedule of construction that goes out 2 or 3 years. So we'll build it 4 years from now. And we're going to need funding for it as well. And Rickover's like, that's not going to work. We need this now. We have the technology, we have the plans. All we need to do is actually build it. But the Navy is so underfunded, understaffed, and backed up in the naval shipyards, he needs to look outside the naval shipyards. And so we had used some civilian contractors like Electric Boat to build submarines during World War II. And that's very close to Kittery, Maine. It's just down there in Connecticut. He decides to take a little trip down to Electric Boat and talk to the teams down there. And they look at his, his approved C&O letter and his plans, and they're like, we can build this. We can actually do this. We'll go forward with your project, Captain Rickover. And so they agree to do it, but then the Navy doesn't agree to fund it. This is just another way that they can stop Captain Rickover from doing his Maverick nuclear submarine idea. He didn't want to play the game and build the nuclear destroyers or research the proper power plants in Tennessee. The Navy's certainly not just going to shell out millions of dollars to build this crazy project that he's running away with on his own, going around chains of command, talking directly to the Chief of Naval Operations. They're not going to give him the money, even though he has a signed letter from the C&O. The Navy says that means nothing without dollars behind it. And so instead of going back to the C&O, Captain Rickover does the next best thing. He goes back to Washington, D.C., and he goes to his congressional friends. He actually speaks before Congress and explains to them the situation that we have this technology, we have this ability, we have a signed letter from the Chief of Naval Operations to build a nuclear submarine. We have a contractor that's ready to do it right there in Groton, Connecticut. And after listening to his pleas, the United States Congress does finally approve in July 1951 the construction of the first nuclear-powered submarine, not just in America, but in the world. And in June 1952, the U.S. Nautilus SSN 571 keel is laid at the Electric Boat shipyard before a crowd of about 10,000 people, lots of fanfare, lots of congressmen there because they helped pay for it. Do you know who is not invited by the Navy? Captain Rickover. Captain Rickover sits in his ladies' room bathroom office down there at the Bureau of Ships in Washington, D.C., and is not invited to the keel laying ceremony. And the press notices this. The congressmen notice this. And this becomes a big kerfuffle in 1952 that the father of the nuclear navy, the person that is pushing this single-handedly practically forward, isn't even invited by the Navy to the first keel laying of his own submarine project. Something else the Navy does, because they want to get rid of him, is they've passed him over for promotion to Rear Admiral 3 times. And back in 1952 and 53, the policy was, if you get passed over 3 times, you're no longer eligible for promotion, and that is your indication to get out of the Navy. You can't even become a Rear Admiral after that, after 3 times. That's the rule. So what he does is he tells Congress, look, I've been passed over 3 times. I can't continue on this project as it's beginning in the shipyard because they're going to kick me out of the Navy and I'll no longer be around. Who knows what's going to happen a couple of years from now whenever the ship is being constructed and there's no more money all of a sudden. So Congress steps in and they talk to the Secretary of the Navy. This is another civilian, but he's in charge of the Navy at the very top civilian side. And they hold what's called a special election board for a Rear Admiral. And these are very rare. They don't happen regularly, but they do happen. And so they hold a special election board looking at his career and everything he's accomplished. And they congressionally promote Captain Rickover to Rear Admiral Rickover, again, going around the Navy chain of command. And so it's just great to see this very determined guy hell-bent on getting his nuclear submarine approved and built, despite everybody working against him. Rear Admiral Rickover is an amazing individual, very determined, and a person to be respected and admired. All right, so in January 21st, 1954, the Nautilus is launched. First Lady Mamie Eisenhower launches it into the Thames River right there in Groton, Connecticut. Of course, sans Captain Rickover at the time. In September 1954, it's about 9 months later, the Nautilus is commissioned into the United States Navy, and the Navy learned from its mistake and invited then Rear Admiral or Admiral Rickover to the commissioning. He was there. The 4,000-ton displacement submarine is put out into the water. It is 320 feet long. It's 28 feet wide at its beam, that's side to side. It drafts about 26 feet and has a test depth of about 700 feet. It is refueled multiple times, but the actual reactor vessel itself is a Westinghouse S2W pressurized water reactor that produces about 13,400 horsepower. That turns 2 shafts, each at 5 blades apiece. Later on in its career, after some refits and overhauls and upgrades, she will get 2 7-bladed screws. But here in the beginning, she has 2 shafts, 5-bladed screws. With these configurations, she's able to transit at 22 knots on the surface, which is pretty good, and even a little bit faster underway at 25 knots submerged. Now, there is a small problem we're going to get into later that keeps her from really maintaining 25 knots for long periods of time, but she is capable of reaching that. Okay, she has 6 torpedo tubes. They're all in the bow, all forward facing, and they're 21-inch standard 53-centimeter torpedo tubes, which is the standard size for the U.S. Navy. And there's a crew of about 92 men and 13 officers that man this vessel. Underway on nuclear power, so here is the actual message sent from Captain Eugene Wilkinson, who was the first CO of the USS Nautilus. It says here, and I'll read from the message from USS Nautilus, SSN 571, to Com Sub Lant, that's Command Submarine Atlantic Fleet, underway on nuclear power, break transmission, which is the shortest, simplest message you could put out there that is so historic that this message is actually kept, you know, in the annals and museums of naval history. This is the moment that the first submarine vessel under nuclear power is underway. And it is at 11:33 Romeo, which is Eastern time, 11:33 Romeo, 17 January 1955. And that's the logo there to the 571. A little bit of history about the logo of the USS Nautilus is that it was designed by Disney artists. So that's a little bit of Disney work there. All right, so her first major transit from New London, Connecticut was to San Juan, Puerto Rico, and it took a record-shattering only 89.9 hours. That is the longest submerged cruise in history. She did that all in one step. It's also the fastest submerged cruise that was more than 1 hour. The fastest transit from New London to Puerto Rico of any surface or submerged vessel. She's faster than any surface ship that has done this same voyage, which granted may not be many, but it's still a record in the books. All right, so July, August 1955, she's finally getting into her, job for the Navy. She conducts wartime exercises in Narragansett Bay and off the coast of Bermuda. Narragansett Bay is the body of water that's south of New England, but kind of east of New Jersey. That body of water there, Narragansett Bay. That's a common operating space for United States submarines, and that's where she was doing her stuff. She demonstrated radical speed increases. They could change speeds quite quickly and get very fast compared to diesel boats. And her endurance had never been seen before by a diesel boat. She could stay submerged for the entire war game, which lasted days if they wanted to. So the ship is fast, capable of, coming in, conducting attack, and successfully evading at high speeds. So this is a whole new class of warfare. This is really getting the attention of the Admiralty now. Not that they're liking, Admiral Rickover anymore, but they do see what his vision was because they're actually seeing it in war games now, and the results are amazing. So the ship is fast and capable, but the USS Nautilus is noisy, and the bow shakes over 10 knots. So anytime she gets up to high speeds, she can't maintain those high speeds for long periods of time because of just, discomfort to the crew and crew fatigue, and also damaging equipment. It gets really, really bad at really high speeds. So they're going to go back and take a look at this and see what they can do to future designs and try to correct these. One of the things that they're going to do is go to an albacore shape hull, which is the modern shape of submarines today, which is that rounded shape you see in the movies. That's called an albacore shape. All right, so she receives repairs and sonar upgrades in December 1955 based on the findings of these war games that happened over the summer. In 1956, the very next year after these upgrades, she goes down to Key West, where she is undergone an in-serve inspection. That's an inspection and survey by the Department of the Navy. These are done regularly to every ship in the Navy, and every squadron in the Navy has to go through this. And the idea of an in-service inspection, or in-serve, is to determine any material failures or systemic failures of a specific ship or chain of command that does not get reported to the admiral. So these are the admiral's watchdogs, because they know it's human nature to try and hide problems until they're fixed. And the Navy will not accept that, especially whenever it comes to nuclear power. So they have these in-serve inspections that go on board every ship, whether it's nuclear or not, and they do very detailed, meticulous systems readiness checks. So they go through this in-service inspection. They pass it with flying colors, much to the credit of the shipyard building a very first nuclear submarine. And she is, for unrestricted service after this, after May 1956, she can go anywhere, do anything the Navy wants. So one of the first things they do is they go up and they refuel her. This nuclear reactor obviously is very small. It has limited life compared to modern reactors and gets refueled pretty regularly. So in February 1957, she goes back up to the shipyard for refuel. She returns to Electric Boat 2 months for nuclear refuel. This is the shipyard that built her. And then she returns to exercises in April. And I can finally, in an unclassified manner, talk about nuclear propulsion of a nuclear submarine. In this case, it's the Nautilus. This has been decommissioned, and this is an old design, but I can finally describe to you in an unclassified way how submarine nuclear reactors work. This is a first. Let's begin. Submarine nuclear reactors have two loops, a primary loop and a secondary loop. The primary loop, if you're watching this, is marked in red, and you have three major components. You have the reactor, the pressurizer, and the main coolant pump. And this circulates pure water around the reactor, obviously to keep the fuel cool, but makes the water, the pure water, extremely hot. Now, to keep the pure water from flashing to steam, it has to be pressurized. So that's what the pressurizer is for. And the reactor coolant pump is simply a circulation pump to keep the water moving over the fuel, keeping the water warm, and so forth. The only thing this primary loop does is go to the steam generator. Doesn't do anything else. That's all it does. And the water itself doesn't go to the steam generator. It is just piped inside pipes to the steam generator, as you see here. Now, the steam generator is part of the secondary loop. The secondary loop has water in it too, but the secondary loop and the primary loop water never mix, ever. They never touch each other. They only have contact via the piping that pipes in the primary into the steam generator. So the water from the steam generator gets flashed to steam, as the name would imply, and that steam races down pipes at high energy, at high speed and heat to two places: a turbine generator that makes electricity, and the main turbine that turns the screw of the submarine. From there, after it's lost a lot of its energy turning these turbines, it begins to cool down and lose its energy, lose its speed, and it's sent to what's called a main condenser. The main condenser absorbs the rest of the energy in the steam, condensing it back into liquid water at a relatively low temperature. This main condenser is cooled with seawater from outside the boat. Now, the secondary and the main seawater systems never mix. They never touch each other either, just like the steam generator never touches the primary, right? So there's no mixing of anything inside the ship's power plant that ever goes out to sea. in normal operations. So the seawater just comes in, it provides cooling, it goes back out again, and the steam becomes water and is pumped with what's called a feed pump back into the steam generator. And this is an unclassified description of how the USS Nautilus S2W reactor worked. All right, so after she gets refueled from May to July of 1957, she visits the West Coast. She goes through the Panama Canal, and she spends that summer seeing the cities of the West Coast: San Diego, Long Beach, Portland, Seattle, Tacoma, San Francisco, up and down the coast, doing kind of a goodwill tour. This is a great time for the crew because they get to see all these great cities. This is a big reason why people join the Navy, is to go see places that they wouldn't normally see. And so the crew are very happy. They're conducting tours. They open the ship up to representatives, elected congressmen, and also to the public, so they can show the American common person what the Navy has done. This is, at this time, 1957, the world's only nuclear submarine that is operational. And so it's quite an achievement, especially in the days of the 50s, when Russia was pulling ahead of us in the space program. They would eventually launch Sputnik, which is that little simple satellite that orbited the Earth. And so we were obviously falling behind in a space race. We had the USS Nautilus and this nuclear accomplishment to say, hey, we're doing this, and they're not doing it. So we're ahead, in this technology. And this was a big, PR, public relation, underway for them. They went over 3,000 miles and hosted over 13,000 visitors in just a few months, and really got the accomplishments of Rickover and the Navy out to the public here. So they're looking for more records to break, more things to do. And the president, the White House, comes up with this idea. Why don't we do, Arctic exploration and navigation? We can go under the ice now. We don't need to surface every day to recharge batteries. Why don't we go explore the Arctic? And so in 1957, they do the first Arctic Circle run. They know they're not going to go to the North Pole at this point. They just want to go to the Arctic Circle, and they want to test their systems. They get within 180 to 100 miles of the North Pole. And sure enough, their gyro compasses and their magnetic compasses are basically useless because they've been submerged for so long, and they're so close to the magnetic North Pole that it deviates from the geographic North Pole. And it's just kind of dangerous. You can get lost under the ice and not be able to navigate your way out. So they don't want to go, too far towards the North Pole until they have better equipment. So they come back from this first excursion into the Arctic area, and they get some equipment from the North American Aviation company. They get an N6A internal guidance system used on the Navajo cruise missile. And they want to use this navigation system, this inertial guidance. In other words, as the guidance device itself is physically moved, it maps where you are on the globe. Now, this inertial guidance is designed for cruise missiles, which fly for a short period of time, minutes, and go very fast. And they want to put it on a submarine that goes very slow and is underway for months. So there's some modifications they have to make to it to make it work, because in all inertial guidance systems, whether they're made in the 50s or even they're made today, they slowly get inaccurate over time. The longer you have them operating without a position fix to reset them back to their actual location, these mechanical and magnetic errors slowly make your position in this inertial navigation less and less accurate. So that is a concern, but it's really the best option they have at this point. And so they try a second attempt to go up to the Arctic, in North Pole this time with this new device. But they get up to the Chukchi Sea, which is just north of the Bering Sea, there between Alaska and Russia's Kamchatka Peninsula. And the ice is too thick. The Chukchi Sea is very shallow, and the ice goes almost all the way down to the bottom. Like, there's no room down there to safely navigate a submarine. It's not worth the risk. So they're going to go back to Pearl Harbor and try again later. So summer comes around, July 23rd, 1958, and they're going to try the same thing again, Operation Sunshine, from Pearl Harbor in the summertime. Sure enough, they get up there, they can submerge, no problem. The internal navigation works this time. It works enough for them to get to the North Pole, and they're able to transit from the Pacific to the Atlantic via the North Pole and pull into Portsmouth, England. They report Their position here in the chit you see to the right, if you're watching the visual side of this. And Commander William Anderson, who is now the new CO of the Nautilus at this time, this is the second CO, says, for the United States, let me quote this, for the USA and the U.S. Navy, Sunday, 3rd August 1958, 23:15 Eastern Daylight Savings Time, the North Pole. That's the announcement he makes over the 1MC to the crew. This is the navigation chit that they have recorded for history. And it's just a moment, another huge accomplishment for the first nuclear submarine to not only transit the Arctic Circle, but go right to the North Pole where they don't need a magnetic compass to help navigate back south again. And it was very hectic because the ice, even in the summertime up there, was very thick, getting very close to the floor of the Arctic Circle. But they managed to stay between their test depth of about 700 feet and still be able to go under the keels of ice that were coming down like little icy walls. A great accomplishment. So from here, after they pull into Portsmouth, England, they helicopter the CO over to Iceland, and from there he gets on a plane and goes to Washington, D.C., where he meets with the president, and the president gives them a presidential unit citation for him. And well, it's actually awarded to the ship, the president unit citation. But him and every crew member get to wear the ribbon on their uniform called a puck. And this is the first time a presidential unit citation has been awarded to a military vessel in peacetime. That's usually a wartime award, but this is such a significant accomplishment. They get a puck assigned to the ship. All right. May 1958, the next year, they go back to Portsmouth Naval Shipyard in Kittery, Maine, where they complete an overhaul and another refueling. So they're doing these refuelings like every 2 years. You know, those are not cheap. But what blows my mind here as a retired sailor myself is that they're doing these refuelings in about 4 months. These nuclear refuelings in today's Navy are 12, 18-month minimum projects. They can take even longer than that. Because of all the meticulous safety precautions that are necessary to do this in a safe manner. Because these systems are very complex and the equipment is very densely packed together, and you can't just cut a hole in a submarine and rip out the reactor and put a new one in like you're changing a AA battery. It's much more involved in that, of course. But the fact that they were doing this in 4 months blows my mind. They had no incidents. They had no problems. There was no reactor accident. So that's all to their credit that they were able to do it safely and quickly. The days of doing it this fast are long gone. All right. The next year, August 1960, she's got a fresh reactor ready to go serve the fleet. She is assigned to the 6th Fleet, which is headquartered out of the Mediterranean Sea. She spends about 4 years over there, steams over 200,000 miles over that time, sees all the major ports, all the NATO allies, showing off America's new nuclear submarine to other countries, saying, hey, look at what we got. Nobody else in the world has this. You know, we were the first, and look how good it is. And they're giving tours. They're taking representatives on short underways, diving them, surfacing them, showing them the capabilities. It's blowing minds around the world. America is a dominant naval force in 1960. As part of the war games, she also served outside of the Mediterranean. Just because she's headquartered there doesn't mean she stays inside that little body of water. She went out into the Atlantic and did war games off the coast of Bermuda, off the coast of Spain and France. And during these war games, she earns lots of awards like Battle Excellence Awards, which is a very prestigious award for a ship to get. The crews always try to get the Battle E Award every time they get a chance. They usually have a chance once a year to get one. And it's a big accomplishment if they do. And she also gets a Distinguished Service Medal, which is, that's great. So she's a highly decorated, highly capable ship, commanded by a crew that is very well trained and disciplined. So as she ages into the 60s and 70s, the Navy has already learned a little bit about her and are making improvements to the next generation of submarine, which is going to have the albacore hull and is called the skipjack class. And then there's essentially going to be the Permit class, which was part of the Thresher, onto the Sturgeon class in the 70s, and finally the 688 class in the 80s. So as these new systems, new submarines come online, she spends, the period of the 60s and 70s kind of as a research vessel. She goes back into that role of not necessarily breaking records anymore, but trying to improve on the equipment that they're using right now. So she is refueled once again in 1967. After the refueling, they do address a lot of the major design flaws. The bow is still noisy. It still vibrates, but they've addressed that by changing the shape of future submarines. They're not going to rebuild the Nautilus. They're going to just make better submarines in the future. In 1974 and 75, after only 7 years, she goes back for an overhaul in Electric Boat. That's the shipyard that built her initially in Groton, Connecticut. And there she begins a long period of testing and improving her systems. Through the 70s, 1975 to 1977, she sails over 35,000 miles. That's a lot of underway time. She goes to Scotland. She does war games in the Gulf of Mexico. She does war games with Canada off Halifax. She sails down to Puerto Rico a few times. She's putting a lot of miles on this reactor, conducting a lot of research, proving herself in war games, developing the tactics that the NATO nations will use to counter the Warsaw Pact threat. She is a big part of that development. As the Navy is actually making better submarines, she, through her research, are making those submarines better with equipment and tactics. So finally, in 1977, she does return to the Mediterranean. She gets an assignment to the Sixth Fleet there, where she does kind of a farewell tour. She does the rounds of the major ports again, meeting the NATO allies and other countries as well, showing off the capabilities of this aging nuclear submarine. At this point, she's historical. She was the first. People just want to see her anytime they get a chance. They do tours. They open the ship to the public while it's in port. They're taking some military NATO members underway to show the capabilities, just like they did years before. And it's just a great way to impress upon the world how capable nuclear submarines are. It's game-changing. It's a generational leap that unless somebody does the same thing, they'll never be able to compete with us in warfare at sea again. That's how significant this is. And so she does that and then returns back to the States, where she does her final voyage in 1979, where she goes again through the Panama Canal and goes to Mare Island Naval Shipyard, which is just a few miles north of San Francisco there. And there she's decommissioned the next year in 1980, after an almost over 25-year career. That has been fantastic. Her impression on naval history not only is well documented, it is incredible. It's amazing and well received. So normally this is where the subbrief would end, with the decommissioning of a submarine. But in this case, it doesn't end here. No, in 1982, only 2 years after her decommissioning, she's still in Mare Island, they make her, they being the United States, a National Historic Landmark for her impact on naval history. So she is now becoming a museum. So they spend about 3 years over in Mare Island, refurbishing her and making her ready for, becoming a tour vessel that will be permanently, tied to a pier, essentially literally welded to a pier and allowed civilians to come on. They do that for 3 years. And then they tow her back to Groton, Connecticut, the river that she was founded in. She's still there today. And she becomes the Submarine Force Museum on April 11th, 1986. Where she's open right now. You guys can go see the USS Nautilus there in Groton, Connecticut. She is within eyesight of the main highway, I-95, that runs through New England. So if you find yourself in New England or even in Connecticut, it is worth a trip. Definitely get on I-95, drive to Groton, Connecticut, get off on the Submarine Force Museum exit there, and you'll have yourself a good time. This is a good half-day visit. You can expect to spend 4 to 6 hours here. And the tour there is managed by some civilian and some active duty people as well. So they can tell you a lot of stories of real world experiences. And there's a lot more to see than just the Nautilus at this museum. It is truly a submarine force museum. But there you can see the USS Nautilus welded to the pier, ready for tour groups. I highly recommend you take time to see her. All right, well, that concludes the USS Nautilus SSN 571 subbrief. Thank you all for listening. I'll see you in the next one.